的笑就是一床的保护色。你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤就不肯往前的愈合。我赞成你的选择，你是看着眼泪飘飘泪两天天双双的走着，快乐，你的笑就是一床的保护色。你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤就不肯往前的愈合。我赞成你的选择，你是看着眼泪飘飘泪两天天双双的走着，快乐，你的笑就是一床的保护色。你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤就不肯往前的愈合。我赞成你的选择，你是看着眼泪飘飘泪两天天双双的走着，快乐，你的笑就是一床的保护色。你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤就不肯往前的愈合。我赞成你的选择，你是看着眼泪飘飘泪两天天双双的走着，快乐，你的笑就是一床的保护色。你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤就不肯往前的愈合。我赞成你的选择，你是看着眼泪飘飘泪两天天双双的走着，快乐，你的笑就是一床的保护色。你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤就不肯往前的愈合。我赞成你的选择，你是看着眼泪飘飘泪两天天双双的走着，快乐，你的笑就是一床的保护色。你决定不爱了，你决定不爱了，让那几个 是现在我的。你的山就不肯往前的余根，我站在你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑只是一场的保护色，你决定不爱了，你决定不爱了，让那情人是现在我的，你的山就不肯往前的余根，我站在你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑只是一场的保护色，你决定不爱了，你决定不爱了，让那情人是现在我的，你的山就不肯往前的余根，我站在你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑只是一场的保护色，你决定不爱了，你决定不爱了，让那情人是现在我的，你的山就不肯往前的余根，我站在你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑只是一场的保护色，你决定不爱了，你决定不爱了，让那情人是现在我的，你的山就不肯往前的余根，我站在你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑只是一场的保护色，你决定不爱了，你决定不爱了，让那情人是现在我的，你的山就不肯往前的余根，我站在你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑只是一场的保护色，你决定不爱了，你决定不爱了，让那情人是现在我的，你的山就不肯往前的余根，我站在你的选择，你是看着眼泪飘 现在我的，你的山就不肯往前的余根，我赞成你的选择，你是看着眼泪飘飘泪在跌跌撞撞的走着，快乐。笑就是一串的保护色，你决定不爱了，你决定不爱了，让那情人是现在我的，你的山就不肯往前的余根。我赞成你的选择，你是看着眼泪飘飘泪在跌跌撞撞的走着，快乐。你的笑就是一串的保护色，你决定不爱了，你决定不爱了。让那情人是现在我的，你的山就不肯往前的余根，我赞成你的选择，你是看着眼泪飘飘泪在跌跌撞撞的走着，快乐。笑就是一串的保护色，你决定不爱了，你决定不爱了，让那情人是现在我的，你的山就不肯往前的余根。我赞成你的选择，你是看着眼泪飘飘泪在跌跌撞撞的走着，快乐。你的笑就是一串的保护色，你决定不爱了，你决定不爱了。让那情人是现在我的，你的山就不肯往前的余根，我赞成你的选择，你是看着眼泪飘飘泪在跌跌撞撞的走着，快乐。笑就是一串的保护色，你决定不爱了，你决定不爱了，让那情人是现在我的，你的山就不肯往前的余根。我赞成你的选择，你是看着眼泪飘飘泪在跌跌撞撞的走着，快乐。你的笑就是一串的保护色，你决定不爱了，你决定不爱了。让那情人是现在我的，你的山就不肯往前的余根，我赞成你的选择，你是看着眼泪飘。 肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护伞，你决定不爱了，你决定不爱了，让那情人是谁让我的？你的山从不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护伞，你决定不爱了，你决定不爱了，让那情人是谁让我的？你的山从不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护伞，你决定不爱了，你决定不爱了，让那情人是谁让我的？你的山从不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护伞，你决定不爱了，你决定不爱了，让那情人是谁让我的？你的山从不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护伞，你决定不爱了，你决定不爱了，让那情人是谁让我的？你的山从不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护伞，你决定不爱了，你决定不爱了，让那情人是谁让我的？你的山从不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着， 穿个保护伞。你决定不爱了，你决定不爱了。让那几个时间淡化了。你的山中不肯往前的余根，我赞赏你的选择。你是看着眼泪飘飘来的跌跌撞撞的走着，快乐。你的笑就是你穿的保护伞。你决定不爱了，你决定不爱了。让那几个时间淡化了。你的山中不肯往前的余根，我赞赏你的选择。你是看着眼泪飘飘来的跌跌撞撞的走着，快乐。你的笑就是你穿的保护伞。你决定不爱了，你决定不爱了。让那几个时间淡化了。你的山中不肯往前的余根，我赞赏你的选择。你是看着眼泪飘飘来的跌跌撞撞的走着，快乐。你的笑就是你穿的保护伞。你决定不爱了，你决定不爱了。让那几个时间淡化了。你的山中不肯往前的余根，我赞赏你的选择。你是看着眼泪飘飘来的跌跌撞撞的走着，快乐。你的笑就是你穿的保护伞。你决定不爱了，你决定不爱了。让那几个时间淡化了。你的山中不肯往前的余根，我赞赏你的选择。你是看着眼泪飘飘来的跌跌撞撞的走着，快乐。你的笑就是你穿的保护伞。你决定不爱了，你决定不爱了。让那几个时间淡化了。你的山中不肯往前的余根，我赞赏你的选择。你是看着眼泪飘飘来的跌跌撞撞的走着，快乐。你的笑就是你穿的保护伞。你决定不爱了，你决定不爱了。让那几个时间淡化了。你的山中不肯往前的余根，我赞赏你的选择。你是看着眼泪飘飘来的跌跌撞撞的走着，快乐。你的笑就是你穿的保护伞。你决定不爱了，你决定不爱了。让那几个时间淡化了。 山就不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护色。决定不爱了，你决定不爱了，让那几个是真的我的，你的山就不肯往前的余额，我赞赏你的选择。你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护色。你决定不爱了，你决定不爱了，让那几个是真的我的，你的山就不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护色。你决定不爱了，你决定不爱了，让那几个是真的我的，你的山就不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护色。你决定不爱了，你决定不爱了，让那几个是真的我的，你的山就不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护色。你决定不爱了，你决定不爱了，让那几个是真的我的，你的山就不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护色。你决定不爱了，你决定不爱了，让那几个是真的我的，你的山就不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着， 的山中不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪在天地长长的走着，快乐，你的笑只是一场的保护色。决定不爱了，你决定不爱了，让那几个是真的我的，你的山中不肯往前的余额，我赞赏你的选择。你是看着眼泪飘飘泪在天地长长的走着，快乐，你的笑只是一场的保护色，你决定不爱了，你决定不爱了，让那几个是真的我的，你的山中不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪在天地长长的走着，快乐，你的笑只是一场的保护色，你决定不爱了，你决定不爱了，让那几个是真的我的，你的山中不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪在天地长长的走着，快乐，你的笑只是一场的保护色，你决定不爱了，你决定不爱了，让那几个是真的我的，你的山中不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪在天地长长的走着，快乐，你的笑只是一场的保护色，你决定不爱了，你决定不爱了，让那几个是真的我的，你的山中不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪。 长长的走着，快乐，你的笑只是一场的保护色，你决定不爱了，你决定不爱了，让那几个是真的我的。 你的山中不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪在天地长长的走着， 定不爱了。让那几个是真的我的，你的山中不肯完全的愈合，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐。你的笑就是一床的保护伞，你决定不爱了，你决定不爱了。让那几个是真的我的，你的山中不肯完全的愈合，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐。你的笑就是一床的保护伞，你决定不爱了，你决定不爱了。让那几个是真的我的，你的山中不肯完全的愈合，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐。你的笑就是一床的保护伞，你决定不爱了，你决定不爱了。让那几个是真的我的，你的山中不肯完全的愈合，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐。你的笑就是一床的保护伞，你决定不爱了，你决定不爱了。让那几个是真的我的，你的山中不肯完全的愈合，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐。你的笑就是一床的保护伞，你决定不爱了，你决定不爱了。让那几个是真的我的，你的山中不肯完全的愈合，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐。你的笑就是一床的保护伞，你决定不爱了，你决定不爱了。让那几个是真的我的，你的山中不肯完全的愈 的保护伞。你决定不爱了，你决定不爱了，让那几人是真的我的。你的山中不肯往前的余根，我站在你的选择，你是看着眼泪飘飘泪流，跌跌撞撞的走着，快乐，你的笑只是一双的保护伞。你决定不爱了，你决定不爱了，让那几人是真的我的。你的山中不肯往前的余根，我站在你的选择，你是看着眼泪飘飘泪流，跌跌撞撞的走着，快乐，你的笑只是一双的保护伞。你决定不爱了，你决定不爱了，让那几人是真的我的。你的山中不肯往前的余根，我站在你的选择，你是看着眼泪飘飘泪流，跌跌撞撞的走着，快乐，你的笑只是一双的保护伞。
Here we are going to learn the basics of a drone, including components and how the drone flies. Then we will look at the installations, basic movements, along with image capture. From there we will cover exciting projects including surveillance drone, face tracking, and line following. Don't worry, this course is for you, and we will focus on the implementation part so that you get the most practical experience out of it. Even though we are using a specific drone for this course, 80% of the material covered in this course can be used with any drone. If you would like to view more of such content, then don't forget to like and subscribe. So, let's explore. The term drone means a continuous low humming sound. Now this might not be the best way to represent these unmanned aerial vehicles, but still it's the most commonly used term. Drones have gained enormous popularity over the past few years as the technology has advanced and the motors have become cheaper. This has allowed the drones to be used in much more commercial sectors such as photography, filmmaking, surveillance, and even delivery systems. Despite this, drones have a long way to go. So learning how to program a drone to perform different tasks is becoming an increasingly popular skill. Drones come in different shapes and sizes. A popular term you might have heard is quadcopter. This refers to a drone with 4 propellers or more. Similarly, a hexacopter has 6 propellers. An octocopter has 8 propellers. So let's have a look at the main components of a drone. A drone will consist of frame, motors, propellers, electric motor controller, power distribution board, a flight controller, battery, receiver or Bluetooth, a camera, video transmitter, and some sensors. The flying board model is what boards can be contained. Most good drones use carbon fiber as the frame since it is quite lightweight and strong. Nowadays, non-DIY drones use wood and 3D printed frames as well. Motors can be considered as the engine of the system that creates the lift and allows the drone to fly. There are two main types of motors used in a drone: brushed and brushless. Brushed motors are simple and cheap, whereas brushless motors are expensive but have a better weight to operation. Propellers are what generate the lift force when the motors start rotating. There will be two types of propellers for any given. One that rotates clockwise and the other that rotates counterclockwise. This is because if all the propellers are rotating in the same direction, the drone will start rotating as well. But since we have half of them rotating in one direction and the other half rotating in the other direction, they can cancel each other out and the drone will start rotating. Propellers can have multiple pairs of blades. The more blades you have, the more thrust they will generate, but the more inefficient they get. The electric motor controller, or the ESC, is what controls the speed of the motors. They convert the DC signal from the battery to AC signal. You can have a separate ESC for each motor or a single board with multiple ESCs on it. Power distribution motors allow battery to power all the components, including the motors and the flight controller. The flight controller is the brain of the system, and it decides what should be the speed of the motors based on the input received from the sensors and the receiver. The battery will power all the components of the drone. This has to be light and efficient at the same time to allow maximum flight time. The receiver or the Bluetooth allows transmission of the signals between the remote and the drone. Most of the times, we also have a camera attached to the drone along with an SD card storage or even wireless transmission. Now, to transmit video, we need video transmitter. This device is responsible for the transmission of video through the internet to your cell phone or the There are multiple sensors attached to the drone. For example, the pressure sensor measures the altitude or the distance between the plane and the drone. The GPS indicates the position of the drone, whereas an IMU measures the acceleration and the angles at which the movement of the air seems quite complicated as it has 4 or more motors to enable the components, but in reality it's quite simple and intuitive. The drone can move with 4 degrees of freedom, which means it can translate in 3 directions and rotate in one. As mentioned earlier, 2 propellers from quadcopter rotate in the clockwise direction and the other 2 rotate in the counterclockwise direction. This generates zero angular momentum that allows the drone to stay stationary rather than rotating in one direction. Let's have a look at the translation movements. First, we run all the motors at the same speed that will generate the lift This will cause the drone to move up. This is the first translational movement. If we want to go down, we will decrease the speed of all motors so that the lift is less than the weight of the drone. If we want to hover in the air, we will change the speed of the motors so that the lift is equal to the weight of the drone. This will allow the drone to hover above the ground. Now coming to the second translation, if we want to move left, we will reduce the speed of the left motors and increase the speed of the right motors. To move towards the right, we will decrease the speed of the right motors and increase the speed of the left motors. Similarly, we can translate in the third direction, which is moving forwards and backwards. By decreasing the speed of the front motors and increasing the speed of the back motors, the drone will move forward. For moving So what can we do to actually find the coordinates when the forward button and the right or the left button? So we are rotating and we are also moving forward or moving backwards. So how can we do that? So by the way, the angular speed is pretty much the same way that we would calculate the distance. So here if you are moving, let's say for 2 seconds, so 45 degrees per second for 2 seconds will be 90 degrees. So that is so let's see how we can use this. So let's say we pressed the forward and we pressed the rotation button at the same time. So now the drone starts moving, but this time it will start rotating as well at the same time. So at the same time it's moving forward, at the same time it's turning. So it will start moving like this. So at the end of the day, it has moved, let's say 2 blocks, and then it has rotated 90 degrees. So how can we find these coordinates where it is now? I'm just assuming that it is here. But how can we actually find these coordinates? So what we can do is, let's assume that these coordinates are final point is over. So what happens is that this is our traveling distance. So this is basically it will be a curve. It will not be going forward and then rotating. It is happening at the same time. So how can we find that? Well, in this case, let's say this is our final point. This is after 1 second, and this is after 2 seconds. So let's say this is our curve. So what we will do is we will find the coordinates after every unit of time. So whatever distance we have kept constant, or whatever time period we have set. In this case, we have 1 second. So after 1 second, we will look at what is our position. So let's say it is here. So let's say that this position is over here. So then what we will do is we will find, first of all, we have the distance. So in the first interval our distance will be 10. After 1 second our distance will be 10. and our angle will be 45. So what we can do is we can write the equation where d is your distance, then d multiplied by the sine of 45. So d here will be the value of 10. So distance multiplied by cosine of 45, and then we will have the sine. So d here again will be 10. So this will be 10 multiplied by sine 45. So this will give us the y coordinate, and this will give us the x coordinate. So this way we will have the x and y coordinate. So the answer of this is about 7, and the answer of this is also 7. So this point will be 7 and 7. Right here. So after 1 second, this will be 100. So we can place this dot in our actual diagram. And then again, if we are moving with the same speed or the distance, and then we are moving at the same angle, then it will also have the same effect. So we will have 10 sine 45 and 10 cos 45. So this calculation we will do every single time after every block of unit that we have traveled. And then again we will have the same calculation, but this time we will add our previous value to it. So because earlier we had 0, 0, so we didn't use anything, but this time we will add to it. So it will be 7.07 plus 7.07. So that will give us 14.14. So this coordinate here will be 14.14 and then 14.14. So if we are moving at the speed of 10 meters per second, the angular speed of 45 degrees per second for 2 seconds, after 2 seconds will be at 14.14 and 14.14 in our Cartesian coordinates. So this way, after every unit of time, we can measure and we can pinpoint exactly where we will go. So this is what we are going to do. So let's have a look at how we can implement this mapping method. Let's say map. Okay, so the first thing we need to do, none of this is related to because we will be the ones controlling the boat, and when the drone is moving, so we will take keyboard control, copy all of it, and let's remove the other one, and we are going to paste it. So the first thing we have to do is write down. So as we have discussed earlier, we need the speed, and we also need the angular speed, and from that we will calculate the distance, and we will calculate how much angle do we have. Now first we are going to write the forward speed. Now the thing is that we already have the forward speed, the one that we have set. So for example, 50 centimeter per second. The thing is that when I experimented with it and tried to find out my own values to see if it's correct or not, a lot of the times the values differ. So the Teledrone is not very repeatable and it is not that accurate, but still we are trying to learn the concept, and based upon my testing I found out that if I move, for example, 10 seconds, I was getting a distance of 117. So 117 divided by 10, this is basically our speed. So I can write it here. Which is basically centimeter per second. So this is centimeter of travel, and this is how many seconds it traveled. So it traveled in 10 seconds, 117. And I was giving the speed of actually 15 centimeters per second. And you can see it's coming to about 11.7, around 12 centimeters. So again, doing some manual testing can help as well. And again, with the manual speed, I tested it at the A speed. Sorry, it took about 10 seconds to read 360 degrees. So I would second. So this will be our angular speed in degrees per second. Now in the example we took the interval as 1 second. So we were checking the value, we were plotting the value after 1 second. Now that is a very long time. We don't want to do that. We will use the interval to actually interval 0.25. So based on this information, now we have the speed and we have the interval. So every unit of our map will represent a certain amount of distance and a certain amount of angle. So that distance and angle we can find, we can write down distance interval equals to forward speed multiplied by is equal to a speed multiplied by interval. So this will give us the distance and the angle every time we move 1 unit. Okay, so these are basically our numbers. Now you can play around with these, you can try it yourself, you can time it, you can stop it, you can write actual code by yourself to test it yourself. These are the values that I have a little bit towards the better side. So again, this is not very accurate, so don't expect it to be very good. But the idea is that if you understand this concept and if you come across a better drone, then you can use the same technology to create a more accurate. Okay, so that being said, what we can do next is we can try to actually plot something to see how the OpenCV actually works. So in order to plot, we are going to create an image, create a black image. So we will call Now we haven't used NumPy before. It's basically a mathematical library that allows all these different mathematical or matrix relations. So we will say as use that. So image is basically a matrix of pixels, matrix of numbers. So that's why we can use the NumPy library, which is known for handling matrices. So we can use that to zeros. We want a matrix of by 1000. So the 3 is basically the channels, so we want it colored in. That's why we have RGB channels. And here we will say that the values that are stored in these matrices, they are basically unsigned integers. That's how we write unsigned integer, and it should be 8-bit. 8-bit means that we can have a value from reference to the power of 8, which is equals to 256. So therefore, the value will be 255. So these are the values that will be stored here. Okay, so that being said, let's draw something on it. Let's create a function called draw points. And these functions. So right now we will just do something simple. Let's just draw a circle. So CV2 dot circle.
的山就不肯完全的预感，我赞成你的选择。
So let's say
你是看着眼泪飘飘在天边光传的走着，
then we're going to say
快乐。
the next part is
你的
side.
笑就是遗忘的保护色，你决定不爱了，你决定不爱了。 是真的我的，
Let's try now. Yeah, there you go. So now it's
你的山就不肯完全的预感。
twist and
我
color.
赞成
So
你
we
的
make this,
选
let's
择。
say 20.
你是看着眼泪飘飘在天边光传的走着，
and 255. So it's BGR. In OpenCV, we don't use RGB, we use BGR. So this is blue, green, and red. Then we are going to say thickness of the film. So we will write here film. Okay, so we can do a little bit of formatting.
你的山就不肯完全的预感。我赞成你的选择。你是看着眼泪飘飘在天边光传的走着， 快乐。 你的笑却是遗忘的保护色，你决定不爱了，你决定不爱了。
So this is our output screen, and you can see the circle is drawn over here.
你的山就不肯完全的预感，我赞成你的选择。你是看着眼泪飘飘在天边光传的走着，
Then we can create our block button.
快乐。
So now what happens
你
is
的笑却是遗忘的保护色。
how far we have to go. So let's call this, these are our values. Let's call them x and y. So we will keep it very simple. We call them x and y. And y. Both of them are 500.
就不肯完全的预感。我赞成
So the idea is that at any given point we want to plot this x and y. So we can simply go here and say instead of this we can say y, we can say x. That's it. So if we want to plot, it should plot right in the middle. So this will be our starting point. And then whenever we press a key, this x and y value should change. So what kind of change we have to put here? So let's look at the left first. So what we will do is we will add to our distance, and then we have to add to our angle. So at any given instance, whenever we press the key, we have to check the angle and the distance. We have to update. So this is the final value in the x and y coordinate, but there should be another value which is basically the distance and the angle, and we will check every time what is happening in that. So the angle we will keep the same. So the angle should not be reset to 0 every time because it will continue to add on, but the distance we will reset every time. So we will write d equals 0 here inside and a equals 0 outside. Okay, so now we going to update this whenever we press a key. So for the left, we will update our interval. So we will make it equals to our DP. So normally, whenever we are traveling with this distance, but we are not traveling in the forward direction. We are traveling towards the west, so we have to change our angle. So we will put the angle as -180 degrees. Now for the right, we will copy this. For the right, we are going to change our angle, and the angle will be 180 degrees, and our distance will be then we will go to up. Now for up, our interval will be positive, but our angle will be towards north, it will be 270. For down, our angle, so this is not actually up and down, it is basically forward and backwards. So for that, we have to write that our angle is again negative, and then our angle is -90. Okay, so this is basically simple because we're just moving left, right, forward and backward. But when it comes to actual rotation, then it gets a little bit tricky. So we need to change the angle. So here what we will do is we will check our previous angle and we will add to it. So A will be that our yaw is equals to plus equals to our A internal. So it will not just be a new value, it will be added to our previous value. And in the other direction, so right here, minus A. Now we will be So after doing that, now we have updated all the values we need to update. Now we need to convert it into Cartesian coordinates. So here we are going to update our angle. So angle will be plus equals the yaw. And then we are going to get our x here. So finally, x is equals to actually plus equals to, we have to add it to our previous value. So we will write here integer, and then we will write the distance multiplied by the math radians, because this function actually uses radians, so we have this X and Y over here. Now it's already been set, it's already been updated, so we don't need to worry about the points, but we could actually write it here. From here we can say objects that we want to draw on, and we can set the points. So we can do this, but it should work automatically as well. But this is a better way to do it. So we can so let's try this.
不肯完全的预言，我站在你的选择，你是看着眼泪飘飘泪在天天长长的走着，快乐，你的笑就是一场的保护伞，你决定不爱了，你决定不爱了，让那几个是真的我的。 你的沙丘不肯完全的预言，我站在你的选择，你是看着眼泪飘飘泪在天天长长的。
So it is working, but there is an issue. What is the issue? Okay, so the first thing is that the button negative. So if the line is not accurate, then all of our information will be wrong. So we need to write here sleep, or I think sleep. So this has to be exactly the same as the interval. So we will copy it from here.
你的沙丘不肯完全的预言，
This has to be our
我站
interval.
在你的选
That fast
择。
as
你是看着眼泪飘飘泪在天天长长的走着，
so now it's much slower and it seems much better. You can see now it's rotating as well.
你的笑就
Like
是
this, so we can see.
一
But
场的
again, the
保护
problem is that we cannot see the map. So it's always printing this point. Then just put this point. We want all the points that have been plotted since. So what we can do is we can create
是真的我的。
points. We can
你的沙丘不肯完全的预言，我站在你的选择。
then we can go down.
你是看着眼泪飘飘泪在天天长长的走
Do is
着，
so we can say points
快乐。
and
你的笑就是一场的保护伞，你决定不爱了，
adding to the
你
points
决定不爱了， 让那几
is
个
here again we have to loop through these points and then we have to print them up or we have to draw them. So
你的沙丘不肯完全的预言，我站在你的选择。
we are going to
你是看着眼泪飘飘泪在天天长长的
so we
走
could simply
着，
write
快乐。你的笑就是一场的保护伞，你决定不爱了，你决定不爱了，让那几个是真的我的。 你的沙丘不肯完全的预言，我站 着你的选择，你是看着眼泪飘飘泪点点撞撞的走着。
forward button pressed. Now if I press D, you can see it's rotating. And if I press left, it's going left. If I press up, it's going up. And it will give us the estimate. So we can simply put X and Y, and that will be the coordinates, or that will be the distance.
不肯完全的预感，我站在你的选择，你是看着眼泪飘飘泪点点点撞撞的走着。快乐，你的笑就是隐藏的保护色。
So we will write points. The last one, so we will put this X at the very end. So we will take the last value and we will take the 0 and 500 because our starting position is 500, so we will subtract 500 and then divided by 100, so that we are giving the value in meters and not centimeters. And then we have to write the other one, so the other one will be pretty much the same. So paste it here, and we will write this one. And then at the end we are going to write meters. So this is basically the distance or the X and the Y coordinates printed out. But now we have to mention where do we actually want to put this. So we don't want to put it exactly on the same point. We want to shift it a little bit. So that's why we will write points. -1, 0. And we will add 10 to it so that it goes a little forward. And then copy this. Paste it here and this time let's say 2. So it is a little bit down. We will make this one. We can format this like that. So that should be good enough. Another issue that so this is supposed to be plus and this is supposed to be so that is one thing. Now another thing that we did in the previous keyboard control chapter is that we wrote a single value here, speed as but in this case we will have different angular speed and we will have different forward speed. So here we have to either we can write it here or we can change it down here. Let's keep this as speed. So we will keep it at 15 because that is the speed that I used for testing. And the angular speed I used was 50. So we can write vehicle speed equals to. So we don't need to change this, but we need to change this. Oh yeah, we can complete this.
的笑就是一双的保护伞。你决定不爱了，你决定不爱了。当那几个是真的我的。你的伤就不肯完成的预言，我赞成你的选择。你是看着眼泪飘飘泪的天天双双的走着，快乐。你的笑就是一双的保护伞。你决定不爱了，你决定不爱了。让那几个是真的我的。你的伤就不肯完全的愈合。我赞成你的选择。你是看着眼泪飘飘泪的天天双双的走着。
which means it is previous value
快乐。
or
你的笑就是一双的保护伞。你决定不爱了，你决定不爱了。
now this just makes sure that we are not plotting the same thing again and again.
你的伤就不肯完全的愈合。我赞成你的选择。你是看着眼泪飘飘泪的天天双双的走着。快乐。
This is out of range.
你的笑就是一双的保护伞。你决定不爱了，你决定不爱了。让那几个是真的我的。
So we can compare.
你的伤就不肯完全的愈合。我赞成你的选择。你是看着眼泪飘飘泪的天天双双的走着。快乐。
Okay. So now we have zero. So now we are getting the distance as well as the coordinates of the both directions as well as everything. I can see what is happening. So I can press these different keys.
的伤就不肯完全的愈合。我赞成你的选择。
Create another circle.
你是看着眼泪飘飘泪的天天双双的
I can change the color for each gene that's making good and let's make it so we will make it and we will use the last one.
就不肯完全的愈合。我赞成你的选择。
Estimation of
你是看着眼泪飘飘泪的天天双双
so now let's test it out on the actual board and see what happens.
快乐。你的笑只是一双的保护伞。你决定不爱了，你决定不爱了。让那几个是 真的让我的。你的山中不肯完全的预感，我站在你的选择，你是看着眼泪飘飘来的跌跌撞撞的走着，快乐，你的笑就是一方的保护色。
So we will look at how we can make our drone to track the So we will do it with face tracking, but later on we will implement it with So first of all, let's have a look at our drone. Now when we have to move the drone and we have to track our face, we need to do different things. We need the motion of forward and backward, and we need the motion of rotation. So we need yaw and forward and backwards. So let's have a look at forward and backwards first. So we will treat both of these individually and then we will combine the both. So let's have a look at the concept of forwards and backwards. So if the object or the face is looking small, then it means that it will move forward. And if the object or the face is looking quite big, then we need to move backwards. So we are too close to the drone. So if this is my drone, and this red area is where it is too close, and this red area is where it is too far. So both of them, the drone has to move. This green region is where you do not have to move at all. So let's say the person here, she moves back. So now the drone will have to compensate and it will move forward. So it will go up to that green zone and then it will stop. Now let's say she moves forward. Then the drone will have to counter the movement by going back, and it has to go back until it reaches the green zone. So this is the idea that there will be a green zone in which the drone will not move, it will be still there, and if it's too close, it will go back, if it's too far away, it will go forward. So this zone we are going to define by area. So let's say the area over here is 6,200 and the area over here is 6,000. So these are the values that I found after some testing. So we will be using these values to actually put in our drone. So this is the area. So if you take the number of pixels, so the width multiplied by the height, so you will get this value. So these are in pixels. Again, you can change these values later on according to your needs. If you're doing the full body, the area will be different than if you're doing the face or object. So that being said, let's have a look at the area. So the idea here is that we are able to go forward and backwards, but what if the person starts rotating? The idea here is that we always want our object to be in the center of the image. So let's say this frame is the image that we have, and the person is not in the middle. So then if they are on the left side, you will move the drone, you will rotate it, and this will bring the person in the center. And if, for example, if they are over here, and then you can rotate, and this will bring back to the center. Now the thing is, we can give it a value. For example, let's say at this point, our object is on the left hand side. So we will say rotate anti-clockwise direction with the speed of 20, let's say. So it starts moving at the speed of 20, and when it reaches the center, it cannot stop immediately. It will move a little bit forward because of the momentum. Think of this as a fan. So if you turn off a fan, it will not just stop immediately. It will keep rotating, and after a while it will stop. So the same thing will happen here. So if we tell it go 20 degrees, go with the speed of 20 centimeter per second, and when it reaches the center, if you tell it to stop, it will not just stop immediately. It will go a little bit further. This is called overshooting. So the same thing will happen if, let's say, she is on the other side and then we do it here. So what happens is, when it overshoots, the image will not be in the center, it will go here. Then it will try to retrieve and it will go here. So it will keep going back and forth and it will not stabilize. So how can we make it better? So we can make it better by reducing the speed as we reach our destination. So let's say the speed here is 20, and once we are getting closer, let's say the person is here now, then we will reduce the speed. Let's say right now it's 10, then it will become 5. And by the time it reaches the center, it becomes 0. So this way, instead of having plus 20 minus 20, it will have a value that will change based on how far are we from the distance, or how far are we from the actual point. So this method is known as PID. I will not go into the detail of how PID works more than this. I think this is a very basic explanation that will give you a basic understanding. But if you want to learn more about PID, it's basically proportional, integral, and derivative. So these are the terms. It's type of a controller that you can use. You can relate two different entities together which are not relatable by default. So these things are a little bit complicated if you haven't seen them before. But for this course, this explanation is more than enough that it is able to go back and forth. And when it is reaching the center, it has to slow down. So we will be using this methodology in our implementation. So let's have a look at the implementation. So we will first create a new file and we will call this So this project is more towards OpenCV. So we will first look at the OpenCV part and then we will see the integration. So let's import CVT.
我站在你的身旁，你是看着泪飘飘。
So what we will do first is we will on our webcam. So I will be using my standard webcam rather than the Android one. And once everything is done, we will so I will write here webcam is equals to video capture, and I have multiple webcams, so I'm using the number 1. If you don't have multiple webcams, most probably you will be using the number 0. And then we will write while true. We are going to get our image from gap.com, and then we will say this is our image and cv2.weight key, and we will give it the name of 1. So this is the standard code for actually running the webcam with OpenCV. So let's run this and see. So here is my webcam. So I will be using my image for the face tracking part. And once that is done, we will try out with the Okay, so now the first thing we will do is try to detect the face. So we will create a new function and we will call it, let's say, find face, and we want to find it in an image. So we will pass that image that we want to find and to find these faces we are going to use a method proposed by Viola Jones. So this is a very famous method of R Cascades. So this is basically a file that has all the parameters and information of a model that helps us detect different objects. In this case, the file that we have will help us detect faces. So let me copy the file. This file is available on the official OpenCV website, and it is also available on my website under this course, so you can download it from different places. So you can go to resources and paste it. So the name of this file is Parcast8 face offer. Actually, we will rename and we will copy this name. Let's move on. And now we have to refer to this file. So we will say that face cascade is equals to cascade classifier. Then we are going to write in this file. Now this file is inside the sources. So we have to write here resources, and then we can write the link or the path of our file. Then we are going to convert this into grayscale. So we can do by writing selecting color. Now if all of this is overwhelming for you, what you can do is you can go back and check out my OpenCV course. It has been very popular and has more than 1 million views now with 99% positive feedback. So if you go through the OpenCV part, this is not but if you don't have a lot of background in OpenCV, then just take my word for it that for example, so then we will write image then we will detect all the faces. So we write face is equal to face cascade dot detect multi-scale, and we are going to pass in our image that we just did, and then we are going to pass in some parameters. Now these parameters, normally the first one is basically the scale factor, and the second one is the mean. So what you can do is you can play around with the So again, you can read about these by going to their default function, or you can check it on the online documentation. I will not be doing anything that much detail. So then we are going to create a list of all the faces, and then we will create a list of all the areas of these faces. So there can be multiple faces, so we need to find the biggest one, and we will assume that that is the one we want to track because it is the closest one. So right here, actually let's write here C for center. So this will have the information of our center point. So CX and CY, where is our face connected. This will have the area. So these will be two lists, and then we will create a folder. So we will create 4 X, Y. So basically, whenever it detects these faces, it will return us these values. So we can unpack these values within this. Right, that we want to draw the rectangle around this face. So we draw rectangle, and for the rectangle we have X, Y coordinates, and then this is the starting point, and then we need the ending point. So the ending point will be X plus width, and then Y plus height. Then we need the color. So now let's run this and see. Let's try it out before we go further. And we need to call this function. So you can see the face is being detected properly, and it doesn't seem to If you don't find good results, you can always change these values. Now, once we have this, what we will do is we will get our center x and center y. So we will have x plus width divided by 2, and then cy is equals to y plus height divided by 2. So once we have this, we can also find area is equals to width multiplied by height. As simple as that. And then we are going to write that we want to bend. What should we? Okay, let's bend it first. Cx and So once we do both of these things, what will happen is, okay, let's explore. So we can draw a circle at this cx and cy position that we see where exactly it is. So right here, see we do draw a circle and we need an image. So the center cx and cy. Let's say and then we need the thickness. We will say fill. We want it complete. Let's So this value is what we will return. What we can do is, because right now we only have one face, so it's obvious we will return this one. But the reason we did these two is because we want to find the maximum area and we only want to send that value. So here we will check if before we actually do any calculations on this, we need to check if this is empty or full. So if it's empty, there is no point of calculation. So we will check first my faces. If we can pick any one of these, my faces area is not equals to 0. If it has some value, then we will say I is equals to my face and then we want to find the index of the max value. So the max value is so this will give us the max value of our area, and this will give us the index of that max value. So once we have that index, we will say return image and then also return my face list at I. And we also want to return the area because we have so from that list we will use this index to find the maximum value of the area, and from that area we will get the cx and cy values of that maximum. But if this is not the case, then we need to give it, we need to return something else. So we will say else return the image and then return 0 for the cx and cy and 0 for the area. So this will be we're pretty much returning. Okay, so now what we can do is we get the values. So the image, and then we have what else we have the cx and cy. And once we have it, what we can do is this will give us the area. So we'll write here area. So, as we discussed earlier in the explanation, if we go forward, the area will increase. If we go backwards, the area will decrease. So, based on this, we are going to move forward.
我站在你的选择，你是爱着眼泪飘飘泪。
Then we also have the center value. So the center will be 0.
你的笑是你放的保护伞，你决定不爱了，你决定不爱了。
So there you go. So now we are getting the center values. So the center values will be used to rotate, and the area value will be used to go forwards. This is good. Now what we can do is we can use our ground, and we can also use range. So let's here we will define a function. So let's say track, and what we need is we need the drone, and then we need the info, and we also need
就不可能完全的预感。我站在你
now
的
I'm going
选
to explain
择，
all of these are.
你是爱着眼泪飘飘泪。
So what happens is that we need to create a range. So we are doing the forwards and backwards right now. So we need to create a range. So here we have that forward and backwards range is equals to, as I mentioned before, it was 6 to 800. So 6 to 800. So these were the values for our range, and then we are going to write here that if our info, what should we call it? Let's call it area is equals to info 0. No, it was at 1. So if area is greater than the front, forward and backward range at 2, then we need to go back. So the forward and backward speed will be minus 1. So this is that, and then else if less than the forward and backwards range at number, this should be 1. Then we will say that forwards and backwards is equals to 1. So at this point it is saying that if it's too far, then go forward. If it's too close, then move backwards. Now we need to add a safety factor here, and the reason is that if we only say that the area is less than this value, which is 6,000 something, then 0 is also less than 6,000. So if nothing is detected, it will start going forward. So we need to mention that the area is not equals to 0. So if it's not equals to 0 and it is less than our range, then move forward. Otherwise it will move backwards, and we also need to add a condition where it will stay stationary. So that should be the first priority. that if it has to stay stationary, stay stationary. We will write here if area is greater than our forward and backward range at 0, and our area is less than our forward and backward range at number 1. This is and we can make this also. So now we have these three conditions. The first one is where we have the green zone. The drone will not move at all. The second one is where it is too close, it is too big, so it will move backwards. And this one is where it is too small or too far, and it will move forward. So now all we have to do is we have to send a command to the drone. We can send this F1 value forwards and backwards. Now let's have a look at the so for the PID we are going to introduce the error. So error is equals to let's unpack our x and y as well. Are basically at 0. So here we will say that our error is basically the x position. So we will say that x minus the width divided by 2. So what is this width divided by 2? It is the center of our image. So we want to find out how far away our object is from the center. So this is the value of the object or the face, and this is our center. So when we subtract it, we find the deviation. How far is it? Once we have that, so this W is basically the width of our image. So we will define it when we are calling this one. And then we will use the equation of PID. Now again, you don't have to go too much into details of what this does. If you want just to know how it works, you can copy the code. Otherwise, if you want to go into detail, I would highly recommend you check out any of the other videos on YouTube that have plenty of information about PID. So we are going to write here that our speed is equals to PID. This is a constant value. So we are basically changing the sensitivity of our error by this value. So we will declare it here, is equals to, and we will give in the values of our error. We are going to use 0.4, 0.4, and 0 in our case. So this is proportional, this is integral, and this is derivative. So we are only going to use so here this is proportional, this will be P, and then what we will do is we will multiply this with the error, and we will add the PID1, which is your derivative. We will multiply it with the error minus the previous error. So this will give us the speed, and what we will do is we will clip this speed between minus 100 and 100. We don't want it to go above 100, we don't want it to go below 100, minus 100. So we will write a speed is equals to integer, we will convert it into integer, we will say 1.1, and we will clip the speed between minus 100 and 100. So this is our new speed for our yaw that we can send in to our drone. So if you remember, for the drone, we can send in something like this. So we can say send underscore control, then we send in all the 4 values. So the first one will be 0. The second one will be forwards and backwards. So it will be this. The third one will be 0. The fourth one will be the yaw. which is our speed. So this is how we can send our command. Now, one more thing that we have to do, we have to return this value, return the error, because we need to use the previous error. So this error, when it comes back here, it will come back as the previous error. So here, right, is error global? No, it's not global, but right. Let's call this Okay, so here we have to include the code for the node. We will still wait for that. We are sending in the info, which is good. Then we need to send in the width. So where can we define the width? We can define it up here. Let's say our width and height is equals to, let's say, 360. As we did earlier as well, we can resize our image based on these values. So we can write here resize, and we will give our image, and we can say that it has width. Value, and then we can say this. We already have PID at the top degree, so that should be fine. Now again, you can change these values if you don't find the results. You can change the value and try out different values. I did not put much effort on tuning of this because tuning usually takes a long time. So I'm showing you the basic method, and later we can tune it yourself and see how it goes. Okay, so that being said, what else is it? So in the track phase, one more thing we have to do is that we need to define if we do not get anything, then we have to stop. So we have already defined it for this, forwards and backwards, but we didn't define it for speed. So just to make sure, we can write here if our, let's say, x is equals to 0, then our speed is equals to 0, and our error is equals to 0. So our previous error will be 0. Okay, so that is good enough. Or let's look out. Actually, let's remove this. Let's look at the webcam. So we are getting the center value, and this is So as you can see, the first one that we are getting, so you can see here, so we are getting backwards because it is too close, and then if you go back, I think it is too big actually. This speed is 6,000 we can try it out later for the angle. We can see that if we move left or right, we can see that the speed changes, and when it's at the center, the speed will be close to 0, and we start to so that is so here we are seeing that it is going to negative 80. So let's see why that is happening. So here display the speed. When it's real, it's displaying horizontal. This is right. The speed is 0. Once it's detected, so now we can test it out in actual environments. Before we do that, we can add the part for our drone. So let's go to drone structure and we will copy the code from here. So we will copy all of this and paste it here, and we will remove the import CO2. That should give us the frame. We can comment this, and we can uncomment this part. We'll send the values to the drone. So let's not print out anything, and let's try it out and see what happens. Now we need to add the safety feature as well. So when we press the new button, add the takeoff part as well. So here we will write and what I've observed is that when it takes off, it's at a lower level right? So what we can do is we can make it it's easy to turn phases going down and bending. So we can right here that actually let's copy it. So and we will do it for, let's say, time counts 2 seconds. So it depends. And you can reduce it. For the landing, we can write something here. Now this will be a little bit confusing, but just understand that this part of the code, when you press the Q button, it will stop. So we are using the CV2 library. So we write here if CV2 and
快乐，你的笑就是一场的保护伞。你决定不爱了，你决定不爱了，让它尽热，是真的我的。
If you like the video so far, give it a thumbs up and don't forget to subscribe.
你的山就不跟往前的预言。
Now the idea behind the blindfold
你的选择，你是爱情的代表，
So let's say that we have the line following draw, which looks something like this. If we Google the results, we can see something like this. So we can see we have a lot of different types. Most of them they have a long chassis and then they have sensors. So it can be 3, it can be 16, it can be 8. So a lot of different types. You can see here. So this is, let's say, the exact same robot. It has these 2 units and these are the 3 sensors that can be either on or off. So if, let's say, the robot is on the black line, then it will be on. If it's not on the black line, then it will be off. So at this point, these 2 will be off and this one will be on. So let's have a look at the concept. So let's say I want to move forward. Now here, this middle one will be on and the left and the right one will be off. So the robot will move forward. Now once it reaches this point, now both the right and the middle one are on because the black line is both available on the right and on the middle sensor. So then we can tell it to rotate a little bit. Now if it keeps going further and it comes to a point where only this one is left, it means that it needs even more rotation. So in that case we will rotate even further to come back to the middle one until we get this point. Then it will keep moving forward. And at some point you will see that maybe this one and the center one start detecting the black line. Then at that point you have to go backwards in the anti-clockwise direction. So this way, if we have this sensor on, we need to rotate in the anti-clockwise. If we have this one, we need to move clockwise. So we are always moving towards the center. Now, if we talk about binaries, now if we talk about numbers, if there is no sensor with the line available, then we can say it is 0, 0, 0. Now, if one of them is on, then we can write it. Then we can write it as 0, 1, 0. So we can have all these different conditions where we can say if it's 0, 1, 0, then go forward. Then let's say that we have this. In that case, it will be 0, 0, 1. So if we have 0, 0, 1, we can go right. So we will rotate towards right. And if we have, let's say, 1, 0, 0, which will be this case, then we can say go left. Okay, so this one is straightforward, but because we have 3 different sensors, the possibilities are 2 to the power of 3, which means 8. So we have a total of 8 different possibilities. We have written down 3 of them already. So here we can say it is 2 to the power of 3, which is equals to 8. So we have written 3, then we can also have 0, 1 and 1. So we will say slight right. Instead of going right, when it is like this. So when it's in the middle, it will have 0, 1 and 1. So this way both of them are on. So we only have to rotate a little. Earlier it was 0, 0, 1, we had to rotate a lot. Now it is 0, 1, 1, so we have to rotate a little. So that is slight right. So the same way we will have 1, 1 and 0. So this will be slight left. And then we will have 0, 0, 0. And then we will have 1, 1 and 1. So a lot of the times maybe one of them is not possible. Like for example 1, 1, 1, maybe it's not possible. And 0, 0, 0, maybe it's not possible if it doesn't go out. But at some cases they can be possible. So we can write, for example, stop and stop. So we have now 1, 2, 3, 4, 5, 6, 7 cases. The last one is 1, 0 and 1. So again this should not be possible. So we will write stop. Or we don't need to define. So here we have 8 different possibilities that can happen. So based on this we can move our robot to follow this line. So it will rotate, so this is the main idea. So let's see how we can implement this. So here we have the rotation of the drone. So let's say that our drone is up here and it is moving forward and the camera is facing downwards. So we are looking directly downwards. Now we are going to use a clip to actually attach a mirror so that it can look downwards. This clip is available on Thingiverse. Now if you cannot print it or you don't have a 3D printer, you can always glue a mirror on the telephone itself. I have tried it with the glue gun and it works perfectly fine. But a neater way, a cleaner way is to use the Thingiverse file, and this file here is provided by Works of Clay. So thanks to the guy who actually built this, and you can see it can view from the top. If you add the mirror, there you go. This is the guy. And yeah, so you can print this, it will print quite quickly, and then you can use this to view downwards. So this is what we are doing. We are viewing downwards, and what we will get is we will get an image. So what we will do is we will split this image into 3 different parts. So we will have left, center and right. So this will be exactly the same method of our line follower. So like this line follower had these 3 sensors, the same way we will have 3 regions where we will detect our black line. So when we are getting the image, if the image is in the middle, then we will say that go forward. Then if it's on the right, then we will say rotate towards the right. So the drone will rotate towards the right, then it will come back to this position, and then when it goes a little bit here, then it will move towards left and it will travel like this. So this way it will follow the line completely. So the idea is exactly the same as the line follower robot. All we are doing is we are converting our image to 3 different sensor zones. So right, middle and left. Now because these are virtual zones, what we can do is we can split them into more regions as well. We can make them 5, we can make them 10. But the problem is if we have more than 3, let's say we have 5, then we will have 2 to the power of 5 different combinations. So that is a lot of combinations to run. So I would suggest go with 3, and if you want to try it out, you can try with 5 as well. Now this is part of rotation. Now because in a line follower robot we can only rotate, so it is a bit easier and that should be enough for the line follower. But in a drone, apart from rotation, we can also translate. So maybe the drone is not here, maybe it's here. then it's not actually viewing the line properly. Maybe it's like this, or maybe it's like this. So we have to make sure that the drone is always at the center, and then when it's at the center, then it will be able to tell when to rotate properly. Otherwise, if it's here, it will not be able to tell how to rotate or how much to rotate. So we also have the problem of translation. So this is the idea of translation, that when the drone is moving, at any given point, we will try to find the center of our black line and where the drone is. So if the image or the line detected is right in the center, we will keep going forward. If it's not, if it's deviated, we will add some translation back towards the center. So the same thing if it's going this way, let's say it is like this, then we will reduce it back to this. So at any given point, we will measure, so it will keep coming back like this. So this is the idea of translation. So let's get started with the presentation. So the first thing we will do is to right click and go to writing file and create a line. So we will open that up, and here we are mostly going to use the OpenCV part. So we will be doing image processing along the lines. So what I will do is I will use my webcam, and once everything is done, we can start. So the idea here is that we are going to lay down the A4 tables because it is very simple to find the A4 tables and everyone has them. So this will be a very easy way to create that. So we will be using A4 paper, but you can use anything that you want. One good thing about the A4 paper is that it is plain white, so we can use color detection to actually detect white color. So let's get started with that. So what we will do is we will write down here, import CV2, then we will add our webcam. So you can put it as 0 if you have it. Then we will write while true, and then we are going to write underscore image is equal to then we are going to write here CV2 dot wait key 1 and CV2 show, CV2 dot I am show, and we will say output image, and also we can resize it so that it is big. So we Now the thing is, when we will be using the Telodrone, the image will be flipped vertically because we are using a mirror to actually find the image, so it will be flipped. So we need to flip it back. So image is equals to CV2 dot flip, and our image will be vertical. But for now, we are going to remove this, and later on, we will okay, so by the way, for now, I have these images. So I have created these images. We are going to test on that. So this represents the path, we have straight and we have left. So we can use the webcam for these images to actually try them out. I will put these images on my website as well, so you can download it from there. By the way, everything will be available on my website for free. You can download the code and all the resources from there. So the next step would be to find our pattern. So to do that, we are going to use the color method. We will create a threshold function, and we will give it an image that will define the color. So we will copy this and right here, thresholding, and we are going to use the HSV color space to define our color. Now if you are not familiar with this, again you can go back to my OpenCV course and you can check that out how you do that. But if you don't want to do that, then just keep along and I will explain as much as I can. So we are going to convert it into HSV. So this will be our HSV image. So we will write here change this image to HSV. The reason we are converting it into HSV, which is hue saturation value, is because it's easier to find colors in that color space. So we are converting from RGB to HSV. Actually BGR to HSV because OpenCV uses BGR. So we will write here cv2.bgr, so color to BGR, to HSV. And then we will give out our limits. So we have the hue minimum and hue maximum, then we have the saturation minimum and saturation maximum, and the value minimum and the value maximum. We have to input these values. But how can we get these values? I have written down a script. Again, this is from my OpenCV course. So this script basically helps us find these 6 values. So paste it. So this is the code. Again, this will be available on my script. So what we can do is we can read it from our capture device. So we can uncomment this. So again, this color picker you can use with the drone as well. I have added the code for the drone. So when you want to tune the drone, so right now we are using it for the images. So let's run this. So here we can see, I think it's flipped. So here, because of the drone flip, I have added the flip here as well. So now you can see the screen, there's black and white, so we have to find this one. So what we have to do is we have to move these values. We have to keep the white color and we have to move. You can look over here. You have to keep the white color and you have to remove the black. Now we are getting the white, so you can see here the white that was here is now gone. How is this? It's getting better. So these are the values that we got. What we will do is we will stop this, and then we are going to go back to our line follower, and here we are going to declare a new variable, and we are going to call this HSV values. So here we will call it HSV values. So now we can use these values to actually create the minimum and the maximum. So here we will call this the lower right, so let's just go to lower, and then we will say numpy. So here we have add our HSV values. Then we have upper at 1.
的山就不肯完全的预感。我赞赏你的选
Same
择，
thing, we will copy from
你
here.
是看着眼泪飘飘泪双双的走着，快乐。
So now, if we want to create that image, this can be so simply to that range, just and we want to use a row. So this will be the image that will only contain the paths, the white paths that we have, and nothing else.
的山就不肯完全的预感。我赞赏你的选择，
Mask.
你是看着眼泪飘飘泪双双的走着，
So what we can do now is I can just call this what we can do is we can display this illustration. So we can say path. So there we go. So now only the white part is shown. As you can see.
这山就不肯完全的预感。我赞赏你的选择。
So it's
你是看着眼泪飘飘泪双双的走着。
now for the white paper, for A4 paper, it will be a little bit different, so you might have to clean it again. Actually, let me put down the paper and show you what it will be. So here you can see that this is the white paper, the A4 paper. Now again, as I mentioned before, once we are done with the code, we will tune it on the drone, on the camera of the drone, so that it will have a little bit of different colors. So we will tune it then. But for now it looks good, but as you can see, my carpet is gray. It's still in that. So once we tune it, it should be fine. Okay, so now that we have the image of our path, we still don't know where the center is or how much curve is present. So to do that, we need to convert this into a box, and from that box we will get the center point. So we will create a bounding box around this path, and we will get the center point of it, and based on that center point we can translate. So if it's towards the right, we will go back towards the center. Again, if it's towards the left, we will go back towards the center. So we will try to keep it at the center. So to do this, we will create a new function, and we will call it get, and we will send in our image threshold, and we will also send in our actual image on which we want to draw the bounding box. So let's create this function. Get threshold. Okay, so the first thing we will do, we will get the contours. So we will use the functions to find contours. Now contours are basically edges. So we are finding the edges in our image, and based on those edges, we will find the path or the bounding path. So here we will write that we want to find it on our image. Again, if you want to go into the detail of how this works, you can check out diagrams. We are going to use the external method that will give us the outer region, and CV2 chain approximation. Again, you can use circle, let's use none. And what this will return is contours. Now Now we are not considering the highlight, but because it's going to return us, we are just going to unpack it. Okay, so then we have to find the biggest contour factors, because that will be our path. We are presuming that the biggest contour or the biggest region we find will be our. So here we will say biggest is equals to, by the way, these contours are basically the dots or the points. Actually, let me draw the contours so that you can see.
就不肯往前的预感，我站在你的选择，你是看着你的最漂亮的天天广场的走
all the contours. This one, -1 means we have to draw all of them, and if it's just 1 or 2, we can draw the first one, the second one. Then we have to define the color, so let's go. Let's define the colors. So let's run this and see what happens.
的山就不肯往前的预感，我站在你的选择，你是看着你的最漂亮的天天广场的走着，快乐，你的笑只是一场的保护。
Here it should not be image, it should be image threshold. So we need to find it from the image threshold that we just got the path from. And there we go. So now you can see
的山就不肯往前的预感，
now the problem is that my regions will be edited as well.
你是看着你的最漂亮的
Otherwise, if I zoom in, you can see the edges. Let me try the other one. There you go. So you can see it's detecting the path. If I go back, we will get the bigger one as well. Elsewhere, so when we are using it with the drone, it should be, the background should be different colors, so it will be easily detected. So now that we have these contours, we need to get the biggest one. So as you saw, we can get the biggest one by writing biggest is equals to max of contours. And what is the key that we want to use? The key will be area. So we will write CV2 dot contour. So this will give us the biggest contour, the points, and then we will convert all of these points because it will have lots of points. We don't want that. What we want is the bounding box, the x, y, and the width and height. So we will change all of these points into just bounding box for the height. So we will say that x, y, and width and height is equals to bounding x, and we want to change the biggest one. So this will give us the x, y, width and height. We can use the rectangle method to draw that, and we can also find the center of this. So the center, x will be x plus width divided by 2, and the center y will be y plus h divided by 2. And as we did earlier, we can draw these circle, image, we want the center to be cx and cy, we want the radius to be c10, then we want the color to be, let's say, and we can change this. Instead of drawing all of them, we can only draw the biggest one.
你的山中不可完全的预感，我赞赏你的选择。
See, the center is here.
你是爱着眼泪
Something like this, we would say that the main center is here somewhere, the center of the image. So we have to go back and do the center.
你的笑只是一场的保护伞。
Using this, so using this method, we can find the deviation, and from that deviation, we can tell the robot to go left or we can also draw the rectangle using these points. All we need for this function is the cn. So we will return cx. Go back here and cx. So now we have done the first part, which is basically for translation. So I can write here. This is for translation. Okay. Now we need something for rotation. So as we discussed, the 3 sensor method, we are going to use that. So we will call this sensor output. Or get sensor output. We will send in our image and we will send in the number of sensors we want to use. So the image will be the same, image threshold, and the number of sensors will be 3. So now you can change those as well, but for now we are going to keep it at 3. So let's copy this and create a function here. So now the idea is that we want to split our image into 3 different portions. So if we have 3 sensors, we want to split it into 3 different sections. So we can use the NumPy library because these are matrices. We can use the NumPy library to actually split it. So there is a very good function for that. Let's say our images are called images equals to NumPy dot horizontal split because we want to split it. We will give in our image, which is the image threshold, and then we are going to give in how many numbers do we want. So we want sensors, which is 3. We want to split it into 3. Now, one thing you have to make sure that when you are splitting, the size of the image here, the width of the image should be divisible by 3. If it's not divisible by 3, it will not be able to split it into equal portions. So you have to make sure of that. So 480 is divisible, so it should not be wrong. So what we can do is to actually check if it's working, we can print out show, and we can write, let's say, or let's say I am in images. We want to show the image, and we have to give a unique name, so we can enumerate it. We can get the value of x. Here for the name of x, we can convert it into a string, and we can write here IM. So every time it will loop, it will create a new image. So we will have 3 images to show. Let's run this and see what happens. So now you can see. So this is our main image, and then we are getting these 3 images So let's say that
，let's
say that is in the center, or let's say it's on the right, it's on the left. So then the right one will be 0, the left one will be 1, the middle one will be sorry, this is left one, this is the middle one, so it will be like this. So right now our sensor value is 1, 1, 0. So right now here we have a lot of values. If we had very little values, maybe something like this, then we can neglect it. We can say if it's more than 20%, then we will count it as 1. And if we have it like this, then it's 1, 1, 1, so it will go forward. If we have it like this, it will be 0, 1, 0. Sorry, 0, 1, 1, and so on. So this way, now we can check each of these images. So we need to count how many pixels here are white, and based on that, we can say whether it's on or off. So to do the counting, we are going to write here pixel count is equals to CV2 dot count 10 from our image. And then we can write here that if our pixel count is greater than the threshold multiplied by total pixels. So what is this threshold value? Well, we can define it up here. Let's say this is 20%. So if it's more than 20% of the total pixels, then it means it is 1. So we can multiply it here, and so total pixels is basically so this will be image, shape. We have to take the width. So the width is element number 1 divided by the sensors. So for example, our width was 480. It will divide it by 3. So it will divide it by 3, and then it will give us the width of our single image, so the one that we have split, and then we will multiply it with the image dot shape at 0. So this is the height. So we are multiplying the width by height, and that will give us the total number of pixels. But because we are splitting it up into 3 pieces, we are dividing the width by 3 first. So this will give us the total pixels, and then we can check if the total pixel count multiplied by threshold is greater than, is less than the pixel count, then it means it is 1. So we will say that send out, so this will be our, let's say, sensor values, and we are going to append 1. So we can our sensor out. So these will be the values. So if the sensor is 110, we have the value 110. So based on every sensor, is it on or off? So here will be else. We will say send out dot. So this is the idea, and we can show this for now. Later on we can remove this. So let me print this out and show you how to use this. So print. Okay, so let's run this and see if it works. it was unable to find the biggest contour. That's why it gave an error. So we can fix that later. We can say do all the calculation if something has been found. Otherwise, don't do it. So here you can see that at this point it should be 0, 1, 1. So this is 0, this is 1, this is 1. And then if I go here, it is 1, 1, 0. If I zoom in or if I zoom out, then the middle one is so the middle one right now is 1, the rest of them are 0. So I think this is clear enough. So here you can see 1, 1, 0, and 1, 1, 1, and 0, 0. So if 20% of the pixels are present, we will consider that. So we do not need to display this. All we need is sensor values of 0. So once we have that, the last thing we can do is we can send out all these values to our drone. So how can we do that? Let's have a look. So we will create a new function and we will call it send and say that we are going to give it the sensor out and we are also going to give the CX. So these are the two values. This one is for translation. We got the CX and this one is for so based on these values, we can rotate or translate. Send commands. And the first thing we will do here is we are going to do the translation. So so the translation is actually very simple. So we will get the value of left and right. We will call it LR. So this is the left and right value. So this will be basically our CX minus the width divided by 2. So width is not divided by 2, and we can introduce sensitivity elements. So we don't want to send in the exact difference. We can divide it by something to make the sensitivity a little bit better. So this value will control the sensitivity. So I can write here sensitivity. So if the sensitivity, the number is high, if number is high, less sensitivity. So that is the and then we can send this value. How can we do that? Now we need to make sure of one thing, which is basically that we don't want to give it a lot of value. So we don't want it to give a very high speed. So maybe the speed is coming to 200, or maybe it's coming to 50 or 70. So that is a very high value and it will be very fast. So we need to restrict our translation to a certain value. So we can use the numpy function here again. So we can say that is equals to numpy dot clip, and we will clip our LR from minus 10 to 10. So we don't want to go above. And the last thing we need to do we want to add a value where the translation will be 0. Because at any given time there will be some value of deviation. But what we want to do is we want to give it some room for error so that it's not always wrong. So we can write it that if our error is less than 2 and our error is greater than -2, which means it's between -2 and 2, then our LR is equal to 2. So at that point it is not going to be all of this. And now we can simply send it by saying send underscore control, and we can send left right, and the rest we can keep it at 0. Now the second part is your rotation. So as we discussed in the rotation, we will have the sensor value. So whether the sensor is on or off. So we will say that if our sensor out is equals to 0, then we will have a curve. The curve value is equals to, let's say, 30. So the idea here is that if the value is 100, then it should turn more. If it's 110, it should turn less. So we can call them as weights. So our weights are basically, let's say, -25, then -50, then 0, then 15, and then 25. So the idea here is that if we have 010, which is the center, then this is the weight. So you don't have any curve, 0 curve. Then if the value is 110, then the curve will be -50. If the curve is 100, then the value will be -25. On the other side, if it's 011, then it will be 15, and if it's 001, it will be 25. So we can take the weights from here. Here, instead of 30, we can write weights. And this is the very harsh on the left, so this will be the first one. So now we can copy this and we can write the other statements. So here we will write else if it will be 110 and the weight will be 1. Then we can copy this line several times. Okay, if we need. So it will be 110, then it will be 0, 10, then it will be 0, 11, then it will be 0, 0, then we can also have 000, and we can also have 111, and we can also have 101. So in the last 3 cases, we will not do anything to the curve, or we can put it as 0. So we will not go any further. So it is up to us. So 0, 1, 2, 2 will be 0. So here, this value is 0, 1, 2, so this is 0. So if it's any of these, it will be 0. Then we have 1, we can change it to 2, 3, and 4. So these are our weights. Do we need to change anything else? So the only thing we have to do, we have to declare the curve. that should be fine. And the last thing we have to do have a constant speed. So this forward speed we can define. So I recommend keep it at slow speed, very fast, but as you keep so that is pretty much it. So let's try it out and see what happens. So what you can do is you can try out one part of it. So you can try out only translation, and then you can try out only translation. And then if you want to tune it, you can tune it, and then you can open both of them and work them at the same time. So here, if you want to just run the translation, you can remove the curve, you can make it 0, and vice versa, you can make this 0 as well and use only the curve. So the last thing we have to add all the things for our drone. So we will go to the image capture, and in the image capture we will copy all of this code and we will paste it here. We are repeating So this is basically this is and what we can do is we can simply snap it here. It's very good and light design. Now it is a bit fragile, so you can just stick it here. So this is how you can attach it. Now you can see the camera. Now it will view. So let's run it and see how it works. Now the thing is that it might actually view. By the way, I got this from the store, and let me check the size of it. So it's 25 by 25. So you can get this or you can cut it yourself. Now the first time I tried this, I took a mirror, I cut it myself with a cutter, and I just glued it with an pen. I just turned on the camera, I looked at the angle, I held it while the hot glue was drying, and it worked out fine. So you don't have to get this fancy stuff if you don't have a 3D printer, but if you do, then this is much better. So let's run this now and see if we can find I will remove the takeoff for now. And let's connect it and see what And yeah, as I was mentioning before, you might get this problem. So as you can see, on the very edge, you will see there is a black area, and this is because of the mirror. So what you can do is, if you press it hard enough, so you can see this is the mirror. Now if you press it hard enough, it works the the upper side, then it will stay. But if it doesn't stay, what you can do is you can take a scotch tape and then you can tighten it from here. So like this, and you can pull it back. You can put it here, and you can pull it back and then tape it down here. So now it should not leave you any of the edge that you will get off. So the first thing we have to do, we have to find the color. So again, we are making this error for the biggest color. So what we can do is so here we can write if length of contours is not equals to 0. So we can write hopefully this will work.
你的山就不肯完全的预言，我赞赏你的选择。
as 0.
你是看着眼泪飘飘来向天地广场的走着。
Okay, so now what we have to do, we have to first of all find the color. So I will lay down the A4 papers, then we will find the color using the computer. So let's go to the color picker and we will run this. Change this to the
的山就不肯完全的预言，我赞赏你的选择。你是看着眼泪飘飘来向天地广场的走着。快乐，你的笑只是一场的保护伞。
There you go. So now I can move these to find the optimum value for the light. So we want to keep it there you go.
你的山就不肯完全的预言，我赞赏你的选择。你是看着眼泪飘飘来向天地广场
These are the values that we have found and it should be fine. So we can stop it, we can go from here.
你的笑只是一场的保护伞。你决定不爱了，你决定不爱了。是真的我的。
So now we are getting our bath.
你的山就不肯完全的
As you can see, we have a little bit of right and left. We have the forward speed. There is no curve. But if we rotate it, we get some curve. So now you can see that we have a curve. If I go on the other side, you can see that okay, anyways, this, everything is working fine. All we have to do now is to try it out and we will take off and run it and see what happens.
你的山就不肯完全的预言，我赞赏你的选择。你是看着眼泪飘飘来向天地广场的走着。快乐，你 肯完全的预言。我赞同你的选择，你是看着眼泪飘飘来的天天。
Hey everyone, and welcome to this Python and OpenCV course. In this course, we'll be talking about everything you need to know to get started with OpenCV and Python. We're going to start off with the very basics, that is reading in images and video, manipulating those media files with image transformations, and how to draw shapes and put text on those files. Then we're going to move on to the more advanced parts of OpenCV, that is switching between color spaces, bitwise operators, masking, histograms, edge detection, and thresholding. And finally, to sum things up, we'll be talking about face detection and face recognition in OpenCV, so how to detect and find faces in an image, and how to recognize them using inbuilt methods. In the last video, we'll be building a deep computer vision model to classify between the characters in The Simpsons based off some images. All material discussed will be available on my GitHub page, and all relevant links will be put up in the description below. So if that sounds exciting, don't forget to head over and subscribe to my channel, and I'll see you in the comments. Hey everybody, and welcome to this Python and OpenCV course. Over the next couple of videos, we're going to be talking about using the OpenCV library to perform all sorts of image and video related processing and manipulation. Now, I won't be delving into what OpenCV really is, but just to be brief, it is a computer vision library that is available in Python, C++, and Java. A computer vision is an application of deep learning that primarily focuses on deriving insights from media files, that is, images and video. Now, I'm going to assume that you already have Python installed on your system, and a good way to check this is by going to your terminal and typing Python --version. Now, make sure you're running a version of Python of at least 3.7 above. Whatever we do in this course won't really work in some older versions of Python, and especially Python 2. So just make sure that you have the latest version installed. Go ahead to python.org and download the latest version of that. Now, assuming that you've done this, we can proceed to installing the packages that we require in this course. The first one is OpenCV. So go ahead and do a pip install OpenCV-contrib-python. Now, sometimes you may find people telling you to install just OpenCV-Python. Well, this OpenCV-Python is basically the main package, the main module of OpenCV. OpenCV-contrib-Python includes everything in the main module, as well as the contribution modules provided by the community. So this is something I recommend you install, as it includes all of OpenCV's functionality. You may also notice that OpenCV tried to install the NumPy package. Now, NumPy is kind of a scientific computing package in Python that's extensively used in matrix and array manipulations, transformations, reshaping, and things like that. Now, we'll be using NumPy in some of the videos in this course, but don't worry if you've never used them before. It's simple and relatively easy to get started with. Now, the next package I'd like you to install is Sierra. So go ahead and do a pip install Sierra. Now, slight disclaimer, this is a package that I built to basically help you to speed up your workflow. Sierra is basically a set of utility functions that will prove super useful to you in your computer vision journey. It has a ton of super useful, helpful functions that will help speed up your workflow. Now, although we're not going to be using this for a good part of this course, in fact, we only begin to use this in the last video of this course when we're building a deep computer vision model, I recommend you install it now so that you don't have to worry about the installation process later on. If you're interested in contributing to this package, or just simply want to explore the codebase, I'll leave a link to this GitHub page in the description below. Okay, so that's it for this video. In the next video, we'll be talking about how to read images and video in OpenCV. So, I'll see you guys in the next video. Hey everybody, and welcome back to another video. In this video, we're going to be talking about how to read images and video in OpenCV. So, I have a bunch of images in this Photos folder, and a couple of videos in this Videos folder. In the first half of this video, we'll be talking about how to read in images in OpenCV, and toward the end, we'll be actually talking about how to read in video. So let's start off by creating a new file. We call this read.py. And the first thing we have to do is actually import cv2 as cv. So the way we read in images in OpenCV is by making use of the cv.imRead method. Now this method basically takes a path to an image and returns that image as a matrix of pixels. Specifically, we're going to be trying to read this image of a cat here. So we're going to say photos/cat.jpg, and we're going to capture this image in a variable called img. Now you can also provide absolute paths, but since this photos folder is inside my current working directory, I'm going to reference those images relatively. Now once we've read in our image, we can actually display this image by using cv.imshow method. Now this method basically displays the image as a new window. So the two parameters we need to pass into this method is actually the name of the window, in this case it's going to be cat, and the actual matrix of pixels to display, which in this case is img. And before we actually move ahead, I do want to add an additional line, a cv.waitKey0. Now the cv.waitKey0 is basically a keyboard binding function. It waits for a specific delay or time in milliseconds for a key to be pressed. So if you pass in 0, it basically waits for an infinite amount of time for a keyboard key to be pressed. But don't worry too much about this, it's not really that important for this course. But we will be discussing some parts of it towards the end of this video. So let's actually save this and run by saying python read.py, and the image is displayed in a new window. Cool. Now this was a small image. This was an image of size 640 by 427. Now we're going to try and read in this image of the same cat, but a much larger version, 2400 by 1600 image. So we're going to say cat_large.jpg, save that and run, and as you can see this image goes way off screen. The reason for this is because the dimensions of this image were far greater than the dimensions of the monitor that I'm currently working on. Now currently OpenCV does not have an inbuilt way of dealing with images that are far greater than your computer screen. There are ways to mitigate this issue, and we'll be discussing them in the next video when we talk about resizing and rescaling frames and images. But for now, just know that if you have large images, it's possibly going to go off the screen. So that's it for reading images. We can now move on to reading videos in OpenCV. Let's go reading videos. So what we're going to do is we're actually going to read in this video of a dog. And the way we read in videos is by actually creating a capture variable and setting this equal to cv.video capture. Now this method either takes in integer arguments like 0, 1, 2, 3, etc. or a path to a video file. Now you will provide an integer argument like 0, 1, 2, and 3 if you are using your webcam or camera that is connected to your computer. In most cases, your webcam would be referenced by using the integer 0, but if you have multiple cameras connected to your computer, you can reference them by using the appropriate argument. For example, 0 would reference your webcam, 1 would reference the first camera that is connected to your computer, 2 would reference the second camera, and so on. But in this video, we'll be actually looking at how to read in already existing videos from a file path. Now specifically, we'll be reading this video of a dog here, and the way we do that is by providing the path. So videos/dog.mp4. Now here's where reading videos is kind of like different from reading images. In the case of reading in videos, we actually use a while loop and read the video frame by frame. So we're going to say while true, and the first thing we want to do inside this loop is say is true and frame is equal to capture.read. Now this capture.read basically reads in this video frame by frame. It returns the frame and a boolean that says whether the frame was successfully read in or not. To display this video, we can actually display an individual frame. So we do this by saying cv.imshow, and we call this video, and we pass in the frame. And finally, for some way to stop the video from playing indefinitely, is by saying if cv.wait key 20 and 0xFF is equal to odd or D, then we want to break out of this while loop. And once that's done, we can actually release the capture pointer, and we can destroy the windows. And we can get rid of this. So basically, just to recap, the capture variable is an instance of this video capture class. Inside of while loop, we grab the video frame by frame by utilizing the capture.read method. We display each frame of the video by using the cv.imshow method. And finally, for some way to break out of this while loop, we say cv.wait key 20 and 0xFF is equal to odd of D, which basically says that if the letter D is pressed, then break out of this loop and stop displaying the video. And finally, we release the capture device and we destroy all the windows, since we don't need them anymore. So let's save that and run, and we get a video displayed in a window like this. But once it's done, you'll notice that the video suddenly stops and you get this error. Most specifically, a -215 assertion failed error. Now, if you ever get an error like this, -215 assertion failed, this would mean in almost all cases is that OpenCV could not find a media file at that particular location that you specified. Now, the reason why it happened in the video is because the video ran out of frames. OpenCV could not find any more frames after the last frame in this video, so it unexpectedly broke out of the while loop by itself by raising a CV2 error. And now you can get the same error if we comment this out, we uncomment this out, and we specify a wrong path to this image. So that's it. cv.wait key 0. Save that, can run, and we get the exact same error. This basically again says that OpenCV could not find all the video frame at a particular location. Basically, it could not be read in. That's what it's saying. So that's pretty much it for this video. We talked about how to read in images in OpenCV and how to read in videos using the video capture class. In the next video, we'll be talking about how to rescale and resize images and video frames in OpenCV. So see you then. Hey everyone, and welcome back. In this video, we're going to be talking about how to resize and rescale images and video frames in OpenCV. Now, we usually resize and rescale video files and images to prevent computational strain. Large media files tend to store a lot of information in it, and displaying it takes up a lot of processing needs that your computer needs to assign. So by resizing and rescaling, we're actually trying to get rid of some of that information. Rescaling a video implies modifying its height and width to a particular height and width. Generally, it's always best practice to downscale or change the width and height of your video files to a smaller value than the original dimensions. The reason for this is because, while most cameras, your webcam included, do not support going higher than its maximum capability. So, for example, if your camera shoots in 720p, chances are it's not going to be able to shoot in 1080p or higher. So to rescale a video frame or an image, we can create a function called def_rescale_frame, and we can pass in the frame to be resized and a scale value, which by default we're going to set as 0.75. So what I'm going to do next is I'm going to say width is equal to frame.shape of one times scale, and I'm going to copy this and do the same thing for the height. Now remember, frame.shape of 1 is basically the width of your frame, your image, and frame.shape of 0 is basically the height of the image. Now, since width and height are integers, I can actually convert these floating point values to an integer by converting it to an int. And what we're going to be doing is we're going to create a variable called dimensions and set this equal to a tuple of width, height. And we can actually return cv.resize the frame, the dimensions, and we can pass in an interpolations of cv.inter_area. Now we'll be talking about cv.resize in an upcoming video, but for now just note that it resizes the frame to a particular dimension. So, that's all our function does. It takes in the frame and it scales that frame by a particular scale value, which by default is 0.75. So let's actually try to see this in action. Let's go back to this read.py and grab this code. And we can paste that there. We don't need to use out. Now what I'm going to do is after I read in the frame, I'm going to create a new frame called frame_resized and set this equal to rescale frame of frame, and let's leave the scale value as 0.75. And we can actually display this video resized by passing in frame_resized. Resize. So let's save that and run Python rescale.py. That was an error. Okay, we don't need this. Let's close that out. Save that and run. And this was our original video, and this is actually a resized video. The video resized by 75%. We can modify this by changing the scale value to maybe 0.2. So we're rescaling to 20%. And we get an even smaller video in a new window. So let's close that out. Now you can also apply this on images. So let's uncomment that out, change that to count.jpg, and we can do cv.unshow image and pass in the resized image. We can create a resized image by calling rescale frame and we pass in the image. So let's save that and run. And this is a small video, so we're not concerned with that. This is actually the big image, the large image, and this is the resized version of this image. So let's close that out. Now there is another way of rescaling or resizing video frames specifically, and that's by actually using the capture.set method. Now this is specifically for videos and will work for image. So let's go ahead and try to do that. Let's call this def change res. So we're changing the resolution of the image of the video. And we can pass in a width and a height. And what we're going to do is we're going to say capture.set 3, width. And we're going to do the same thing with capture.set full, height. Now 3 and 4 basically stand for the properties of this capture class. So 3 references the width and 4 references the height. You can also expand this to maybe change the brightness in the image, and I think you can reference that by setting this to 10. But for now we're going to be interested in the width and the height. Now, I do want to point out this. This method will work for images, videos, and live video. Basically for everything you can use this rescale frame method. But the change function only works for live video. That is video you're reading from an external camera or your webcam, for instance. The video that is going on currently. This is not going to work on standalone video files that already exist. It just doesn't work. So if you're trying to change the resolution of a live video, then go with this function. If you're trying to change the resolution of an already existing video, then go with this function. So that's pretty much it for this video. So we talked about how to resize and rescale video frames and images in the OpenCV. In the next video, we'll be talking about how to draw shapes and write text on an image. So that's everything. I'll see you guys in the next video. Hey everyone, and welcome back to another video. In this video, we're going to be talking about how to draw and write on images. So go ahead and create a new file and call it draw.py. We're going to import CV2 and CV. We're going to import the NumPy package that OpenCV had installed previously, and we're going to import that as np. We will read in an image by saying unread equal to cv.unread, pass in photos/cat.jpg, so display that image in the window, and we can do cv.weight 0. Now there are two ways we can draw on images, by actually drawing on standalone images like this image of the cat here, or we can create a dummy image, a blank image to work with. And the way in which we can create a blank image is by saying blank is equal to np.0 of shape 500 by 500 and give it a data type of uint8. uint8 is basically an image, the data type of an image. So if you want to try and see this image, see what this image looks like, we can say blank and we can pass in blank. Say that run Python draw.py. And this is basically the blank image that you can draw on. So we're going to be using that instead of drawing on this cat image. But feel free to use this cat image if you'd like. So the first thing we're going to do is try to paint the image a certain color. And the way we do this is by saying blank and reference all the pixels and set this equal to 0,255,0. So by painting the entire image green. And we can display this image by saying green and passing a blank image. Save that and run. And broadcast out. Okay, you need to give it a shape of 3. Basically, we are giving it a shape of height, width, and the number of color channels. Just keep that in mind. Save that. And this is the green image that we get. Cool. We can even change this and try to change this to red. 0,255. Save that. And we get a red image over here. Now, you can also color a certain portion of the image by basically giving it a range of pixels. So we can say 200 to 300, and then from 300 to 400. Save that and run. And you get a red square in this image. The next thing we're going to do is we're going to draw a rectangle. And the way we do this is by using the cv.rectangle method. This method takes in an image to draw the rectangle over, which in this case is blank, and it takes in point 1, point 2, color, thickness, and a line type if you like. So the point 1 will specifically be 0,0, which is the origin, and we can go all the way across to 250, 250. Let's give it a color of 0,255,0, which is green. Give it a thickness of, let's say, 2, which is basically saying the thickness of the border. And once that's done, we can display this image saying, let's call this rectangle, and passing the blank image. We can comment this out because we don't need this anymore. And we get a green rectangle that goes all the way from the origin to 250, 250. You can play around with it if you like, so we could go from 250 to maybe 500. And it goes all the way across the image. So you basically divide the image in half. Now there is a way of filling in this image a certain color, and the way we do this is, instead of saying thickness is equal to 2, we say thickness is equal to cv.fill, and that basically fills in the rectangle to get this green rectangle. Now alternatively, you can also specify this as -1, and we get the same result. What we could also do is, instead of giving it fixed values like 250 and 500, what we could do is we could say img.shape of 0, of 1 divided by 2, and image.shape of 0 divided by 2. Let's save that and run. Image.find. This is blank. This is blank. Save that and run. And we get a nice little rectangle, or square, in this image. What it basically did is it scaled the rectangle from, instead of being this entire square, this rectangle basically has dimensions half of that of the original image. So moving on, let's try and draw a circle. This is also fairly straightforward. We do a cv.circle, and we pass in the blank image, and we give it a center, which are basically the coordinates of the center. But now let's set this to the midpoint of this image. We're saying 250, 250. Alternatively, we could also get this. Let's give it a radius of 40 pixels, give it a color of 0,0,255, which is red, BGR, and give it a thickness of, let's say, 3. We can display this image, say, circle is equal to blank. And we get a nice little circle over here that has its center at 250, 250 and a radius of 40 pixels. Again, you can also fill in this image by giving a thickness of -1. And we get a nice little dot here in the middle. Cool. Now there's something else that I forgot, and that is how to draw a line, a standalone line on the image. That again is fairly straightforward. So draw a line. We use the cv.line method, and this takes the image to draw the line on and 2 points. Let's just copy these points, basically everything. And this basically draws a point from 0,0 to half these image dimensions, so that's 250, 250, and then it draws a line of color 0,255,0. Let's set this to full white, 255, and 255, and basically the thickness you can specify as 3. And we can display this image. See behind show on this line, draw the line. Blank image. And we get a line that goes all across from 0,0 to 250, 250. Let's try and play around with this. Let's draw a line from 100 to 250, and then it goes all the way to 300 to 400. Save that on, and you get a line that goes from 100 to 100 to 300, 400. Cool. And finally, the last thing that we will discuss in this video is how to write text on an image. So that's write text on an image. Now the way we do this is very straightforward. we do a cv.put text, and this will put text on the blank image. We specify what we want to put on. So let's say hello. We can give an origin, which is basically where do we want to draw the image from. Let's set this to 225 and 225. And we can also specify font face. Now, OpenCV comes with inbuilt font faces, and we will be using the cv.font_fishy_. We'll be using the triple X. You have complex, you have duplex, you have plain, you have script simplex, and a lot of inbuilt fonts. But for now, let's use the triple X. Let's give this a font scale, which is basically how much you want to scale the font by. Let's set this to 1.0. We want to scale the font. Let's give it a color of 0,255,0 and give it a thickness of 2. Let's comment that out, and we can display this image. So it's either and show, let's call this text, and pass in blank image. And we get some text that is placed on the image. You can play around with it and say, hello, my name is Jason. Save that and run. And it goes off screen when we're dealing with large images, but there's no way of actually handling this except for maybe changing the margins here. You can do that by 0,225. And it starts from 0 and it says, hello, my name is Jason. So, that's it for this video. We talked about how to draw shapes, how to draw lines, rectangles, circles, and how to write text on an image. Now in the next video, we'll be talking about basic functions in OpenCV that you're most likely going to come across whatever project in computer vision you end up doing. So if that's it, I'll see you guys in the next video. Hey everyone, and welcome back to another video. In this video, we're going to be talking about the most basic functions in OpenCV that you're going to come across in whatever computer vision project you end up building. So let's start off with the first function, and that is converting an image to grayscale. So we've written an image and we've displayed that image in your window, and currently this is a BGR image, a 3-channel blue, green and red image. Now there are ways in OpenCV to essentially convert those BGR images to grayscale so that you only see the intensity distribution of pixels rather than the color itself. So the way we do that is by saying gray is equal to cv.cvt color. We pass in the image that we want to convert from, which is IMG, and we specify a color code. Now this color code is cv.color_BGR to gray, since we're converting a BGR image to a grayscale image. And we can go ahead and display this image by saying cv.imshow, passing gray, and passing the gray image. Save that and run. The Python basic.py. And this was the original image, and this is the grayscale image. Let's try this with another image. Let's try it with this image of a park in Boston. Same as Boston. And this is the BGR image in OpenCV, and this is its corresponding grayscale image. So nothing too fancy, we've just converted from a BGR image to a grayscale image. The next function we're going to discuss is how to blur an image. Now, blurring an image essentially removes some of the noise that exists in an image. For example, in an image there may be some extra elements that were there because of bad lighting when the image was taken, or maybe some issues with the camera sensor and so on. And some of the ways we can actually reduce this noise is by applying a slight blur. Now, ray tracing blurring techniques, which we will get into in the advanced part of this course, But for now, we're just going to use the Gaussian blur. So what we're going to do is we're going to create a blurred image by saying blur is equal to cv.Gaussian blur. And this image will take in a source image, which is the IMG. It will take in a kernel size, which is actually a 2x2 tuple, which is basically the window size that OpenCV uses to compute the blur on the image. We'll get into this in the advanced part of this course, so don't worry too much about this. Just know that this kernel size has to be an odd number. So let's start up real simple and keep the kernel size to 3x3. And another thing that we have to specify is cv.border_. So go ahead and try to display this image, say blur, and pass in blur. Now you will be able to notice some of the differences in this image, and that is because of the blur that is applied on. Right, the people in the background are pretty clear in this image, and over here they are slightly blurred up. To increase the blur in this image, we can essentially increase the kernel size, so from 3x3 to 7x7. Save that and run. And this is the image that is way more blurred than the previous image. So, that's it. The next function we're going to discuss is how to create an edge cascade, which is basically trying to find the edges that are present in the image. Now, again, there are many edge cascades that are available, but for this video we're going to be using the Canny Edge Detector, which is pretty famous in the computer vision world. Essentially, it's a multi-step process that involves a lot of blurring, and that involves a lot of gradient computations and stuff like that. So we're going to say Canny is equal to cv.Canny. We pass in the image. We pass in two threshold values, which for now I'm going to say 125 and 175. Let's go ahead and try to display this image. Get the Canny images, and we can pass in Canny. Say that. And these were the edges that were found in this image. As you can see that there were hardly any edges found in the sky, a lot of features in the trees and the buildings, and quite a few, features and edges in the grass and stuff. We can reduce some of these edges by essentially blurring the image. And the way we do that is instead of passing the IMG, we pass in the blur. Save that and run. And as you can see that there were far less edges that were found in the image. And this is the way you can basically reduce the amount of edges that were found by a lot, by applying a lot of blur, or get rid of some of the edges by applying a slight blur. Now, the next function we're going to discuss is how to dilate an image using a specific structuring element. Now, the structuring element that we are going to use is actually these edges, the Canny edges that were found. So we're going to say dilating the image. And the way we do that is by saying dilated is equal to cv.dilate, and this will take in the structuring element, which is basically the Canny edges, and we'll take in the kernel size, which we'll specify as 3x3 for now, and it will also take in iterations of 1. Now, dilation can be applied using several iterations at a time, but for now we're just going to stick with 1. So go ahead and try to display this image by saying cv.unshow, call this dilated, and we can pass in dilated. Say that and run. And if these were our edges, these are the dilated edges. We can maybe increase the kernel size to maybe 7x7 and try to see what that does. Hold on. And nothing much was done. Not much difference was there. Let's try to increase the number of iterations to maybe 3. And it's definitely way thicker, but you're going to see subtle differences with the amount of features and edges that we find. Now, there is a way of eroding this dilated image to get back this structuring element. Now, it's not going to be perfect, but it will work in some cases. So we're going to say, call this eroding, and we call this eroded is equal to cv.erode. It will take in the dilated image, passing dilated. We will take a kernel size of, let's start off with 3x3 and give it iterations of 1, just for now. And we can display this image. Show course eroded. And if this was your structural element, and this was your dilated image, this is basically the result you get from eroding this image. Now, it isn't the same as a structuring element, but you can just about make the features that. But you can see that between this and this, there is a subtle change in the edges, the thickness of these edges. We can maybe try to match these values so that there is an attempt to get back this edge cascade. He asked me about the edges back. Now, as you can see that you compare these two, they look pretty much the same. The edges are so essentially, if you follow the same steps, you can, in most cases, get back the same edge cascade. And probably the last function that we're going to discuss is how to resize and crop an image. So we're going to start with resize. So we covered resizing video frames and images in the previous video, in one of the previous videos. But we're just going to touch on the cv.resize function just a bit. So we're going to say resize is equal to cv.resize. This will take an image to be resized, and it will take in a destination size, which let's set this to 500 by 500. And so this essentially takes in this image or the part and resizes that image to 500 by 500, ignoring the aspect ratio. So we display this image by saying cv.imshow resize and resize. Save that and run. And let's go back to this image. If this is the original image, this is the image that was resized to 500 by 500. Now by default, there is an interpolation that occurs in the background, and that is cv.inter_image. Now this interpolation method is useful if you are shrinking the image to dimensions that are smaller than that of the original dimensions. But in some cases, if you are trying to enlarge the image and scale the image to a much larger dimensions, you would probably use the inter_linear or the inter_cubic. Now, cubic is the slowest among them all, but the resulting image that you get is of a much higher quality than the inter_area or the inter_linear. So let's touch on cropping. And that's basically by utilizing the fact that images are arrays, and we can employ something called array slicing. We can select a portion of the image on the basis of their pixel value. So we can say cropped is equal to the image, and we can select a region from 50 to 200, and from 200 to 400. And we can display this image. Call this cropped, passing cropped. And this is the cropped image of this original image. Try to superimpose them. It's probably going to be basically this portion. So that's pretty much it for this video. We talked about the most basic functions in OpenCV. We talked about converting an image to grayscale by applying some blur, by creating an edge cascade, by dilating the image, by eroding that dilated image, by resizing an image, and trying to crop an image using array slicing. In the next video, we're going to be talking about image transformations in OpenCV. That's translation, rotation, resizing, flipping, and cropping. So if you have any questions, leave them in the comments below. Otherwise, I'll see you guys in the next video. Hey everyone, and welcome back to this Python and OpenCV course. In this section, we're going to cover basic image transformations. And these are common techniques that you likely apply to images, including translation, rotation, resizing, flipping, and cropping. So let's start off with translation. Translation is basically shifting an image along the X and Y axis. So using translation, you can shift an image up, down, left, right, or with any combination of the above. So to translate an image, we can create a translating function. We're going to call this def translate. And this translation function will take an image to translate and take an X and Y. X and Y basically stand for the number of pixels you want to shift along the X-axis and the Y-axis respectively. So to translate an image, we need to create a translation matrix. So we're going to call this transnet is equal to np.float32, and this will take in a list with two lists inside. In the first list, we're going to say 1, 0, x and 0, 1, y. And since we're using NumPy, we can import NumPy. And once we've created a translation matrix, we can essentially get the dimensions of the image, same dimensions, which is a tuple of image.shape of 1, which is the width, and image.shape of 0, which is the height. And we can return cv.warp_affine. This will take in the image from matrix, so transnet, and it will take in the dimensions. And with that done, we can essentially translate our image. And before we do that, I do want to mention that if you have negative values for x, you are essentially translating the image to the left. Negative y values imply shifting it up. Positive x values imply shifting it to the right. And as you guessed, positive y values shifted down. So let's create our first translated image. By setting this equal to translate, we're going to pass in the image, and we're going to shift the image right by 100 pixels and down by 100 pixels. So the cv.line show, translated, and translate. Save that and run Python transformations.py. And this is your translated image. It was shifted down by 100 pixels and shifted to the right by 100 pixels. So let's change that. Let's shift the image left by 100 pixels and down by 100 pixels. So we pass in negative values for x. And it moved to the left. Feel free to play around with these values as you see fit. Just know that negative x shifts it to the left, negative y shifts it up, x shifts it to the right, and positive y values shifted down. Moving on, let's talk about rotation. Rotation is exactly what it sounds like, rotating an image by some angle. OpenCV allows you to specify any point, any rotation point that you like to rotate the image around. Usually it's the center, but with OpenCV you can specify any arbitrary point. It could be in a corner, it could be 10 pixels to the right, 40 pixels down, and you can shift the image around that point. So to rotate the image, we can create a rotating function. It's called defrotate. This will take in the image angle to rotate around and a rotation point, which we're going to set as none. So we're going to grab the height and the width of the image by setting this equal to ing.shape of the first two values. And basically, if the rotation point is none, we are going to assume that we want to rotate around the center. So we're going to say rot point is equal to width divided by 2 and height divided by 2. And we can essentially create the rotation matrix like we did with the translation matrix by setting this equal to rot.net is equal to cv.getRotation matrix 2D. We're going to pass in the center, the rotation point, an angle to rotate around, which is angle, and a scale value. Now we're not interested in scaling the image when we rotate it, so we can set this to 1.0. Finally, we can set a dimensions variable equal to the width and then the height. And we can return the rotated image, which is cv.walk affine image dot net, the destination size, which is dimensions, and that's it. That's all we need for this function. So we can create a rotated image by setting this equal to rotate, and we can rotate the original image by 45 degrees. So let's display this image, call this rotated, and pass in rotated. Save that and run. And this is your rotated image. As you can see, it was rotated counterclockwise by 45 degrees. If somehow you wanted to rotate this image clockwise, just specify negative values for this angle, and it will rotate the image right. Rotate it clockwise. Now, you can also rotate a rotated image. That is, take this image and rotate it by 45 degrees further. So let's call this rotated is equal to rotate of rotated, and we can rotate this image by another 45 degrees, so we're rotating it clockwise, and we can cv.imshow, call this rotated, and we can pass in rotated, a lot of rotated. And this is your rotated image. Now the reason why these black lines were included is because if there's no image in it, if there's no part of the image in it, it's going to be black by default. So when you took this image and rotated it by 45 degrees, you essentially rotated the image but introduced these black triangles. Now if you try to rotate this image further by some angle, you are also trying to rotate these black triangles along with it. So that's why you get these kind of skewed image, so these additional triangles are included over here. But save yourself the trouble and basically add up these angles and you'll get the final angle. So we can change that to 90 and rotate the original image by -90. And this is essentially the image that we were trying to go for. Take this image, rotate it 45 degrees clockwise, and rotate this 45 degrees image by a further 45 degrees. Save yourself the trouble and add those two angle patterns. So far we've covered two image transformations, translation and rotation. Now we're going to explore how to resize an image. Now this is nothing too different from what we discussed previously, but let's touch on it just a bit. Resizing, and we can create a resized variable and set this equal to cv.resize. We can pass in the image to resize and a destination size of maybe 500 by 500. And by default, the interpolation is cv.inter_area. You can maybe change this to inter_linear or inter_cubic. That may be a matter of preference depending on whether you're enlarging or shrinking the image. If you're shrinking the image, you would probably go for inter_area or stick with the default. If you're enlarging the image, you could probably use the inter_linear or the inter_cubic. Cubic is slower, but the resulting image is better. It's of a high quality. Again, nothing too different from what we've discussed before. So we can display this image, saying resize, and passing resize. Save that and run, and we got a resized image. Next up we have flip, how to flip an image. So we don't need to define a function for this, we just need to create a variable and set this equal to cv.flip. This will trigger an image and a flip code. Now this flip code could either be 0, 1 or -1. 0 basically implies flipping the image vertically, that is, over the x-axis. 1 specifies that you want to flip the image horizontally or over the y-axis. And -1 basically implies flipping the image both vertically as well as horizontally. So let's start with 0, flipping it vertically. Show calls flip a passing flip. Save and run. And this is the image that was flipped vertically. Let's try a horizontal flip. And we get a horizontal flip. To really see whether it was a horizontal flip, we can bring these two images together. And if they look like mirror images, then it was flipped horizontally. This is kind of a symmetric image, so it's not that obvious, but bring them together and you can maybe find out the difference. We could also try to flip the image vertically and horizontally by specifying -1 as a flip code, and the image was flipped both vertically as well as horizontally. Mirror images, but reverse mirror images. And the last method is cropping. Now we discussed cropping again, so I'm just going to touch on it. We can create a variable called cropped and set this equal to img and perform some array slicing. So 200 to 400 and 300 to 400. Save that and run. We can display this image. Either on show, it's called cropped, passing cropped. Save and run. And this is the cropped image. I'm trying to bring this together. Brought together. Okay. So that's pretty much it for this video. We talked about translating an image, rotating that image, resizing an image, flipping an image, and cropping those images. We are basically just covering the basic image transformations. There are of course way more transformations that you could possibly do with OpenCV. Just to keep this course simple and beginner friendly, I'm only covering the basic transformations. So that's it for this video. In the next video, we're going to be talking about how to identify contours in an image. So if you have any questions, leave them in the comments below. Otherwise, I'll see you guys in the next video. Hey everyone, and welcome back to another video. In this video, we're going to be talking about how to identify contours in OpenCV. Now, contours are basically the boundaries of objects, the line or curve that joins the continuous points along the boundary of an object. Now, from a mathematical point of view, they're not the same as edges. For the most part, you can get away with thinking of contours as edges. But from a mathematical point of view, contours and edges are two different things. Contours are useful tools when you get into shape analysis and object detection and recognition. So in this video, I sort of want to introduce you to the idea of contours and how to identify them in OpenCV. So the first thing I've done is I'm writing a file, an image file, and I've displayed that image using the cv.imshow method. The next thing I want to do is convert this image to grayscale by saying gray is equal to cv.cbt color img cv.color underscore bgr to gray. And we can display this. So just to know that we're on the same footing, I'm going to run this. Python contours.py. And we get a gray image. Now after this, I want to essentially grab the edges of the image using the Kenny edge detector. So I'm going to say Kenny is equal to cv.kenny. We're going to pass in the img, and we're going to give it two threshold values. So 125 and 175. And we can display this image, calling this Kenny edges, passing the Kenny. Let's save that and run. Let's save that and these are the edges that were there in the image. Now the way we find the contours of this image is by using the find contours method. Now this method basically returns two things, contours and hierarchies. And essentially this is equal to cv.find contours. So this takes in the edges, so and it takes in a mode in which to find the contours. Now this is either cv.reta_tree if you want all the hierarchical contours, or the reta external if you want only the external contours, or reta list if you want all the contours in the image. The next method we pass in is actually the contour approximation method. For now we're going to set this to cv.chain_approx_none. So let's just have a top-down look at what this function does. So essentially the cv.find contours method looks at the structuring element or the edges of a founding image and returns true values. The contours, which is essentially a Python list of all the coordinates of the contours that were found in the image, and hierarchies, which is really out of scope of this course, but essentially it refers to the hierarchical representation of contours. So for example, if you have a rectangle, and inside the rectangle if you have a square, and inside of that square you have a circle, so this hierarchies is essentially the representation that OpenCV uses to find these contours. This cv.reta list essentially is a mode in which this find contours method returns and finds the contours. Reta list essentially returns all the contours it finds in the image. We also have reta external that we discussed. Reta external retrieves only the external contours, so all the ones on the outside, it returns those. Reta_tree returns all the hierarchical contours, so all the contours that are in a hierarchical system, that is returned by reta_tree. And now I'm just going to set this to list to return all the contours. The next one we have is the contour approximation method. This is basically how we want to approximate the contour. So chain_approx none does nothing, it just returns all of the contours. Some people prefer to use chain_approx simple, which essentially compresses all the contours that are returned into simple ones that make most sense. So for example, if you have a line in an image, if you use chain_approx none, you are essentially going to get all the contours, all the coordinates of the points of that line. Chain_approx simple essentially takes all of those points of that line, compresses it into the two endpoints only, because that makes the most sense. A line is defined by only two endpoints. We don't want all the points in between. That, in a nutshell, is what this entire function is doing. So since contours is a list, we can essentially find the number of contours that were found by finding the length of this list. So we can print the length of this list. And we can say, there. We can say, these many contours found. Okay, so let's save that and run. And we find 2,794 contours in the image. And this is huge. This is a lot of contours that were found in the image. So let's do a couple of things. Let's try to change this chain_approx simple to chain_approx none and see what that does. See how that affects our length. Now there isn't any difference between those two because I'm guessing that there were no points to compress since there are a lot of edges and points in this image, so there wasn't a lot of compression. So let's change it back to simple. And actually what I want to do is I want to blur this image before I find the edges. So let's do a blur is equal to cv.gaussian blur to pass in the gray image, and we can give the kernel size of, let's do a bottom blur, so 5 by 5, and maybe we can give it body default of cv.border _default, and we can And we can display this image, call this blur, and pass in the blur. And we can find the edges on this blurred image. So let's call this blur. And as you can see, the significant reduction in the number of contours that were found just by blurring the image. So it went all the way from 2,794 to 380. That's close to 7 times just by blurring the image with the cutoff size of 555. Okay, now there is another way of finding the contours, is that instead of using this KHD vector, we can use another function in OpenCV, and that is threshold. So I'm just going to comment this out, and down here, what I'm going to do is I'm going to say ret thresh is equal to cv.threshold. This will take in the gray image, and we'll take in a threshold value of 125 and a maximum value of 255. Don't worry too much about thresholding for now. Just know that thresholding essentially looks at an image and tries to binarize that image. So if a particular pixel is below 125, if the intensity of that pixel is below 125, it's going to be set to 0 for black. If it is above 125, it is set to white, 255. That's all it does. And in the find contours method, we can essentially pass in the thresh value. So let's save that. Let's close this out and try to run that. Okay, threshold is okay, I think I forgot one part. We're going to specify a thresholding type. So this is cv.thresh underscore binary. Wait, binarizing the image basically. Let's run that. And there were 839 contours that were found. We can visualize that. Let's print. Let's display this thresh image. Passing in and this was the thresholded image. Using 125, using 125 as our threshold value and 255 as our maximum value, we got this thresholded image. When we try to find the contours on this image, we got 839 contours. Now, don't worry too much about this thresholding business. We'll discuss this in the advanced section of this course more in depth. Just know that thresholding attempts to binarize an image. Take an image and convert it into binary form. That is either 0 or black, or white, or 255. Now, what's cool in OpenCV is that you can actually visualize the contours that were found on the image by essentially drawing over the image. So what I'm going to do real quick is actually import NumPy. NumPy as NP. And after this, I'm going to create a blank variable and set this equal to np.zeros of image.shape of the first two values. Maybe give it a good time of, I don't know, uint8. We can display this image. Also blank. Just to visualize how a blank image would work. Save that and go to a blank image. This is of the same dimensions as our original cat's image. So what I'm going to do is I'm going to draw these contours on that blank image so that we know what kind of contours that OpenCV found. So the way we do that is by using the cv.drawContours method. It takes in an image to draw over, so blank. It takes in the contours, which has to be a list, which is, in this case is just the contours list. It takes in a contour index, which are basically how many contours do you want in the image. Since we want all of them, since we want to draw all of them, we can specify make it 1. Give it color. Let's set this to BGR, so let's set this to red, 0,255. And we can give it a thickness of 2, and we can display the blank image. Let's call this contours drawn, and we can pass it blank. Save that and run. Okay, there is an error. This has to be shape. Okay, so these were the contours that were drawn on the image. And if you take a look at threshold value, threshold image, it's not the same thing. What I believe it attempts to do is instead it found the edges of this image, all the edges of this image, and attempted to draw it out on this blank image. Let's set this. So let's set the thickness to maybe 1, so that we have a crisper view. Okay, so these were the contours that were drawn in the image. And in fact, if you try to visualize it with the pen, let's actually visualize that with pen. Uncomment that out, run. There's one. Okay, image. Let's look at Kenny. Okay, it's not the same thing. And that makes sense because our find contours method didn't use Kenny as a basis of detecting and finding the contours. But we can do that. Let's not use a thresholding method, and instead let's use Kenny. So we can pass on Kenny here. Save that and run. And okay, they're pretty much the same thing, right? It's basically a mirror image of these two. Like I said, you can get away with thinking of contours as edges. They're not the same thing, but you can think of them as edges because from a programming point of view, they are kind of like the edges of the image, right? They are the boundaries, they are curves that join the points along the boundary. Those are basically edges. So let's try to blur that image. Now let's uncomment that out. Let's see what that does. I think that's anything. Okay, 380 contours have found and mirror images of each other. So generally what I recommend is that you use Kenny method first and then try to find the contours using that, rather than try to threshold the image and then find the contours of that. Because like we'll discuss in the advanced section, this type of thresholding, the simple thresholding, has its disadvantages. Maybe because we're passing a simple, just one value, try to binarize the image using this threshold value. Right? It's not the most ideal, but in some cases, in most cases, it is the most favored kind of thresholding because it's the simplest and it does the job pretty well. So that's pretty much it for this video. We talked about how to identify contours in OpenCV, but in two methods. First, trying to find the edge cascades of the image using the Kenny edge detector, and trying to find the contours using that, and also trying to binarize that image using the CV.threshold and finding the contours of that. So, if you have any questions, leave them in the comments below. I'll be sure to check them out. Otherwise, as always, I'll see you guys in the next video. Hey everyone, and welcome back to another video. We are now at the advanced section of this course, where we are going to discuss the advanced concepts in OpenCV. So what we're going to be doing in this video is actually discussing how to switch between color spaces in OpenCV. Now, color spaces are basically a space of colors, a system of representing an array of pixel colors. RGB is a color space, grayscale is a color space. We also have other color spaces like HSV, LAB, and many more. So let's start off with trying to convert this image to grayscale. So we're going to convert from a BGR image, which is OpenCV's default way of reading of images, and we're going to convert that to grayscale. So the way we do that is by saying gray is equal to cv.cvt color. We pass in the image and we specify a color code, which is cv.color underscore BGR to gray, since we're converting from a BGR image format to grayscale format. And we can display this image by saying gray and passing in gray. Let's save that and run. Python spaces.py. as a comma. Save. And this is the grayscale version of this BGR image. Cool, pretty cool. Grayscale images basically show you the distribution of pixel intensities at particular locations of your image. So, let's start off with trying to convert this image to an HSV format. So from BGR to HSV. HSV is also called hue saturation value and is kind of based on how humans think and conceive of color. So the way we convert that is by saying HSV is equal to cv.cvt color. We pass in the ing variable and we specify a color code, which is cv.color underscore BGR to HSV. And we can display this image as HSV and pass in HSV. Let's save that. And this is the HSV version of this BGR image. As you can see, there is a lot of green in this area and the skies are reddish. Now we also have another kind of color space, and that is called the LAB color space. We're going to convert from BGR to LAB. This is sometimes represented as L times A times B, but feel free to use whatever you want. So LAB is equal to cv.cvt color, we pass the imaging, and the color underscore BGR to LAB. Show, call this LAB, and pass in LAB. Just run back. And this is the LAB version of this BGR image. This kind of looks like a washed down version of this BGR image, but hey, that's the LAB format. It's not true to how humans perceive color. Now when I started off with this course, I mentioned that OpenCV reads in images in a BGR format, that is blue, green and red. And that's not the current system that we use to represent colors outside of OpenCV. Outside of OpenCV, we use the RGB format, which is kind of like the inverse of the BGR format. Now, if you try to display this ING image in a Python library that's not OpenCV, you're probably going to see an inversion of colors. And we can do that real quick. Let's try to import matplotlib.pyplot as PLT. And we can basically comment that out, and we can try and display this image variable. So we're going to say plc.imshow, pass the image, and we can say plc.show. Maybe let's comment this out. Save that and run. And this is the image you get. Now, if you compare with the image that OpenCV read, this is completely different. These two are completely different images. And the reason for this is because this image is a BGR image and OpenCV displays BGR images. But now if you try to take this BGR image and try to display it in Matplotlib, for instance, Matplotlib has no idea that this image is a BGR image and displays that image as if it were an RGB image. So that's why you see an inversion of color. So where there's red over here, you see a blue. Where there's blue over here, you see a red. And there are ways to convert this from BGR to RGB, and that is by using OpenCV itself. So let's comment that out, and let's uncomment this all out. And right over here, let's say BGR to RGB. And what we're going to say is RGB is equal to cv.cvt color. We can pass in the BGR image. We can pass in the BGR image, and what we're going to do is specify a color code, which is cv.color underscore BGR to RGB. And we can try to display this image in OpenCV and see what that displays. RGB. And we can also display this in Matplotlib. So let's pass in RGB, and we can do plt.show. Save that. Let's do Python spaces.py. What I'm most interested in is this and this. Now, again, you see an inversion of colors, but this time in OpenCV. Because now you provided OpenCV an RGB image, and it assumed it was a BGR image, and that's why there's an inversion of colors. But we passed in the RGB image to Matplotlib, and Matplotlib's default is RGB, so that's why it displayed the pop-up image. So just keep this in mind when you're working with multiple libraries, including OpenCV and Matplotlib, for instance, because do keep in mind the inversion of colors that tends to take place between these two libraries. So, now another thing that I want to do is we've essentially converted the BGR to grayscale. We've essentially converted BGR to HSV, BGR to LED, BGR to RGB. What we can do is we can do the inverse of that. We can convert a grayscale image to BGR. We can convert an HSV to BGR. We can convert an LED to BGR, and RGB to BGR, and so on. But here's one of the downsides. You cannot convert a grayscale image to HSV directly. If you wanted to do that, what you have to do is convert the grayscale to BGR, and then from BGR to HSV. So we're going to do that real quick. We're going to say HSV to BGR. Okay? So the first thing we do is HSV underscore BGR, basically converting from HSV to BGR, is equal to cv.cvt color. This will take in the HSV image, and the color code will be color underscore HSV to BGR. And we can display this image. Let's call this HSV to BGR, and pass in HSV underscore BGR. Okay, we're not interested in this. But essentially, this is the HSV to BGR. This was the HSV image. We converted this image to BGR. And we can try this with LAB. So let's call this LAB to we can get rid of that. Okay, then what with HSV LAB to BGR. That was my mistake. Cool. So if this was the LAB version, this is the LAB to BGR version. Back from BGR to LAB and from LAB to BGR. So that's pretty much it for this video. We discussed how to convert between color spaces from BGR to grayscale, HSV, LAB, and RGB. And if you want to convert from grayscale to LAB, for instance, note that there is no direct method. What you could do is convert that grayscale to BGR, and then from BGR to LAB. That's possible. But directly, I don't think there is a way to do that. If OpenCV could come up with a feature like that, it would be good. But it's not going to hurt you to write extra lines of code. At least 2 or 3 lines of code extra. What really hurts? In the next video, we'll be talking about how to split and merge color channels in OpenCV. If you have any questions, leave them in the comments below. Otherwise, I'll see you guys in the next video. Hey everyone, and welcome back to another video. In this video, we're going to be talking about how to split and merge color channels in OpenCV. Now, a color image basically consists of multiple channels: red, green, and blue. All the images you see around you, all the BGR or the RGB images, are basically these 3 color channels merged together. Now, OpenCV allows you to split an image into its respective color channels. So you can take a BGR image and split it into blue, green, and red components. So that's what we're going to be doing in this video. We're going to be taking this image of the path that we had seen in previous videos, and we're going to split that into its 3 color channels. So the way we do that is by saying B, G, R, which stand for the respective color channels, and set this equal to cv.split of the image. So the cv.split basically splits the image into blue, green, and red. And we can display this image by saying cv.imShow Let's call this blue and pass in blue. And let's do the same for green image and pass in blue. And we can do the same for the red part. So R. And we can actually visualize the shapes of these images. So let's first print the image shape, and then print the V shape, and then print the G shape, and then print the R shape. Basically, we're printing the shapes and dimensions of the image and the blue, green, and red. And we're also displaying these images. So let's run Python split merge.py. And these are the images that you get back. This is the blue image, this is the green image, and this is the red image. Now these are depicted and displayed as grayscale images that show the distribution of pixel intensity. Regions where it's lighter show that there is a far more concentration of those pixel values, and regions where it's darker represent that there are little or even no pixels in that region. So take a look at the blue channel first, and if you compare it with the original image, you will see that the sky is kind of almost white. This basically shows you that there is a high concentration of blue in the sky, and not so much in the trees or the grass. Let's take a look at the green, and there is a fairly even distribution of pixel intensities between the grass, the trees, and some parts of the sky. And take a look at the red color channel, and you can see that parts of the trees that are red are whiter. The grass and the sky are not that white in this red image. So this means that there is not much red color in those regions. Now, coming back, let's take a look at the shapes of the image. Now, this stands for the original image, the BGR image. The additional elements in the tuple here represents the number of color channels. 3 represents 3 color channels, blue, green, and red. Now if we proceed to display the shapes of BG and R components, we don't see a 3 in the tuple. That's because the shape of that component is 1. It's not mentioned here, but it is 1. That's why when you try to display this image using CV.io show, it displays it as a grayscale image, because grayscale images have the shape of 1. Now, let's try and merge these color channels together. So the way we do that is by saying the merged image is equal to cv.merge, and what we do is we pass in a list of blue, G, R. Let's save that, let's display that, and cv.onshow, call this the merged image, and we can pass in merged. So let's save that and run. And we get that merged image by basically merging the 3 individual color channels, red, green, and blue. Now, there is an additional way of looking at the actual color there is in that channel. So instead of showing you grayscale images, it shows you the actual color involved. So for the blue image, you get the blue color channel. For the red channel, you get the red color for that channel. And the way we do that is we actually have to reconstruct the image. The shapes of these images are basically grayscale images. But what we can do is we can actually create a blank image using NumPy. And essentially what we're going to do is we're going to say blank is equal to input.0, and we're going to set this to the shape of the image, but only the first 2 values, and we can give it a data type of 8, which basically are for images. And to print the blue color channel, what we're going to do is we're going to say blue is equal to cv.merge. We're going to pass in a list of blank, and we're going to do the same thing for green, and set this equal to cv.merge of blank, G, blank, and we're going to do the same thing for red by setting this equal to cv.merge of blank, red. Basically what I've done is this blank image basically consists of the height and the width, not necessarily the number of colored channels in the image. So by essentially merging the blue image in its respective compartment, so blue, green and red, we are setting the green and the red components to black and only displaying the blue channel. And we're doing the same thing for the green by setting the blue and the red components to black, and the same thing for red by setting the blue and the green components to black. And we can display this by saying blue, green, and red. Let's save that. And now you're asked to get the color in its respective color channel. Taking a look at this, you will now be able to visualize the distribution much better. Here you can see lighter portions represent a high distribution. Lighter portions here represent a high distribution of red, and the wider regions represent a high distribution of green. So essentially, if you take these three images of these color channels and merge them together, you essentially get back the merged image. So that's pretty much it for this video. We discussed how to split an image into its three respective color channels, how to reconstruct the image to display the actual color involved in that channel, and how to merge those color channels back into its original image. In the next video, we'll be talking about how to smooth and blur an image using various blurring techniques. If you have any questions, leave them in the comments below. Otherwise, I'll see you guys in the next video. Hey everyone, and welcome back to another video. In this video, we're going to address the concepts of smoothing and blurring in OpenCV. Now before, I mentioned that we generally smooth an image when it tends to have a lot of noise. And noise that's caused from camera sensors, or basically problems in lighting when the image was taken. And we can essentially smooth out the image or reduce some of the noise by applying some blurring method. Now previously we discussed the Gaussian blur method, which is kind of one of the most popular methods in blurring, but generally you're going to see that Gaussian blur won't really suit some of your purposes. And that's why there are many blurring techniques that we have, and that's what we're going to address in this video. Now before we actually do that, I do want to address a couple of concepts. Let's actually go to an image and discuss what exactly goes on when you try to apply blur. So essentially the first thing that we need to define is something called a kernel, or a window. That is essentially this window that you draw over an image. So this is essentially a window that you draw over a specific portion of an image, and something happens on the pixels in this window. I'll change that to blue. So essentially this window has a size. This size is called a kernel size. Now, kernel size is basically the number of rows and the number of columns. So over here we have 3 columns and 3 rows. So the kernel size for this is 3 by 3. Now, essentially what happens is that we have multiple methods to apply some blur. So essentially blur is applied to the middle pixel as a result of the pixels around it, also called surrounding pixels. So something happens here as a result of the pixels around the surrounding pixels. So with that in mind, let's go back and discuss the first method of blurring, which is averaging. So essentially averaging is we define a kernel window over a specific portion of an image. This window will essentially compute the pixel intensity of the middle pixel of the true sensor and the average of the surrounding pixel intensities. So if this was, green. Suppose if this pixel intensity was 1, this was maybe 2, this is 3, 4, 5, 6, 7, 8 to that point. Essentially the new pixel intensity for this region will be the average of all the surrounding pixel intensity. So that's summing up 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 and dividing that by 8. which is essentially the number of surrounding pixels. And we essentially use that result as the pixel intensity for the middle value, or the true center. And this process happens throughout the image. So this window basically slides to the right, and once that's done, it slides down and computes it basically for all the pixels in the image. So let's try to apply and see what this does. So what we're going to do is we're going to say average is equal to cv.blur. The cv.blur method is a method in which we can apply averaging blur. So we define the source image, which is RG, we give a kernel size of, let's say, 3 by 3, and that's it. We can display this image, call this average blur, save that and run. Python smoothing.py. Max, gosh. Pass an average, save that and run. And this is basically the average blur that's applied. So what the algorithm did in the background was essentially define a kernel window of the specified size, so 3 by 3, and it computed the center value for a pixel using the average of all the surrounding pixel intensities. And the result of that is we get a blurred image. So the higher kernel size we specify, the more blur there is going to be in the image. So let's increase that to 7 by 7 and see what that does. And we get an image with way more blur. So let's move on to the next method, which is the Gaussian blur. So Gaussian basically does the same thing as averaging, except that instead of computing the average of all of the surrounding pixel intensity, each surrounding pixel is given a particular weight. And essentially the average of the products of those weights give you the value for the true center. Now using this method, you tend to get less blurring than compared to the averaging method, but the Gaussian blur is more natural as compared to averaging. So let's print that out. Let's call this Gauss and set this equal to cv.Gaussian blur. And this will take in the source image, so IMG, the kernel size of 7 by 7, just to compare it with the averaging. And another parameter that we need to specify is sigma x, or basically the standard deviation in the x direction, which for now we're just going to set as 0. And we can print that out, call this Gaussian blur, and pass it x, save that and run. If you compare with this, you see that both of them use the same kernel size, but this is less blurred as compared to the averaging method. And the reason for this is because a certain weight value was added when computing the blur. Okay, so let's move on to the next method, and that is median blur. So let's go back to our image. And median blurring is basically the same thing as averaging, except that instead of finding the average of the surrounding pixels, it finds the median of the surrounding pixels. Generally, median blurring tends to be more effective in reducing noise in an image as compared to averaging and using Gaussian blur. And it's pretty good at removing some salt and pepper noise that may exist in the image. Generally, people tend to use this image in advanced computer vision projects that tend to depend on the reduction of substantial amount of noise. So let's go back here, and the way we apply the blur is by saying, let's call this median, and set this equal to cv.median blur. We pass in the source image, and this kernel size will not be a tuple of 3 by 3, but instead just an integer of 3. And the reason for this is because OpenCV automatically assumes that this kernel size will be a 3 by 3 just based off this integer. And we can print this out, let's call this median blur, and pass it. And let's compare with that, so let's have that to 7. And comparing it with Gaussian blur and averaging blur, you tend to look at this and you can make out some differences between the two images. So it's like as if this was your painting and it was still drying, and you take something and smudge over the image and you get something like this. Now generally median blurring is not meant for high kernel sizes like 7 or even 5 in some cases, and it's more effective in reducing some of the noise or the image. So let's change this all to 3 by 3. Let's copy that. And we can change that to 3. Now let's have a comparison between the 3. This is your Gaussian blur, this is your averaging blur, this is your median blur. So compared with these two, you can see that there is kind of less blurring than Gaussian, but you can sort of make out the differences between the two. It's very subtle, but there are a couple of differences between the two. Finally, the last method we're going to discuss is bilateral blurring. Now, bilateral blurring is the most effective and sometimes used in a lot of advanced computer vision projects, essentially because of how it blurs. Now, traditional blurring methods basically blur the image without looking at whether you're reducing edges in the image or not. Bilateral blurring applies blurring, but retains the edges in the image. So you have a blurred image, but you get to retain the edges as well. So let's call this bilateral. And set this equal to cv.bilateral filter. And we pass in the image, we give it a diameter of the pixel neighborhood. Now notice this isn't a kernel size, but in fact a diameter. So let's set this to 5 for now. Give it a sigma color, which is basically the color sigma color. A larger value for this color sigma means that there are more colors in the neighborhood that will be considered when the blur is computed. So let's set this to 15 for now. And sigma space is basically your space sigma. Larger values of this space sigma means that pixels further out from the central pixel will influence the blurring calculation. So let's set this to 15. So let's take a look at that sigma space thing. So for example, in bilateral filtering, if this is the value for this central pixel or the true center is being computed, by giving larger values for the sigma space, you essentially are indicating that whether you want pixels from this far away, or maybe this far away, or even this far away from influencing this particular calculation. So if you give like really huge numbers, then probably a pixel in this region might influence the computation of this pixel value. So let's set this to 15 for now, and let's display this image. So call the cv.onShow. Let's call this bilateral and pass in bilateral. Save that and run. And this is your bilateral image. So let's compare with all the previous ones that we had. Compared with this, much better. Compared with average, way much better. Let's compare with median. The edges are still there. It's slightly blurred. If you compare it with the original image, they kind of look the same thing. Okay, it kind of looks like there's no blur applied. So maybe let's increase this diameter to, I don't know, 10. And not much was done. The edges are still there. It kind of looks like the original image itself. So let's try and tune one of the other parameters. Let's set this to 35. Let's set this to 25. We're really playing around with these values. And now you can basically make out that this is starting to look a lot like median blur. When you give it large values, it's starting to show you that this is more looking like a smudged painting version of this image. Right? There's a lot of blur applied here, but the cats are looking smudged. So definitely keep that in mind when you are trying to apply blurring image, especially with bilateral and median blurring, because higher values of the space sigma for bilateral or the kernel size for median blurring, and you tend to end up with a washed up, smudged version of this image. So definitely keep that in mind. But that kind of summarizes whatever we've done in this video. We discussed averaging, Gaussian, median, and bilateral load. So in the next video, we'll be talking about bitwise operators in OpenCV. So again, like always, if you have any questions, leave them in the comments below. Otherwise, we'll see you guys in the next video. Hey everyone, and welcome back to another video. In this video, we're going to be talking about bitwise operators in OpenCV. Now, there are 4 basic bitwise operators: AND, OR, XOR, and NOT. If you've ever taken an introductory CS course, you will probably find these terms familiar, bitwise operators, and they are in fact used a lot in image processing, especially when we're working with masks like we'll do in the next video. So at a very high level, bitwise operators operate in a binary manner. So a pixel is turned off if it has a value of 0 and is turned on if it has a value of 1. So let's actually go ahead and try to import NumPy as NP. And what I'm going to do is I'm going to create a blank variable and set this equal to np.zeros of size 400 by 400. And we can give the data type of uint8. Is what I'm going to do is I'm going to use this blank variable as a basis to draw a rectangle and draw a circle. So I'm going to say rectangle is equal to cd.rectangle. We can say blank.copy, and we can pass in the starting point. So let's give the margin of around 30 pixels on either side. So we're going to start from 30, and we can go all the way across to 370, 370. And we can give a color. Since this is not a color image but rather binary image, we can just give it one parameter, so 255, white, and give it a thickness of -1 because we want to fill this image. And then I'm going to create another circle variable and set this equal to cd.circle. I'm going to say blank copy. We are going to give it a center, so the center will be the absolute center, so 200 by 200. Let's give it a radius of 200 and give it a color of 255. And let's fill in the circle, so -1. So let's display this image and see what we're working with. So I'll call this rectangle and pass in the rectangle. I'm going to do the same thing with the circle. Let's call this circle and pass in the circle. Save that and run. Python bitwise.py. So we have 2 images that we're going to work with. This image of a rectangle and this image of a circle. So let's start off with the first basic bitwise operator, and that is bitwise AND. So before I actually discuss what bitwise AND really is, let me show you what it does. So essentially what I'm going to do is I'm going to say bitwise underscore AND is equal to cb.bitwise AND. And basically what I have to do is pass in 2 source images. That are these 2 images, rectangle and circle. Now we can display this image. Let's call this bitwise AND. Let's pass in bitwise AND. Save. Run, and essentially you get back this image. So essentially what bitwise AND did was it took these 2 images, placed them on top of each other, and basically returned the intersection. Right? And you can make out, when you take this image, put it over this image, you have some triangles that are not common to both of these images, and so those are set to black or 0, while the common regions are returned. So the next one is basically bitwise OR. Now bitwise OR really simply returns both the intersecting as well as the non-intersecting regions. So let's try this. Bitwise OR is equal to cb.bitwise underscore OR. We pass in rectangle, we pass in circle, and we can print that. Let's close bitwise OR and pass in bitwise OR. Save that and run. And bitwise OR. Okay, this is bitwise OR. Okay, so bitwise OR basically returned this funky looking shape. Essentially what it did is it took these two images, put them over each other, found the common regions, and also found the regions that are not common to both of these images, and basically superimposed them. Basically, you can just put them together and find the resulting shape, and this is what you get. Put this image over this, and you get this. Moving on. The next one is bitwise XOR, which basically is good for returning the non-intersecting. So this found the intersecting regions. This found non-intersecting regions, and XOR only finds the non-intersecting regions. So let's do that. Let's say bitwise XOR is equal to cv.bitwise underscore XOR. We pass in the rectangle, and we pass in the circle. Now we can display this. cv.circles bitwise XOR, and you can pass in bitwise XOR. Save that and run. And here we have the non-intersecting regions of these two images when you put them over each other. Pretty cool. And just to recap, this bitwise AND again returns the intersecting regions. Bitwise OR returns the non-intersecting regions as well as the intersecting regions. Bitwise XOR returns the non-intersecting regions. So essentially, if you take this bitwise XOR and subtract it from bitwise OR, you get bitwise AND. And conversely, if you subtract bitwise AND from bitwise OR, you get bitwise XOR. So essentially, that's a good way of visualizing what exactly happens with these bitwise operators. And finally, the last method we can discuss is bitwise NOT. Essentially, it doesn't return anything. What it does is it inverts the binary color. So let's do that. So let's call this bitwise NOT is equal to cv.bitwise underscore NOT. And this only takes in one source image. So let's set this to the rectangle for now. And we can display this. Rectangle NOT bitwise NOT. See that and basically what it did is, if you look at this image, it found all the white regions, all the white pixels in the image, and inverted them to black. And all the black images, it inverted to white. Essentially, it converted white to black and from black to white. So we can try that with this circle, save and run, and the resultant circle NOT that you get is this. This is a white hole, this is a black hole. Or this is a circle. Okay, so that's pretty much it for this video. I just wanted to introduce you all to the idea of bitwise operations and how it works. In the next video, we'll be actually talking about how to use these bitwise operations in a concept called masking. So if you have any questions, leave them in the comments below. Otherwise, I'll see you guys in the next video. Hey everyone, and welcome back. In this video, we're going to be talking about masking in OpenCV. Now in the previous video, we discussed bitwise operations. And using those bitwise operations, we can essentially perform masking in OpenCV. Masking essentially allows us to focus on certain parts of an image that we'd like to focus on. So for example, if you have an image of people in it, and if you're interested in focusing on the faces of those people, you could essentially apply masking and essentially mask over the people's faces and remove all the unwanted parts of the image. So that's basically a high-level intuition behind this. So let's actually see how this works in OpenCV. So I basically read the file and I've displayed that image. The other thing I want to do is I want to import numpy as np. What I'm going to do is I'm going to say blank is equal to np.zeros of size image dot shape first values. Now this is extremely important. The dimensions of the mask have to be the same size as that of the image. If it isn't, it's not going to work. And we can give a data type of UID. If you want to display this, we can display this. It's just going to be a blank image. It's a blank image and passing blank. Essentially what I'm going to do is I'm going to draw a circle over this blank image and call that my mask. So I'm going to say mask is equal to cb.circle. I'm going to draw on the blank image. On the blank image, we can give the center of this image. So let's say image.shape of 1 divided by 2, and image.shape of 2, image.shape of 0 divided by 2. And we can give the radius of, let's say 100 pixels, give it a color of 255, give it a thickness of -1. And we can visualize our mask as mask and passing mask. Let's run that. Python masking.py. And this is essentially our mask. There's the blank image we're working with, and this is the image that we want to mask over. So let's actually create a masked image. We're going to say masked image is equal to cv.bitwise underscore end. There's source image, so img, and we specify the parameter mask is equal to mask, which is this circle image over here. And we can display this image, call this masked image, and we can pass in masked. Save that and run. And this is essentially your masked image. You took this image, you put this image over it, and found the intersecting region. Okay, by optionally passing the mask is equal to mask. That's exactly what we're doing. Cool. Let's try and play around with this. Let's maybe move this by a couple of pixels around. So let's say 45. Save and run. This is 45. And we get the cat. We can draw a circle. We can draw a rectangle instead. Let's pass on blank. That. Give it that and draw. Give it a starting endpoint of copy this and a couple of pixels. So maybe 100 pixels this way and 100 pixels this way. This is the square, and this is essentially the masked image. So let's actually try this with a different image. So here I've got an image. Let's try it with EBS Cats 2. And this is the mask that we get by putting these two over each other. And essentially you can play around with these as you feel fit. You can maybe try different shapes, weird shapes. And the way you can get these weird shapes is essentially creating a circle, a rectangle, and applying bitwise and you get this weird shape. And then you can use that weird shape as your mask. So let's just try that. Let's try that. We're gonna say let's call this circle. Copy. And let's create a rectangle. Let's just grab from this bitwise. Let's bits. Paste that there. I'm going to copy 33. Okay. So let's create this weird shape is equal to cv.bitwise of this circle, this rectangle, and we don't need to specify anything else. Let's try to visualize this. Let's close this out. Try to see the weird shape, possibly weird shape. Run. Mask not defined. This mask. This mask. This is the weird shape that we get. We're not really going for a half moon. Hey, whatever. Use this weird shape as a mask. So use weird shape as a mask. That's the final mask. And this is essentially your weird shape masked image. Let's call this a weird shape masked image. Weird shaped masked image. This little half moon here. And essentially you can do pretty much anything you want with this. You can experiment with various shapes and sizes and stuff like that. But just know that the size of your mask has to be of the same dimensions as that of your image. If you want to see why, let's maybe subtract 100 pixels. No, not maybe, like subtract 2. Okay, so let's just say image.shape of 1. Okay, let's just give it a different size. Why are we using? Let's give it a size of 300 by 300. Definitely not the size of this. And we get this. Assertion failed, m-type blah blah blah, mask.same size. Function, whatever. So essentially, these need to be of the same size, otherwise it's going to fail and throw you an error. So that's it for this video. We talked about masking. Again, nothing too different. We've essentially used the concept of bitwise and from the previous video. And you'll see that when we move on to computer histograms in the next video, where masking really comes into play and how masking really affects your histograms. So if you have any questions, again, leave them in the comments below. Otherwise, I'll see you in the next video. Hey everyone, and welcome back to another video. In this video, we're going to be talking about computing histograms in OpenCV. Now, histograms basically allow you to visualize the distribution of pixel intensities in an image. So whether it's a color image or whether it's a grayscale image, you can visualize these pixel intensity distributions with the help of a histogram, which is kind of like a graph or a plot that will give you a high-level intuition of the pixel distribution in the image. So we can compute a histogram for grayscale images and compute a histogram for RGB images. So we're going to start off with computing histograms for grayscale images. And so let's just convert this image to grayscale. So cvd.cvd color. Let's pass the image and give it a code of color underscore BGR to gray. Display this image. And pass gray. Now, to actually compute the grayscale histogram, what we need to do is essentially call this gray underscore hist and set this equal to cv.calc hist. This method will essentially compute the histogram for the image that we pass it to. Now this images is a list, so we need to pass in a list of images. Now since we're only interested in computing a histogram for one image, let's just pass in the grayscale image. The next thing we have to pass in is the number of channels, which basically specify the index of the channel we want to compute a histogram for. Now, since we are computing a histogram for a grayscale image, let's wrap this as a list and pass in 0. The next thing we have to do is provide a mask. Do we want to compute a histogram for a specific portion of an image? We will get to this later, but for now, just set this to none. Hist size is basically the number of bins that we want to use for computing the histogram. Essentially, when we plot a histogram, I'll talk about this concept of bins. But essentially, for now, just set this to 256, wrapped as a list. So let's wrap that as a list. And the next thing I want to do is specify the range of all possible pixel values. Now for our case, this will be 0 to 256. And that's it. So to plot this image, let's actually use matplotlib. So import matplotlib.pyplot as PLT. And then we can instantiate our PLT.figure, a PLT figure. Let's give it a title. Call this Grayscale histogram. We can essentially give it a label across the x-axis, and we're going to call this bins. Let's give this a y label and set this equal to the number of pixels. And that's one label. And finally we can plot by saying plc.plot the grayscale histogram. And finally we can essentially give it a limit across the x-axis, so plt.xlim of a list of 0 to 256. And finally we can display this image, so plt.show. Save that and run. Python histogram.py. And this is the distribution of pixels in this image. As you can see, the number of bins across the x-axis basically represent the intervals of pixel intensities. So as you can see that there is a peak at this region. This means that this is closely at 50-60-ish. So this means that in this image there are close to 4,000 pixels that have an intensity of 60. And as you can see that there's a lot of peaking in this region. So between probably 40 to 70, there's a peak of pixel intensities of close to 3,000 pixel intensities in this image. So let's try this with a different image. Let's try this with the cats. Let's go to 2. Save that and run. And there is a peaking of pixel values in between 200 and 225. And this makes sense because most of the image is white. So given that reason, you can probably deduce that there will be a peaking towards white to 255. So this is essentially computing the grayscale histogram for the entire image. And what we can do is we can essentially create a mask and then compute the histogram only on that particular mask. So let's do that. Let's go back to masking. Let's grab this. Let's go right up there. Set this to image.shape of the first two values. The sizes are the same. Let's essentially draw a mask, which will be cv.circle of blank, and we get a sensor of image.shape of 1 divided by 2, image.shape of 0 divided by 2, give the radius of 5 pixels, give a color of 2.5, give the thickness of 3. We can display a mask. Let's call this mask. And here's where things get interesting. We compute the grayscale histogram for this mask. And the way we do that is by setting this mask parameter to mask. So instead of none, we set this to mask. And let's see what that does to our histogram. And please not great. Save that. Yeah, I kind of made a mistake here. This is the mask. It's not exactly. This is a circle. This will be a circle. And essentially we need to mask out the image. So the way we do that is by creating a mask and setting this equal to cv.bitwise underscore, and we can pass in the grayscale image, and we can pass in the mask, which is equal to circle. Now we can use that as the mask. So let's Sorry, I made a mistake, but probably things should be fine right now. So this is the mask, and this is the histogram computed for this particular mask. As you can see, that there is a peaking of pixel intensity values in this region, and there are smaller peakings in these regions down below. Let's try this with another image. Let's pass the cats.jpg. This is our mask, and this is the there is a peaking in this image towards 50. Okay, so that was it for computing grayscale histograms. Let's move on to try to compute a color histogram. That is to compute a histogram for a color image, so an RGB image. So let's call this color histogram. And the way we do that is, instead of converting this image to grayscale, let's convert all of this out. We use the mask. All of this out. This mask will be fine. So let's start with the color histogram. The way you do that is, let's define a tuple of colors and set this equal to B, then tuple of G, a tuple element of R. And what I'm going to do next is, I'm going to say for I, call in enumerate of colors. What I'm going to do is, I'm going to say hist, so I'm going to plot the histogram by saying cv.calc hist. I'm going to compute it over the image itself. The channels will be I mean this I over here. We're going to provide a mask of none for that, give it a hist size of 256, and give it ranges of 0 to 256. And then let's do a plt dot plot hist, and give it a color equal to col, and finally we can do a plt dot xlen of 0 to 256. And for this purpose we can essentially go down this, uncomment this out, and we can do a plt dot show. So this should work. We're not computing this histogram for a mask. We do that next. Let's save that and run. Cool. And let's close it on. Let's say this is a shouldn't make much of a difference. So this is the color histogram that we get for the original image, not for a mask, but in fact this image. So as you can see, that this color image basically computed the plot for the blue channel, the red channel, and the green channel as well. So using this, you can basically make out that there is a peaking of blue pixels that have a pixel intensity of 30. There's a peaking of red at probably around 50, peaking of green probably around 80, 75 to 80. Cool, and using this you can basically make up the distribution of pixel intensities of all three color channels. So let's try and apply mask. Mask anything is equal to mask. Let's see whether we have everything bottoms. Mask are not the same size. Okay, I finally got the error. So basically the mask needs to be a binary format. So instead of passing in this mask, this will actually be the masked image. We can pass this with that mask, and we can change the circle to mask. Now this should work without any errors. And we can change that to masked. And that's around that. And now we get the color histogram for this particular mask. I made a mistake because I used this as my mask to compute the histogram for one channel. The problem was this masked image was actually of 3 channels, and I attempted to use these 3 channel mask to calculate the histogram per channel, which isn't allowed in OpenCV. So that was my mistake. I kind of used the wrong variable names, so I got confused. But essentially this is it. You're computing the histogram for a particular section of this image, and this is what you get. There is a high peaking of red in this area, high peaking of blue in this area, and high peaking of green in some other area. So essentially that's it for this video. Histogram is actually allowing you to analyze the distribution of pixel intensities, whether for a grayscale image or for a colored image. Now these are really helpful in a lot of advanced computer vision projects when you're actually trying to analyze the image that you get and maybe trying to equalize the image so that there's no peaking of pixel values here and there. In the next video we'll be talking about how to threshold an image and the different types of thresholding. As always, if you have any questions, leave them in the comments below. Otherwise, I'll see you guys in the next video. Hey everyone, and welcome back to another video. In this video, we're going to be talking about thresholding in OpenCV. Now, thresholding is the binarization of an image. In general, we want to take an image and convert it to a binary image. That is, an image where pixels are either 0 or black, or 255 or white. Now, a very simple example of thresholding would be to take an image and take some particular value that we're going to call the thresholding value, and compare each pixel of the image to this thresholded value. If that pixel intensity is less than this threshold value, we set that pixel intensity to 0, and if it is above this thresholded value, we set it to 255 or white. So in this sense, we can essentially create a binary image just from a regular standalone image. So in this video, we're actually going to talk about 2 different types of thresholding: simple thresholding and adaptive thresholding. So let's start off with simple thresholding. So in essence, what I want to do is, before I talk about simple thresholding, is I want to convert this BGR image to grayscale. So I'm going to say gray is equal to cv.cvt color. We pass in the image, we pass in the color code, which is BGR gray. We can display this image, call this gray, and gray. Cool. So let's start off with the simple thresholding. So essentially, to apply this idea of simple thresholding, we essentially use the cv.threshold function. Now this function returns threshold and thresh, which is equal to cv.threshold, and this in essence takes in the grayscale image. The grayscale image has to be passed in to this thresholding function. Then what we do is we pass in a thresholded value. So let's set this to 150 for now, and we have to specify something called a maximum value. So if that pixel value is greater than 150, what do you want to set it to? In this case, we want to binarize the image, so we set it to 255. And finally, we can specify a thresholding type. Now this thresholding type is essentially cv.thresh_binary. And what this does is it basically looks at the image, compares each pixel value to this thresholded value, and if it is above this value, it sets it to 255. Otherwise, it infers that if it falls below, it sets it to 0. So essentially it returns 2 things: thresh, which is the thresholded image or the binarized image, and threshold, which is essentially the same value that you passed, 150. The same thresholded value you pass in will be returned to this thresholded value. So let's actually display this image. So let's say cv.ironShow, we'll call this thresholded. We'll call this simple thresholded, and we can pass in the thresh. So let's save that and run python thresh.py. and this is the thresholded image that you get. Again, this is nothing too different from when we discussed thresholding in one of the previous videos, but this is essentially what you get. So let's play around with these threshold values. Let's set this to 100 and let's see what that does. And as a result, both parts of the image have become white. So, and of course, if you give it a higher value, less parts of the image will be white. So let's set this to 225. And very few pixels in this threshold image actually have a pixel intensity of greater than 225. So, what we can do after this is essentially create an inverse thresholded image. So what we could do is we could essentially copy this, and instead of saying thresh, we're going to say thresh underscore inverse, and we're going to leave everything else the same. Let's set this to 150, and let's enter it here. And instead of passing in the type of thresholding, I'm going to say cv.thresh underscore binary underscore inverse. And let's call this threshold inverse, and we can pass in inverse. So let's save that and run. And this is essentially the inverse of this image. Instead of setting pixel intensities that are greater than 150 to 255, it sets whatever values that are less than 150 to 255. So that's essentially what you get, right? All the black parts of this image will change to white, and all the white parts of the image will change to black. Cool, so that's it for simple threshold. Let's move on now to adaptive threshold. Now, as you can imagine, we got different images when we provided different threshold values. Now, kind of one of the downsides to this is that we have to manually specify a specific threshold value. Now, some cases this might work, in more advanced cases this will not work. So one of the things we could do is we could essentially let the computer find the optimal threshold value by itself. And using that value that it finds, it binarizes over the image. So that's in essence the entire crux of adaptive thresholding. So let's set up a variable called adaptive underscore thresh and set this equal to cv.adaptive threshold, and inside I want to pass in a source image. So let's set this to grid. I want to pass in a maximum value, which is 255. Now notice there is no threshold value. The adaptive method basically tells the machine which method to use when computing the optimal threshold value. So for now we're just going to set this to the mean of some neighborhood of pixels. So let's set this to cv.adaptive underscore thresh underscore mean underscore c. Next we'll set up a threshold type. This is cv.thresh underscore binary. Again, nothing too different from this from the first example. And two other parameters that I want to specify is the block size, which is essentially the neighborhood size or the kernel size, which OpenCV needs to use to essentially compute mean to find the optimal threshold value. So for now, let's set this to 11. And finally, the last method we have to specify is the C value. Now this C value is essentially an integer that is subtracted from the mean, allowing us to essentially fine-tune our thresholding. So again, don't worry too much about this, you can set this to 0, but for now, let's set this to 3. And finally, once that's done, we can go ahead and try to display this image. So let's call this adaptive thresholding and passing adaptive thresh. So let's save that and run. And this is essentially your adaptive thresholding method. So essentially what we've done is we've defined a kernel size or a window that is drawn of this image. In our case, this is 11 by 11. And so what OpenCV does is it essentially computes a mean over those neighborhood pixels and finds the optimal threshold value for that specific part. And then it slides over to the right, and it slides and does the same thing, and it slides down and does the same thing, so that it essentially slides over every part of the image. So that's how adaptive thresholding works. If you wanted to fine-tune this, we could change this to a thresh underscore binary underscore inverse, just to see what's really going on under the hood. Cool, so all the white parts of the image will change to black, and all the black parts of the image will change to white. So let's play around with these values. Let's set this to probably 13. Let's see what that does. Okay, definitely some difference from the previous hyperparameter. So let's set this to 11, and let's set this to maybe 1. Okay, definitely more white. Let's set this to maybe 5. And really, you can play around with these values. Right? The more you subtract from the mean, the more accurate it is. Right? You can basically make out the edges now in this basket. So let's maybe increase that to 9. And you get less white parts in the image, but essentially now you can make out the features better. So that was essentially adaptive thresholding. Adaptive thresholding that essentially computed the optimal threshold value on the basis of the mean. Now we don't have to stick with the mean, we can go with something else. So instead of mean, let's set this to Gaussian. So let's say that and see what that does. And this is the threshold that image using the Gaussian method. So the only difference that Gaussian applied was essentially add a weight to each pixel value and compute the mean across those pixels. So that's why we were able to get a better image than when we used mean. But essentially the adaptive thresholding mean works in some cases, the Gaussian works in other cases. There's no real one-size-fits-all. So really play around with these values, see what you get. But that's essentially all we have to discuss for this video. We talked about two different types of thresholding, simple thresholding and adaptive thresholding. In simple thresholding, we have to manually specify a threshold value, and in adaptive thresholding, OpenCV does that for us using a specific block size or a kernel size, and either computing the threshold value on the basis of the mean or on the basis of the Gaussian distribution. So in the next video, the last video in the advanced section of this course, we're going to be discussing how to compute gradients and edges in an image. So if you have any questions, leave them in the comments below. I'll be sure to check them out. Otherwise, I'll see you guys in the next video. Thanks for watching. Hey everyone, and welcome back to another video. In this video, we're going to be talking about gradients and edge detection in OpenCV. Now you can think of gradients as these edge-like regions that are present in an image. Now, they're not the same thing. Gradients and edges are completely different things from a mathematical point of view. But you can pretty much get away with thinking of gradients as edges from a programming perspective only. So essentially, in the previous videos, we've discussed the Canny edge detector, which is essentially kind of an advanced edge detection algorithm that is essentially a multi-step process. But in this video, we're going to be talking about two other ways to compute edges in an image, and that is the Laplacian and the Sorbel method. So let's start off with the Laplacian. So the first thing I want to do is I want to convert this image to grayscale. Calling the CVT color method, we pass in the image, and we say cv.color_BVR to gray. We'll display this image, let's call this gray, and we can pass in gray. So let's start off with the Laplacian. So we're going to define a variable called lap, and set this equal to cv.Laplacian. And what this essentially will do is it will take in a source image, which is gray now, and it will take in something called a ddepth, or data depth. Now for now, we set this to cv.64f, and just go along with whatever I do next. I'm going to say lap is equal to np.uid, and inside I'm going to pass in np.absolute, and we can pass in lap. And since I'm using NumPy, I can actually go ahead and put NumPy. And when I go to display this image, calling the cv.actual method, let's call this Laplacian, and we can pass in lap. Call our lap, save, and run. And call this Python, gradients, and now it's inside cv. Okay, it's cv.cf CV_64. See that? And this is essentially the Laplacian edges in the image. Kind of looks like an image that is drawn over a chalkboard and then smudged just a bit. But anyway, this is the Laplacian method. Let's try this with another image. Let's try this with park. Cool. Save it. And this essentially looks like a pencil shading of this image. So all the edges that exist in the image, or at least most of the edges in the image, are essentially drawn over with a pencil and then lightly smudged. So that's essentially the Laplacian edge. So again, don't worry too much about why we converted this to an UI and then we computed the absolute value. But essentially the Laplacian method computes the gradients of this image, the grayscale image. Generally this involves a lot of mathematics, but essentially when you transition from black to white and white to black, that's considered a positive and a negative slope. Now, images itself cannot have negative pixel values. So what we do is we essentially compute the absolute value of that image. So all the pixel values of the image are converted to their absolute values, and then we convert that to a UINT, so an image-specific data type. So that's basically the crux of what's going on right here. So let's move on to the next one. That is Sobel gradient magnitude representation. So essentially the way this does is that Sobel computes the gradients in two directions, the x and the y. So we're going to say Sobel x, which is the gradients that are computed along the x-axis, and set this equal to cv.sobel, and we can pass in the image. Let's set this to the grayscale image. We pass in a data depth, which is cv.cv_64f, and we can give it an x direction, so let's set this to 1, and the y direction we can set that to 0. And let's copy this and call Sobel y, and instead of 1, 0, we can say 0, 1. And we can visualize this. Let's print. Let's call this Sobel x, and we can pass in Sobel x, and we can say cv.show Sobel y, and set this to Sobel y. Call that. And these are essentially the gradients that are computed. This is over the y-axis, so you can see a lot of horizontal specific gradients, and the Sobel x was computed across the y-axis, so you can see y-axis specific gradients. Now we can essentially get the combined Sobel image by essentially combining these two, Sobel x and Sobel y. And the way we do that is we're going to say combined underscore Sobel, and set this equal to cv.bitwise underscore r, and we can pass in Sobel x and Sobel y. And we can display this image, so let's call cv.show. We can say combined Sobel, and we can pass in the combined Sobel. Let's run that. And this is essentially the combined Sobel that you get. It essentially took these two, applied cv.bitwise or, and essentially got this image. So if you want to compare this with the Laplacian, two completely different algorithms, so the result you get will be completely different. Okay, so let's compare both of these, Laplacian and the Sobel, with the Canny edge detector. So let's go down here. Let's say Canny is equal to cv.image, and we can pass in the image. So let's pass in the grayscale image. Let's give it two threshold values of 150 and 175, and we're done. Let's display this image. Call it Canny. We can pass in Canny. So let's say that. Let's see what that gives. Let's compare that. So that's essentially it. This is the Laplacian gradient representation, which essentially returns kind of this pencil shading version of the image, of the edges in the image. Combined Sobel computes the gradients in the x and the y direction, and we can combine these two with bitwise OR. And Kenny is basically a more advanced algorithm that actually uses Sobel in one of its stages. Like I mentioned, Kenny is a multi-stage process, and one of its stages is using the Sobel method to compute the gradients of the image. So essentially, you see that the Kenny detector is a more cleaner version of the edges that can be found in the image. So that's why in most cases you're going to see the Kenny used. But in more advanced cases, you're probably going to see a Sobel used a lot. Not necessarily Laplacian, but Sobel definitely. So that's pretty much it for this video. And in fact, this video concludes the advanced section of the course. Moving on to the next section, we will be discussing face detection and face recognition in OpenCV. We're actually going to touch on using hard cascades to perform some face detection. And in face recognition, we actually have two parts. Face recognition with OpenCV's built-in face recognition, and the second part will be actually building our own deep learning model to essentially recognize some faces in an image. Again, like always, if you have any questions, leave them in the comments below. Otherwise, I'll see you guys in the next section. Hey everyone, and welcome back to another video. We are now at the last part of this Python and OpenCV course, where we are going to talk about face detection and face recognition in OpenCV. So what we're going to be doing in this video is actually discussing how to detect faces in OpenCV using something called a hard cascade. In the next video, we will talk about how to recognize faces using OpenCV's built-in face recognizer. And after that, we will be implementing our own deep learning model to recognize between the Simpson characters. We're going to create that from scratch and use OpenCV for all the pre-processing and displaying of images and stuff like that. So, let's get into this video. Now, face detection is different from face recognition. Face detection merely detects the presence of a face in an image, while face recognition involves identifying whose face it is. Now, we'll talk more about this later on in this course, but essentially face detection is performed using classifiers. A classifier is essentially an algorithm that decides whether a given image is positive or negative, whether a face is present or not. Now, a classifier needs to be trained on thousands and tens of thousands of images with and without faces, but fortunately for us, OpenCV already comes with a lot of pre-trained classifiers that we can use in any program. So essentially, the two main classifiers that exist today are hard cascades and more advanced classifiers called local binary patterns. We're not going to talk about local binary patterns at all in this course, but essentially they're more advanced hard cascade classifiers. They're not as prone to noise in the image as compared to the hard cascade. So, I'm currently at the OpenCV's GitHub page where they store their hard cascade classifiers, and as you can see, there are plenty of hard cascades that OpenCV makes available to the general public. You have a hard cascade for an eye, a frontal cat face, a frontal face default, full body, your left eye, a Russian license plate, a Russian plate number, I think that's the same thing, a hard cascade to detect smile, a hard cascade for detection of the upper body, and things like that. So feel free to use whatever you want, but in this video we're going to be performing face detection, and for this we're going to use the hard cascade underscore frontal face underscore default.xml. So when you go ahead and open that, you're going to get about 33,000 lines of XML code. So all of this. So what you have to do is essentially go to this raw button, and you'll get all this raw XML code. All you have to do is click Ctrl A or Command A if you're on the Mac, and click Ctrl C or Command C, and then go to your VS Code or your editor and create a new file, and we're going to call this har_face.xml. And inside this, I want to paste in those 33,000 lines of XML code. Go ahead and save that, and our classifier is ready. You can go ahead and close this out. So, we're going to be using this har cascade classifier to essentially detect faces that are present in an image. So, in this file called face_detect.py, I imported OpenCV, I basically read in an image of a lady, a person, that is this image over here. And we can go real quick and display this. So let's run Python face_detect.py. And we get an image in a new window. Cool. So let's actually implement our code. The first thing I want to do is convert this image to grayscale. Now, face detection does not involve skin tone or colors that are present in an image. These har cascades essentially look at an object in an image and using the edges tries to determine whether it's a face or not. So we really don't need color in our image, and we can go ahead and convert that to grayscale. cv.cvt color, passing the image, and cv.color the BGR to the gray. And we can display this, call this gray person. We can pass in IMG. Let's save that and run. And we have to pass in the gray. Okay, we have a gray person over here. So, let's move on to essentially reading in this har_face.xml file. So the way we do that is by essentially create a har cascade variable. So let's set this to har_cascade. I'm going to set this equal to cv.cascade classifier. And inside, what I essentially want to do is pass in the path to this XML file. And that is as simple as saying har_face.xml. So this cascade classifier class will essentially read in those 33,000 lines of XML code and store that in a variable called har_cascade. So now that we've read in our har cascade file, let's actually try to detect the face in this image. So what I'm going to do is essentially say faces_rect is equal to har_cascade.detect multiscale, and inside we're going to pass in the image that we want to detect the face on. So this is gray. We're going to pass in a scale factor. Now let's set this to 1.1. Give it a variable called minimum neighbors, which essentially is a parameter that specifies the number of neighbors a rectangle should have to be called a face. So let's set this to 3 for now. So that's it. That's all we have to do. And essentially what this does is this detect multiscale, an instance of the cascade classifier class, will essentially take in this image, use these variables called scale factor and minimum neighbors to essentially detect a face, and return essentially the rectangular coordinates of that face as a list to faces_rect. That's exactly why we are giving it faces_rect, rectangle. So, you can essentially print the number of faces that were found in this image by essentially printing the length of this faces_rect variable. So let's do that. Let's print the number of faces found is equal to possible length of faces_rect. So let's save that and run. And as you can see, the number of faces that were found is 1. And that's true because there's only one person in this image. Cool. Now, utilizing the fact that this faces_rect is essentially the rectangular coordinates for the faces that are present in the image, what we can do is we can essentially loop over this list and essentially grab the coordinates of those images and draw a rectangle over the detected faces. So let's do that. So the way we do that is by saying for x, y, w, h in faces_rect, what we're going to do is we're going to draw a rectangle. See the rectangle over the original image, so IMG. We have the point 1. This point 1 is essentially x comma y, and point 2 is essentially x plus w comma y plus h. Let's give it a color. Let's set this to green, so 0, comma 255, comma 0. Give it a thickness of 2. And that's it, and we can print this, and we can display this image. So let's set this to detected faces. And we can toss it and if you look at this image, you can essentially see the rectangle that was drawn over this image. So this in essence is the face that OpenCV's Hard Cascades found in this image. So let's try this with another image. So what I have here are a couple of other people, an image of 5 people. So we're going to use that image and try to see how many faces OpenCV's Hard Cascades could detect in this image. So let's set this to group 2, and we can change that to group of 5 people. Save that. Oh, great people. Save and run. And I want to point real quick that the number of faces that were found were actually 7. And we know that there are 5 people in this image, so let's actually see what OpenCV thought was affected. We can go real quick. So actually it detected all the faces in this image, all the 5 people, but it also detected 2 other, against the stomach and part of her neck. Now this is to be expected because Hard Cascades are really sensitive to noise in an image. So if you have something that pretty much looks like a face, like her neck looks like a face, it has the same structure as a typical face would have. I don't know why her stomach would recognize his face, but again, this is to be expected. So one way we can try to minimize the sensitivity to noise is essentially modifying the scale factor and minimum neighbors. So let's increase the minimum neighbors to maybe 6 or 7. Save that and run. And as you can see, now 6 faces were found. So I guess by increasing the minimum neighbors parameter, we essentially stop OpenCV from detecting her stomach as face. So let's try this with another more complex image. A couple of people in group 1. So I change that to group 1, save, run. Now as you can see that the number of faces that were found were 6, and we know that this is not 6. So let's actually change this minimum neighbor just a bit. Let's change this first to 3 and see how many faces were found. Now we got 14. Maybe some people at the back weren't chosen because either the faces are not perfectly perpendicular to the camera, or they're wearing some accessories on their face. For example, eyeglasses, this dude's wearing a cap, and stuff like that. So let's actually change this to 1, and let's see where that gets us. 1, save, run. And now we got 19 faces that were found in this image. So essentially by looping through these values, by changing these values, by tweaking these values, you can essentially get a more robust result. But of course, by minimizing these values, you're essentially making OpenCV's Hard Cascades more prone to noise. So that's a trade-off you need to consider. Now again, Hard Cascades are not the most effective in detecting faces. They're popular, but they're not the most advanced. They're probably not what you would use if you were to build more advanced computer vision projects. I think for that, D-Lid's face recognizer is more effective and less sensitive to noise than OpenCV's Hard Cascades. It's as per your use case. Hard Cascades are more popular, they're easy to use, and they require minimal setup. And if you wanted to extend this to videos, you could. All you have to do is essentially detect Hard Cascades on each individual frame of the video. Now, I'm skipping that because it's pretty self-explanatory. So that's pretty much it for this video. We discussed how to detect faces in OpenCV using OpenCV's R Cascade. In the next video, we will actually talk about how to recognize faces in OpenCV using OpenCV's built-in face recognizer. So, like always, if you have any questions, comments, concerns, whatever, leave them in the comments below. Otherwise, I'll see you in the next video. Hey everyone, and welcome back to another video. In this video, we will learn how to build a face recognition model in OpenCV using OpenCV's built-in face recognizer. Now, in the previous video, we dealt with detecting faces in OpenCV using R Cascades. This video will actually cover how to recognize faces in an image. So what I have here are 5 folders of 5 different people. Inside each folder, I have about 20 images of that particular person. So Jerry has 21 images, Elton has 17, Mindy Kaling has 22, Ben Affleck has 14, and so on. So what I'm essentially going to do is we're going to use OpenCV's built-in face recognizer, and we're going to train that recognizer on all of these images in these 5 folders. And this is sort of like building a mini-sized deep learning model, except that we're not going to build any model from scratch. We're going to use OpenCV's built-in face recognizer. All we're going to do is we're actually going to pass in these close to 90 images, and we're going to train that recognizer on these 90 images. So let's create a new file, and we're going to call this faces_train.py. We're going to import OS, we're going to import CV2 and we're going to import NumPy as a P. So the first thing I want to do is essentially create a list of all the people in the image. So this is essentially the names of the folders of these particular people. What you can do is you can manually type those in, or you could essentially create an empty list. Let's call this P. And we can loop over every folder in this folder. Let's set this to r-string. And we can say p.append I. And we can print P. Save that and run. Python faces_train.py, and we get the same list that we got over here. So that's one way of doing it. And what I'm going to do next is I'm essentially going to create a variable called dir and set this equal to this base folder. That is this folder which contains these 5 folders of these people. Cool. So with that done, what we can do is we can essentially create a function called def_train that will essentially loop over every folder in this base folder, and inside that folder is going to loop over every image and essentially grab the face in that image and essentially add that to our training set. So our training set will consist of 2 lists. The first one is called features, which are essentially the image arrays of faces. So let's set this to an empty list. And the second list will be our corresponding labels. So for every face in this features list, what is its corresponding label? Or whose face does it belong to? Like one image could belong to Ben Affleck, the second image could belong to Elton John, and so on. So let's create a function. So we're going to loop over every person in this people list. We're going to grab the path for this person. So for every folder in this base folder, going through each folder and grabbing the path to that folder. So that's essentially as simple as saying os.path.join, and we can join the dir with person. And what I'm going to do is I'm going to create a label variable and set this equal to people.index of person. And now that we're inside each folder, we are going to loop over every image in that folder. So we're going to say for image in os.list dir path. We are going to grab the image path. So we're going to say image underscore path is equal to os.path.join. Let's join. We're going to join the path variable to the image. Now that we have the path to an image, we're going to root in that image from this path. So we're going to create a variable called ing underscore array is equal to cv.read image underscore path. We're going to convert this image to grayscale, cvt, color, pass an ing underscore array, and we can pass in cv.color underscore bgr. Cool. And now with that done, we can essentially try to detect the faces in this image. So let's go back to face underscore detect and grab the hard cascade classifier variable. Let's paste that there. And we can create our faces underscore rect and set this equal to har underscore cascade dot detect multi-scale. This will take in a gray image, the scale factor of 1.1, and the minimum neighbors of 4. And we can loop over every face in this face rect. So for x, y, w, each in faces rect, we are going to grab the faces region of interest and set this equal to, and basically crop out the face in the say gray, y to y plus h, and x to x plus w. And now that we have a face region of interest, we can append that to the features list, and we can append the corresponding label to the labels list. So we're going to do features dot append. We're going to pass in faces underscore ROI, and we can do a labels dot append label. This label variable is essentially the index of this list. Now the idea behind converting a label to numerical values is essentially reducing the strain that your computer will have by creating some sort of mapping between a string and the numerical label. Now the mapping that we are going to do is essentially the index of that particular list. So let's say that I grab the first image, which is an image of Ben Affleck. The label for that would be 0, because Ben Affleck is at the 0th index of this people list. Similarly, Elton John, an image of Elton John would have a label of 1 because it is at the 2nd position or the 1st index in this people's list. So that's essentially the idea behind it. Now, with that done, we can essentially try to run this and see whether we got any errors or not. And we can bring the length of the features. So let's say length of the features list is equal to the length of features. We can do the same thing. Let's copy this. Length of the labels list. Set this to length of labels. So that shouldn't give us any error. So let's run that. And we get the length of the features 100 and length of the labels 100. So essentially what we have are 100 faces and 100 corresponding labels to those faces. So we don't need this anymore. What we can do is we can essentially use this features and labels list, now that it's appended, to train our recognizer on it. So the way we do that is we instantiate our face recognizer, call this as an instance of the cv.face.lbph face recognizer underscore create class, and this will essentially instantiate the face recognizer. Now we can actually train the recognizer on the features list and the labels. And the labels So the way we do that is by saying face underscore recognizer dot train, and we can pass in the features list, and we can pass in the labels. And before I actually do that, I do want to convert this features and labels list to NumPy arrays. So we're gonna say features is equal to np.array of features, and we can say labels is equal to np.array labels, and save that and run. Okay, let's set this to dtype object. Passing dtype is equal to object, and we can actually print when this is done. Print done. And we can actually go ahead and save this features and labels list. And we're going to say np.save, we're going to call this features.np1, we can pass the features, and we do np.save labels.np1, and we can pass the labels. So let's save that and run. Cool. So essentially now the face recognizer is trained, and we can now use this. But the problem here is that if we plan to use this face recognizer in another file, we have to separately and manually repeat this process, this whole process of adding those images to a list and getting the corresponding labels, and then converting that to NumPy arrays, and then training all over again. What we can do, and what OpenCV allows us to do, is essentially save this trained model so that we can use it in another file, in another directory, in another part of the world, just by using that particular YAML source file. So we're going to repeat this process again, but the only change that I'm going to do is I'm going to say face recognizer.save, and we're going to give the path to a YAML source file. So we're going to say face_train.yaml. So let's repeat this process again. Training's done, and now you'll notice that you have face_train YAML file in this directory, as well as faces, as well as features.npy and labels.npy. So let's actually use this trained model to recognize faces in an image. So let's close this out and create a new file, and we're going to call this face_recognition.py. Very simply, we're going to import NumPy as np and cd2 and cd. We don't need OS anymore because we're not looping over directories. We can essentially create r_cascade file. We can load our features and label array using, I think, features is equal to np.load features.np1, and we can say labels is equal to np.load, let's call this labels.np1. And we can essentially now read in this face_train.yaml file. So let's go over here, let's grab this line, and let's say face recognizer.read, and we're going to give it a path to this YAML source file, face_train.yaml. So that's pretty much all we need. Now we need to get the mapping, so let's grab this list as well. So that's pretty much all we have to do. So let's create a variable, image, and let's set this to cv.imread, give it a path. Let's grab one from this validation. And one from this validation. So let's try this and grab piece of that, and that's a JPG file. And we can convert that image to grayscale. We go to color, plus the image, color. Let's go to that's displayed so colors the person, unidentified person, so what we're going to do is we're going to first detect the face in the image. So the way we do that is by saying faces underscore rect is equal to r underscore cascade dot detect multi-scale. We pass in the scale factor, which is 1.1, give it a minimum neighbors of 4, and we can loop over every face in this faces underscore rect. So for x comma y comma w comma h in faces is underscore rect, we can grab the region of interest, so what we're interested in finding, y to y plus h and x to x plus h. And now we can predict using this face recognizer, so we get the label and a confidence value, and we say face recognizer dot predict, and we predict on this faces underscore ROI. Let's print, let's call this label is equal to label with confidence of face. And since we're using numerical values, we can probably say people of label. Okay. And we can, essentially what we can do is we can put some text on this image just to show us what's really going on. We can put this on image. We can create a string, the label of people of label, so the person is involved in that image. Give it an origin, or let's say 10, let's say 20 by 20. In the font face of CV dot font underscore Hershey underscore complex. Give it a font scale of 1.0. Give it a color of 0,255,0, and give it a thickness of 2. And we can draw a rectangle over the image, over the face. And this is, we draw the same image, x to y, and x plus delta y plus 2. We give it a color of 0,255,0, and we can give it a thickness of 2. So with that done, we can finally display this image, called the detected face, and we can pass the image. And finally, we can do a CV.weight 0. So let's save and see what we get. Python face underscore mission.py. Can I get a line pickles? Where is that? Probably don't do If you wanted to use these again, you could essentially use mp.load. Since the data types are objects, you can basically say, well, pickle is equal to true. That's essentially it. We're not going to use this, so let's comment that out. Save. Okay, we get Ben Affleck with a confidence of 60%. So that's pretty good. 60% is good given the fact that we only train this recognizer on 100 images. So let's try this with another image of Ben Affleck. This image. This again is Ben Affleck with a confidence of 94%. Very good. Let's go back. Let's go maybe to another person. Let's go to Madonna. Let's grab this. It's a pain really, but okay, let's grab this person. Not sure whether it will detect the face because of the hair, so let's paste that in. Now this is where you'll find that OpenCV's face recognizer, built-in face recognizer, is not the best. It can't detects that this person in the image is actually Jerry Seinfeld, and that's with a confidence of 110%. Maybe there's an error somewhere. I'm not sure why that went to 111, but pretty sure there's an error somewhere. But essentially, this is where the discrepancies lie. It's not the best, so it's not going to give you accurate results. So let's try this with another image. Let's go back to maybe okay, this is Madonna with a confidence of 96.8%. Okay, let's move on to Elton John. Wasn't had problems with Elton John, given the fact that it looked pretty similar to Ben Affleck for some reason. Change that to Elton_John and print that. Okay, Elton John with a confidence of 67%. Pretty good. Okay, so not bad. This is more accurate than what I predicted before filming this video. I did a couple of trial runs and I got varied results. For example, Elton John was continually detected as Jerry Seinfeld. Ben Affleck, Madonna was detected as Ben Affleck. Ben Affleck was detected as Mindy Kaling. Mindy Kaling was detected as Elton John, and a whole bunch of weird results. So I guess that we did something right. I must have done something wrong in the trial run, but hey, we get good results, and that's pretty good. Now I'm not sure why that gave a confidence of 111%. Maybe there's an error somewhere with the training set, but I guess for the most part you can ignore that. Given the fact that we get pretty good results. So, that's pretty much it for this video. We discussed face recognition in OpenCV. We essentially built a features list and a labels list, and we trained our recognizer on those two lists, and we saved our model as a YAML source file. In another file, we essentially read in that saved model, saved YAML source file, and we essentially made predictions on each. And so in the next video, which will actually be the last video in this course, we will discuss how to build a deep learning model to detect and classify between 10 Simpson characters. So if you have any questions, comments, concerns, whatever, leave them in the comments below. Otherwise, I'll see you in the next video. Hey everyone, and welcome to the last video in this Python and OpenCV course. Previously, we've seen how to detect and recognize faces purely in OpenCV, and the results we got were varied. Now, there are a couple of reasons for that. One is the fact that we only had 100 images to train the recognizer on. Now, this is a significantly small number, especially when you're training recognizers and building models. Ideally, you'd want to have at least a couple of thousand images per class. The second reason lies in the fact that we weren't using a deep learning model. Now, as you go deeper into especially computer vision, you will see that there are very few things that can actually beat a deep learning model. So that's what we're going to be doing in this video, building a deep computer vision model to classify between the Simpson characters. Now generally, OpenCV is used for pre-processing the data, that is, performing some sort of image normalization, mean subtraction, and things like that. But in this video, we're going to be building a very simple model, so we're not going to be using any of those techniques. In fact, we'll only be using the OpenCV library to read in an image and resize them to a particular size before feeding it into the net. Now, don't worry if you've never used or built a deep learning model before. In this video, we'll be using TensorFlow's implementation of Keras. Now, I want to keep this video real simple just so you have an idea of what really goes on in more advanced computer vision projects. And Keras actually comes with a lot of boilerplate code. So if you've never built a deep learning model before, don't worry, Keras will handle that for you. So kind of one of the prerequisites to building a deep learning model is actually having a GPU. Now a GPU is basically a graphical processing unit that will help speed up the training process of a network. But if you don't have one, again, don't worry, because we'll be using Kaggle, a platform which actually offers free GPUs for us to use. So real simple, before we get started, we'll need a couple of packages installed. So if you haven't already installed Sierra at the beginning of this post, go ahead and do a pip install Sierra. The next package you require is Kinero. And this is a package that I built specifically for deep learning models built with Keras. And this will actually prove surprisingly useful to you if you plan to go deeper into building deep computer vision models. Now, installing this package on your system will only make sense if you already have a GPU on your machine. If you don't, then you can basically skip this part. So we can do a pip install Kinero. And Kinero actually installs TensorFlow by default, so just keep that in mind. So with all the installations out of the way, let's actually move on to the data that we're going to be using. So the dataset that we're going to be using is the Simpsons character dataset that's available on Kaggle. So the actual data that we're interested in lies in the Simpsons underscore dataset folder. This basically consists of a number of folders with several images inside each subfolder. So Maggie Simpson has about 128 images. Homer Simpson has about 2,200 images. Abraham has about 913 images. So essentially what we're going to do is we are going to use these images and feed them into our model to essentially classify between these characters. So first thing we want to do is go to kaggle.com/notebooks, go ahead and create a new notebook. And under advanced settings, make sure that the GPU is selected since we're going to be using the GPU. After that, click create. And we should get a notebook. So we're going to rename this to Simpsons. And another thing I want to do is enable the internet since we're going to be installing a couple of packages over the internet. So to use the Simpsons character dataset in our notebook, you need to go ahead to add data, search for Simpsons. And the first one by Alex Satia should pop up. Go ahead and click add. And we can now use this dataset inside of our notebook. So the first thing I want to do is we're going to pip install Sierra and Kinero. Now the reason why I'm doing this yet again is because Kaggle does not come pre-installed with Sierra and Kinero. Now I did tell them to install it on the machine, and the reason for that is because you all can work with it and experiment with it. So once that's done, go ahead to a new cell and let's import all the packages that we're going to need. So we're going to import OS, we're going to import Sierra, we're going to import Kinero, we're going to import NumPy, we're going to import CV2 and CV, and we're going to import GC for garbage collection. Then next what I want to do is basically when building deep computer vision models, your model expects all your data, all your image data to be of the same size. So since we're working with image data, this size is the image size. So all the data, all the images in that dataset will actually have to be resized to a particular size before we can actually feed that into the network. Now with a lot of experiments, I found that an image size of 80 by 80 works well, especially for this Simpsons dataset. Okay, the next variable we need is channel. So how many channels do we want in our image? And since we do not require color in our image, we're going to set this to 1, basically grayscale. So run that. What we need next is we're going to say car_path is equal to the base path where all the data, where all the actual data lies. And that is in the Simpsons underscore dataset. This is the base folder for where all our images are stored in. So we're going to copy this file path and we're going to paste that in there. Cool. So essentially what we're going to be doing now is we're essentially going to grab the top 10 characters which have the most number of images for that class. And the way we're going to do that is we are going to go through every folder inside the Simpsons underscore dataset, get the number of images that are stored in that dataset, store all of that information inside a dictionary, sort that dictionary in descending order, and then grab the first 10 elements in that dictionary. I hope that makes sense. So what we're going to do is we're going to say empty dictionary. We're going to say for character in os.list dir car path. We are going to say car underscore dict of car is equal to length of os.list dir of os.path dot join car underscore path with car. So essentially all that we're doing is we're going through every folder, we're grabbing the name of the folder, and we're getting the number of images in that folder, and we're storing all that information inside a dictionary called car underscore dict. Once that's done, we can actually sort this dictionary in descending order. And the way we do that is we say car underscore dict is equal to cr.sort underscore dict of car underscore dict, and we set descending equals to true. And finally we can print the dictionary that we get. So this is the dictionary that we have. As you can see, Homer Simpson has the most number of images at close to 2300, and we go all the way down to Lionel, who has only 3 images in the dataset. So what we're going to do is, now that we have this dictionary, what we're going to do is we are going to grab the names of the first 10 elements in this dictionary and store that in a list, a characters list. We're going to say characters. We're going to say characters is equal to an empty list, and we're going to say for I in car underscore dict, we're going to say characters dot append, and we're going to append the name, so we say I of 0, and we say if count is greater than or equal to 10, we can break, and we specify count of 0, increment that count. Okay, once that's done, let's print what our characters looks like. So we essentially just grab the names of the characters. So with that done, we can actually go ahead and create the training data. And to create the training data is as simple as saying train is equal to cr.preprocess from we pass in the car underscore path, the characters, the number of channels, the image size, and we say is shuffle equals true. So essentially what this will do is it will go through every folder inside car underscore path, which is Simpsons underscore dataset, and we'll look at every element inside characters. So essentially it's going to look for a Homer Simpson inside the Simpsons underscore dataset. If it finds Homer Simpson, where is Homer Simpson? If it finds Homer Simpson, it's going to go through inside that folder and grab all the images inside that folder and essentially add them to our training set. Now, as you may recall in the previous video, a training set was essentially a list. Each element in that list was another list of the image array and the corresponding label. Now the label that we had was basically the index of that particular string in the characters list. So that's essentially the same type of mapping that we're going to use. So Homer Simpson is going to have a label of 0, Ned will have a label of 1, Lisa will have a label of 3, and so on. So once that's done, go ahead and run this. Now, basically the progress is displayed to the terminal. If you don't want anything outputted to the terminal, you can basically just set the velocity to 0. But I'm going to leave things just as it is. Since there are a lot of images inside this dataset, this may take a while depending on how powerful your machine is. So that's done. It took about a minute or so to pre-process our data. So let's essentially try to see how many images there are in this training set. We do that by saying the length of track. And we have 30,811 images inside this training set. So let's actually try to visualize the images that are present in this data set. So we're going to import matplotlib.pyplot as PLT. We're going to do a PLT.figure, and we're going to give it a big size of 30 by 30. Let's do a PLT.imShow. We can pass in the first element in this training set, so 0 and then 0. And we can give it a color map of gray, and we can display this image. Now the reason why I'm not using OpenCV to display this image is because for some reason OpenCV does not display properly in Jupyter Notebook. So that's why we're using Matplotlib. So this is basically the image that we get. It's not very legible, but to a machine, this is a valid image. Okay, the next thing we want to do is we want to separate the training set into the features and the labels. Right now the training set basically is a list of 13,811 lists inside it. Inside each of that sub-list are two elements, the actual array and the labels itself. So we're going to separate the feature set for the arrays and the labels into separate lists. And the way we do that is by saying feature set and labels is equal to Sierra.set_train. We are going to separate the training set and give it an image size of image size. And that's an equals to. So basically what this is going to do is going to separate the training set into the feature set and labels, and also reshape this feature set into a 4-dimensional tensor so that it can be fed into the model with no restrictions whatsoever. So go ahead and run that, and once that's done, let's actually try to normalize the feature set. So essentially we are going to normalize the data to be in range of 0, 1. And the reason for this is because if you normalize the data, the network will be able to learn the features much faster than not normalizing the data. So we're going to say feature set is equal to Sierra.normalize, and we're going to pass in feature set. Now we don't have to normalize the labels, but we do need to one-hot encode them. That is, convert them from numerical integers to binary class vectors. And the way we do that is by saying from TensorFlow.keras.utils import to _categorical, and we can say labels is equal to categorical, and we can pass in more labels and the number of categories, which is basically the length of this characters list. Cool. So once that's done, we can actually move ahead and try to create our training and validation data. Now don't worry too much if you don't know what these are, but basically the model is going to train on the training data and test itself on the validation data. And we're going to say x_train, x_val, and y_train and y_val is equal to Sierra.train val split, and we're going to split the feature set and the labels using a particular validation ratio, which we're going to set as 0.2. So that's basically what we're doing. We're splitting the feature set and the labels into training sets and validation sets with using a particular validation ratio. So 20% of this data will go to the validation set and 80% will go to the training set. Okay. Now, just to save on some memory, we can actually remove and delete some of the variables that we're not going to be using. So we do that by saying del print, del feature sets, del labels, and we can collect this by saying gc.collect. Cool. Now, moving on, we need to create an image data generator. Now, this is basically an image generator that will essentially synthesize new images from already existing images to help introduce some randomness to our network and make it perform better. So we're going to say datagen is equal to canary.generators.image-data-generator, and this basically instantiates a very simple image generator from the Keras using the Keras library. And once it's done, let's create a training generator by setting this equal to datagen.float, and we can pass in xtrain and ytrain and give it a batch size equal to batch size. So let's actually create some variables here. Let's set my batch size to 32. And maybe let's train the network for 10 epochs. So once that's done, let's run that. So with that done, we can actually proceed to building our model. So let's call this creating the model. Now before making this video, I actually tried and tested out a couple of models and found that one actually provided me the highest level of accuracy. So that's the same model architecture that we're going to be using. So we're going to say model is equal to canary.models.create Simpsons model. We are going to pass in the image size, which is equal to the image size. We're going to say set the number of channels equal to the number of channels. We're going to set the output dimensions to 10, which is basically the length of our characters. Then we can specify our loss, which is equal to binary cross entropy. Then we can set a decay of e to the -6th power. We can set our learning rate equal to 0.001. We can set our momentum of 0.9, and we can set Nesterov to true. So this will essentially create the model using the same architecture I built, and we'll actually compile the model so that we can use it. So go ahead and run this, and we can go ahead and try to print the summary of this model. And so essentially what we have is a functional model, since we're using Keras' functional API. And this essentially has a bunch of layers and about 17 million parameters to train on. So another thing that I want to do is create something called a callbacks list. Now this callbacks list will contain something called a learning rate scheduler that will essentially schedule the learning rate at specific intervals so that our network can essentially train better. So we're going to say callbacks list is equal to learning rate scheduler, and we're going to pass in canary.lr_schedule. And since we're using learning rate schedule, let's go and import from TensorFlow Keras, then callbacks, import learning rate scheduler, and that should about do it. So let's actually go ahead and train the model. So we're going to say training is equal to model.fit. We're going to pass in the train gen. We're going to say steps the epoch is equal to the length of x_3 divided by batch size. We're going to say epochs is equal to epochs. We're going to give the validation data. Validation data equal to a tuple of x_val and y_val. We're going to say validation steps is equal to the length of y_val divided by the batch size. And finally we can say callbacks is equal to callbacks_list. Steps per epoch, that's steps per epoch. And that should begin training. And once that's done, we end up with a baseline accuracy of close to 70%. So here comes the exciting part. We're now going to use OpenCV to test how good our model is. So what we're going to do is we're going to use OpenCV to read in an image at a particular file path, and we're going to pass that to our network and see what the model spits out. So let's go ahead and go to this Simpson test set. So let's go ahead and try to search for all the way down here. Let's look at a characters list just to see what characters we trained on. Okay, let's look for Bart Simpson. That's probably the best characters. Okay, we got an image of Bart Simpson, so click this to see that. Got a test path. So it's equal to our string. And what we're going to do is we're going to say mj is equal to cv.imread test_path. And just to display this image, we can use plt.imshow. We can pass the image, and give it a color map of gray. We can do a plt.show. Okay, okay, so this is an image of Bart Simpson. So what we're going to do is we are going to create a function called prepare, which will basically prepare our image to be of the same size and shapes and dimensions as the images we used to prepare the model in. So this will take an image, and what this will do is we'll convert this image to grayscale. So we're going to say mj is equal to cv.cvt_color, and we're going to pass in the mj. We're going to say cv.color_bgr to gray. We can resize it to our image size. We're going to say mj is equal to cv.resize. We're going to resize the image to the image_size. I'm going to reshape this image, so mj is equal to str.reshape of image. We want to reshape the image to be of image size with channels equal to 1. And we can return the image. So let's run that. And let's go down here and say predictions is equal to model.predict and prepare image. And we can visualize these predictions. So let's print predictions. And essentially this is what we get. So to print the actual class, what we can do is we can print the characters of np.arg next, and we can say predictions of 0. And let's try to visualize this image, so we can do a plt.imshow. Let's pass in the image, and plt.show. Let's grab this. Down there. Okay, so this is our image, And right now, our model thinks that Bart Simpson is in fact Lisa Simpson. Lisa Simpson. Okay, let's try another image. Let's try probably this image. Bart Simpson 28. Let's go up and then to 8. Run that. This is Bart Simpson. Let's run this. And again we get Lisa Simpson. So let's try with a different image. Yeah, we do Charles Montgomery. So copy this. All the way down there. We got Charles, Predict, and we got Van Houten. Okay, definitely not the best model that we could have asked for, but hey, this is our model. Right now this company has a baseline accuracy of 70%, although I would have liked it to go to at least 85%. In my tests, it had gone close to 90-92%. I'm not sure exactly why this went to 70%, but again, this is to be expected since building deep computer vision models is a bit of an art, and it takes time to figure out what's the best model for your project. So that's it for this Python and OpenCV course. This course was basically kind of a general introduction to OpenCV and what it can do. Of course, we've only just scraped the surface, and really there's a whole new world of computer vision out there. Now, while we obviously can't cover every single thing that OpenCV can do, I've tried my best to teach you what's relevant today in computer vision. And really, one of its more interesting parts, building deep learning models, which is in fact where the future is. Self-driving vehicles, medical diagnosis, and tons of other things that computer vision is changing the world in. So all the code and material that was discussed throughout this course is available on my GitHub page, and the link to this page will be in the description below. And just before we close, I do want to mention that although I did recommend you install Sierra in the beginning, we barely use it throughout the course. Now, it's probably not going to make sense to you right now, but if you plan to go deeper into computer vision, into building computer vision models, Sierra will actually prove to be a powerful package for you. It has a lot of helper functions to do just about anything. Now, I'm constantly updating this repository, and if you want to contribute to these efforts, definitely do that. Send a pull request with your changes, and if it's helpful, it will be merged into the official codebase, and you'll be added as a contributor. If you're into building deep learning models with Keras, then Canary will be useful to you. But again, for the most part, it's usually Sierra that you'll be using. So anyway, with that said, I think I'll close up this course. If this course helped you in any way and got you more interested in computer vision, then definitely like this video, subscribe to my channel, as I'll be putting up useful videos on Python, computer vision, and deep learning. So I guess that's it. I hope you enjoyed this course, and I'll see you in another video.
Valeu, galera, boa noite. Já vamos começando aí a falar se tá tudo certo no áudio, se tá tudo certo no vídeo, se tá tudo belezinha. A live vai ficar, falar um pouquinho sobre isso já. Boa noite, o som não tá funcionando, vamos lá, olha só, galera, vamos começar, a gente tem muita coisa bacana pra gente cobrir nessa live agora, tá? Vamos começar, se você estava aqui na live passada, foram 3 horas de live, a gente começou às 6 horas, e é por isso que a gente começa às 6 horas, tá? Por isso que a gente começa então, a gente vai começar às 6 horas, sem hora para acabar, só termina quando acaba e vamos lá, beleza? Então, vamos lá, galera. Primeiro, novidades e notícias e coisas e noticiários, etc. A live vai sim ficar gravada, beleza? Então, se você não abrir o YouTube, não conseguir assistir toda, ou não tem disponibilidade no horário, enfim,
importa, vai ficar gravado e vai ficar aqui no canal do YouTube disponível por uma semana, legal? Depois ela sai e ela vai na nossa plataforma de alunos. Amanhã mesmo ela vai estar lá, a plataforma de alunos, beleza? E junto dessa já vai estar com todo o material. Então, por exemplo, esse layout aqui do aplicativo que eu vou estar aqui para vocês, já vai estar lá também funcional, tudo certinho, o arquivo, etc. Beleza? Pode quiser, vai estar lá disponível também, beleza? Então, sobre o projeto, vamos começar a conversar um pouquinho sobre o projeto. Antes, na verdade, como esse processo de criar etc., às vezes demora um pouquinho, eu vou fazer o seguinte, deixa eu abrir logo aqui, terminal. Eu já vou começar a criar o nosso projeto. E aí, depois eu volto para aqui e explicar o projeto, como é que vai funcionar. Eu vou criar aqui, eu vou entrar aqui. Eu criei uma pastinha chamada Dev Partner, vai ser o nome desse projeto, Dev Partner. E aí já eu explico um pouquinho sobre isso. E eu vou criar o projeto aqui dentro. Mas por que eu vou criar aqui dentro? Porque a gente vai ter o aplicativo, a gente vai ter o back-end e a gente vai ter um outro sistema que seria um front-end. Já explico também como é que vai funcionar esses detalhes, beleza? Então, vamos lá. Interface, React, Native, Init, e aí vamos começar a criar o nosso projeto. Como esse vai ser o enquanto ele vai criando o projeto, eu vou vir para cá para a gente explicar como é que vai funcionar o projeto. Legal? Então, olha só, galera, como é que vai funcionar. Basicamente, esse projeto aqui é um aplicativo que você, usuário, né, entra lá, você vai ver a lista de barbeiros que tem cadastrado na determinada localização. Inclusive, ó, você pode botar aqui a sua localização, você pode apertar esse botãozinho aqui e vai pegar a sua localização, então a gente vai trabalhar com pegar a localização do GPS, etc. Tá? E os barbeiros que tem perto da sua localização. Esse projeto a gente escolheu fazer para barbeiros, contudo, é um projeto que se aplica a qualquer profissional que vai prestar serviço. Tá? Então, você quer fazer, sei lá, não quer fazer para barbeiro, você quer fazer para treinador de cachorros, serve do mesmo jeito, só você vai trocar, na verdade, um nome aqui em cima, barbeiro para treinador de cachorros. Tá? Ou quer marcar consulta de dentista, quer marcar consulta com médico, quer marcar não sei o que, enfim, você quer marcar alguma coisa com algum profissional liberal, prestador de serviço, você tem como usar o mesmo projeto, você só muda o nome. Tá? Então, esse projeto em si, ele é mais do que uma startup. Então, se você criar esse projeto de verdade, se você fazer não só a parte técnica, mas você fazer também a parte comercial dessa ideia de negócio, você consegue abrir uma empresa, uma startup fácil com esse projeto. Tá? E, inclusive, é um projeto que vai contribuir na situação atual da gente. Você consegue marcar consultas, enfim, marcar prestação de serviços diversos, né? Por exemplo, na situação atual, o que você pensa que aconteceu com os barbeiros? Então, basicamente, a renda dele foi para zero. Se ele tivesse acesso ao ele podia marcar, agendar, ou a pessoa ia no horário marcado, ou então, se for um cara que está começando, ele pode ir na pessoa. Pareceu um negócio de vermelho Agora voltou. Bom, voltou. Deu só uma caídazinha básica, galera. Olha só. Então, continuando aqui. basicamente, o que vai acontecer? Você pode cadastrar, você pode se cadastrar no sistema e você, aí a parte comercial, a gente pode conversar um pouco mais sobre isso. Inclusive, a gente tem um curso para freelancer que dentro dele a gente aborda também essa questão da startup, iniciação do negócio. E eu estava falando, inclusive, com o Alessandro, para a gente fazer, justamente com base nesse projeto, uma análise lá para os alunos, uma análise da parte comercial desse projeto. Tá legal? Por quê? Você pode, por exemplo, cobrar para o usuário, você pode cobrar para o barbeiro ter o nome dele, né? Claro, usar esse aplicativo também. Então são duas fontes de realização. Então, voltando para o aplicativo em si, que a gente vai fazer hoje, agora. Olha só. Esse software aqui, o Adobe XD, tá? Mas você pode fazer no vídeo também, você pode fazer como você quiser, tá? O nome desse software específico aqui é Adobe XD, beleza? Ele tem uma versão gratuita, etc. Olha só. Primeira telinha é um pré-load, eu nem botei aqui, mas tem um loadzinho que vai ficar aqui. A primeira tela que a gente vai fazer, essa tela, ela vai basicamente decidir, assim que você abre o aplicativo, ela vai decidir se o cara está logado ou se o cara não está logado. Essa tela que é o login. E aí tem a tela de login e a tela de cadastro, tudo bem? Lembrando, isso aqui não é o cadastro do cabeleireiro. É o do barbeiro, tá? É o cadastro do usuário que vai usar o aplicativo. Esse aplicativo que a gente está fazendo aqui, a finalidade dele é para o usuário final, tá? Então, ele vai fazer o login aqui, etc. E ele vem para essa tela aqui, a primeira tela, que a gente chama de home. Em que aqui, basicamente, o cara pode dizer onde ele está. Ele pode apertar aqui no botãozinho para pegar o aplicativo. E aí, com base nisso, vai aparecer aqui, vão aparecer, né, os barbeiros na próxima daquela localização. Legal? E aí isso já vem para cá, você pode clicar para ver no perfil, na hora que é só um nome fake, mas você pode clicar no cara inteiro, né? E você vai automaticamente para essa telinha, que é a tela do próprio barbeiro. Eu mandei, inclusive, no Stories, uma foto da foto dessa telinha aqui. Essa parte azul aqui, na verdade ela não vai ficar azul no aplicativo real. Ela vai ser uma galeria de fotos, tá? Então aqui vão aparecer fotos de antes e depois, fotos do cara que está aí o barbeiro que vai escolher ele põe a foto aqui e aí ele vai fazer o swipe. Então o cara vai poder passar do lado e as fotos podem ficar passando também, tá? Se ele gostou desse barbeiro, ele clica aqui no coraçãozinho, ele vai salvar em uma lista específica de favoritos. E aí aqui no menu, ó, aqui embaixo, tem um coraçãozinho. Ele clica, ele vai abrir uma tela que tem apenas os barbeiros, né? Que ele gostou, que ele já aprovou. Ele faz a própria listinha dele do usuário, dos barbeiros que ele vai querer. Legal? E aqui aparece a lista dos serviços que o cara presta. Cada barbeiro pode prestar o serviço que ele quiser, tá? Clicou em agendar, ele vai abrir, ó, esse modal aqui. O serviço e um calendário de lição. Parte legal, né? Aqui ele vai ver o calendário, ele vai poder ir para os outros meses, para os outros anos, etc. Tá? Ele pode rolar isso aqui também para ver os dias do mês. Ele clica no mês, aparecerão os horários disponíveis de acordo com o próprio cabeleireiro, né? Ele mesmo que vai dizer quais horários disponíveis. E o cara seleciona e finaliza o agendamento. Legal? E aí tem outras telas aqui, que no caso são aqui a tela de busca. Então, o cara apertar nessa lupazinha aqui em cima ou na lupazinha lá embaixo no tab bar. E essa tela de busca, o cara pode botar um serviço específico, alguma coisa. Beleza? Depois tem telinha favoritos. Essas telas aqui são telinhas favoritas. O meu que a área fica extensa demais se a gente for criar todas essas telinhas desse tipo, a telinha de busca, a telinha de favoritos, a telinha dos seus próprios atributos aqui, ó, tá? A telinha do perfil nem dessa aqui. Aqui a telinha dos seus próprios atributos, por exemplo, já passou, fica mais mortinho, né? E aqui em cima ele fica os que você tem futuros ou atuais. Você não fez ainda o serviço. Legal? Então, detalhes técnicos, a gente vai fazer um tab bar 100% personalizado. Então, ó, perceba que você não tem como fazer um tab bar usando os recursos padrões da plataforma. Você não tem como fazer um tab bar dessa forma aqui. Então, a gente vai fazer o nosso, entre aspas, próprio tab bar personalizado que a gente vai inserir aqui. Tudo bem? Aqui o projeto, tá? Já a gente vai instalar todas as bibliotecas que você precisar, tudo bem? Eu vi o pessoal perguntando sobre o material. Não se preocupa, galera. O material vai ficar disponibilizado para quem é aluno na plataforma. Vai dar esse arquivo aqui com todos os layouts, se você tiver o Adobe. Eu vou disponibilizar também o imagem para quem não tem o Adobe 3D. Normal, todos os vídeos aqui são esses então, tudo vai estar disponibilizado, pode fonte, tudo, tá? E aí, um detalhe importante, back-end, a gente vai fazer o back-end, se eu fosse fazer numa live, criando back-end, o aplicativo, o front-end, no caso do front-end, vai ser o sistema, o lado do cabeleireiro, do barbeiro, tá? Então ele vai ver as pessoas que agendaram lá, ele vai ver a agenda dele, etc. Ele vai fazer o gerenciamento dele, tá? Esse vai ser o front-end. Então se a gente ficar fazendo em uma live só o back-end, o aplicativo e o front-end, vai passar aqui 4 horas de live. Não vai dar muito certo, né? Então o que é que a gente vai fazer? O back-end, ele já existe, ele já está online, a gente vai usar ele, tá? Ele foi feito em PHP com o Laravel. E a gente vai ter aulas passo a passo criando esse back-end também, beleza? Eu não vou criar ele em live, ele já está criado e eu vou fazer ele em aulas específicas, tá bem? Então, você vai poder usar o back-end tudo normal, legal? E as telas também, eventualmente, tipo essas telas mais bestas, como eu falei, e eventualmente não tem pra gente fazer em live, inclusive, eu pensei em fazer, que é pegar essa live, depois a gente separar ela em pedaços menores, né, tipo em aulas, e a gente disponibilizar na plataforma, ela toda dividida para você consumir de forma mais fácil. E aí a gente aproveita e faz o restante, caso não dê para fazer todas as telas, tá bem? Então, vamos lá. Vamos começar do começo, tudo bem? Então vamos lá. Vamos começar a instalar as bibliotecas que a gente precisa. Já abri logo o projeto, tá? Então eu estou usando o CS. Vou pegar aqui, acho que é a pastinha do projeto. Eu estou com um emulador do Android funcionando também, tá? Do lado. A gente vai usar esse cara também. Tem que aproximar a câmera aqui para que a gente consiga ver. Então é o seguinte, pessoal, vou diminuir para a gente colocar mais o aplicativo em si. Olha como estou em cima aqui do aplicativo. Pronto, fiquei pequenininho lá embaixo, mas não tem problema, porque o foco é o aplicativo, tá? Marcelo, você poderia usar o aplicativo para comercializar ou usar no portfólio? Normalmente, como você quiser, Marcelo, tá? Se você quiser pegar o projeto e criar ele, na sua cidade aqui, funcionar 100%, não tem problema nenhum, beleza? Então, esse emulador aqui é um emulador do próprio Android, do Android Studio. Nós colocamos ele também. Tudo bem, vamos ver aí como é que vai ficar. De acordo com o que então vamos lá. Projeto criado. Vamos agora criar as bibliotecas, as libs e as bibliotecas que a gente vai precisar usar durante esse projeto. Tá? Eu vou listando aqui e vou instalando o tempo com você. Limpar aqui para a gente começar. Vamos usar para a gente utilizar as coisas do nosso aplicativo. A gente vai usar uma biblioteca chamada Styled Components. Então, npm install, você pode usar npm install Styled Components para a gente utilizar o gerenciamento, para a gente fazer o gerenciamento de páginas, ou seja, para a gente ir de uma página para outra no nosso aplicativo, a gente vai usar, como já instalou aqui, a gente vai usar o duas partes dele, a parte stack, que é onde a gente pode passar de lugar, beleza? Para quem está chegando aqui na live agora, galera, vai ficar gravado sim, tá? E é o seguinte, eu vou fazer o seguinte com vocês, vou ser bonzinho dessa vez agora. Olha só, presta atenção, vou ser bonzinho com todo mundo aí. Quando terminar a live, amanhã na verdade, tá? Amanhã eu faço. Eu vou pegar o layout, todo o que a gente quiser aqui, o que a gente brincar aqui. Eu vou zipar tudo, eu vou limpar o link e eu vou botar na descrição desse vídeo aqui, tá? Então vai estar disponível tanto para quem é aluno quanto para quem não é aluno, tá? Durante a semana da live vai estar disponível também aqui o material, tudo bem? Vou ser bonzinho nessa live com vocês, tá legal? Porque eu sei que tem layout também, o pessoal que quer acompanhar, sem o layout fica mais complicado de fazer. Então, eu vou disponibilizar aqui o layout dos materiais, tá? Beleza, vamos lá. Instalamos aqui React Native Navigation. Vamos chamar aqui agora o próprio React Navigation, ele pede para a gente instalar. Eu posso copiar e colar aqui, mas eu vou mostrar para você achar quando você quiser achar por conta própria, tá? Então, olha só. E logo aqui, da própria biblioteca, tá? Você vem aqui, ele deu o comando, que é o comando que a gente acabou de botar, tá? Logo depois, aqui embaixo, ele tem o comando de outras dependências que são interessantíssimas que você tenha, tá? Então, copia esse cara aqui, e eu vou instalar toda essa galera. Eu só instalar aí, enquanto eu vou explicando outros detalhes que já instalou. Então, dá prosseguimento aqui ao processo. Olha só, uma vez que eu instalei pelo menos o React basicão, eu vou vir aqui no index.js, que é o primeiro arquivo, na verdade, que abre quando a gente cria o nosso projeto. E eu vou adicionar logo aqui no comecinho, antes de qualquer coisa, eu vou adicionar, vou importar, na verdade, um carinha aqui, então importa o que esse cara faz? Bastante como o próprio nome dele fala, está decantando a tela para a direita, você consegue voltar na tela. Então, esses detalhezinhos básicos, só o fato de você importar o cara aqui, você já deixa tudo funcionando, tá? Instalou aqui, já fiz a configuraçãozinha básica dele aqui. E vamos continuar, vamos instalar o próximo, o stack, npm install React Navigation, depois ele instala o tabs, tá? O bottom tabs, esse processo inicial de instalar as bibliotecas é meio chatinho, eu não sou muito fã desse processo inicial, mas como a gente a proposta de fazer do zero, vamos instalando tudo que a gente vai precisar, tá? A gente precisa salvar, lembra que eu falei que a gente gente vai usar o Web Service e tem esse sistema de login. Então, a gente vai salvar o token, fazer o login utilizando JWT, legal? E a gente vai salvar o token de acesso no próprio aplicativo para, se você fechar o aplicativo, depois você abre de novo, você consegue se manter logado, tudo bem? Então vamos fazer isso no aplicativo. Então, antes ele era interno do React Native, agora ele é externo, você tem que instalar e você utilizar. Então, npm install Além dele, nós vamos utilizar também o geolocation, que também era interno e agora não é mais interno. Então a gente vai precisar pegar a localização do usuário. Então a gente vai instalar também o geolocation. Esse cara também. É com ele que a gente vai pegar a localização do usuário, certo? E aí, para a gente pegar a localização do usuário, nas versões mais novas do Android, especificamente, ele precisa pedir essa. Então, por causa disso, vamos instalar mais uma biblioteca chamada React Native Permissions. Install React quando a gente instalar ela, vamos fazer só uma configuração extra depois disso aqui. Eu poderia ter feito, o Josué está falando, poderia ter feito com o Export. Sim, poderia ter feito com o Export, sim, mas eu pessoalmente prefiro você fazer o projeto nativo. Tá? Mas nada contra o Export. Então, olha só, agora que a gente instalou o React Native Permissions, vamos fazer o seguinte, vamos fazer uma pequena configuraçãozinha para o projeto ficar bonitinho, tá? Eu vim aqui, se você estiver fazendo para Android, tá? Você vem no Android, app, src, main, abre aqui, e aí ó, você vai ver esse carinha aqui, que basicamente significa esse aplicativo usar. Você vai copiar esse cara e você vai duplicar ele, basicamente. Você vai para baixo aqui e você vai substituir o nome da internet por access 2C e 2S, tá? Underline location. Isso aqui basicamente eu estou deixando claro para o Android que eu vou precisar pegar a localização do usuário. Aqui, ó, usuário aí. Deixa eu pegar a sua localização. Se ele permitir, tudo certo. Deixa claro para o aplicativo que ele vai precisar usar de recursos. Salvei aqui. Vamos dar esses carinhos aqui. Instalamos o Async Storage, instalamos o Geolocation, o Permissions. Vamos agora instalar as duas bibliotecas restantes. A primeira é o swipe, para a gente fazer o swipezinho lá na tela. Install React, tracinho, swipe. Instalando esse cara também. Pronto, instalou. E vamos instalar agora o último, que é a instalação do que são bibliotecas que vão ajudar a gente a trabalhar com SVG. Então, é interessante que a gente tenha a biblioteca que esse permita, né, a gente trabalhar com SVG com React Native. Tracinho Native, tracinho SVG, essa é uma das. Depois a gente vai instalar uma última, que é a SVG Transform. Ela vai facilitar ainda mais, junto com a SVG, a gente trabalhar de forma passo a passo. Então, depois desse cara, vamos instalar a nossa última. E aí, mais instalar coisas, vamos começar a meter a mão na massa. SVG transforma. Beleza? O Adriano falou uma tonelada de dependências. É porque, na verdade, são poucas dependências, só que eu estou instalando tudo de uma vez para a gente acelerar logo delas. Mas são basicamente as coisas básicas que a gente vai precisar para fazer o projeto de Então, ó, eu instalei aqui a React Native SVG Transformer. Eu vou só fazer o seguinte: eu vou jogar aqui no Google para a gente ver a link dela. E eu vou mostrar para você um detalhezinho importante Depois de instalado, né, eu preciso abrir o meu arquivo metro.config.js. Esse arquivo abrir ele aqui, o meu tá, ó, só com esse básico aqui. O que a gente vai fazer? Vamos pegar isso aqui, esse código que está aqui, ó. Vou copiar esse cara e eu vou vir para cá. Eu vou colar aqui embaixo e agora eu vou juntar todos. Ou seja, aqui eu tenho o módulo export transformer, aqui eu tenho o módulo export e eu tenho aqui, ó, o transformer também. Então, eu tenho então o que eu vou fazer? Eu vou copiar esse cara apenas, copiei esse cara apenas, e eu vou vir pra cá, colar ele aqui e eu vou ligar aqui. Então basicamente eu estou juntando aqui eu tinha e juntando com o que a biblioteca me pediu para fazer, tudo bem? Beleza, configurando aqui, é só isso que eu precisava configurar para que o SVG funcione 100%, beleza? Tudo instalado, pronto pra gente começar a brincar, tudo bem? Então vamos lá, ó. Esse projeto depois de instalar tudo isso, vamos ver se está funcionando certo. Então, npx react run, como eu estou com Android, então, não, como eu falei, não são muitas bibliotecas, né? Você falou que acha que é muito, então também isso, e o fato de eu ter instalado tudo isso, o Eric Cordeiro falou que essa dependência deixa o projeto mais pesado. Você vai ter uma pastinha aqui chamada essa pastinha fica pesada, e aí o projeto do React ela vai ficar pesada, tá? Mas ela em si, quando você compila tudo e gera o aplicativo, ela é juntada só o que interessa, é só o supra-sumo, é só o que você realmente utilizou e ela junta, então fica tudo certo, beleza? Então, ó, tá rodando aqui o nosso projeto. Tudo. Beleza, ó. Welcome to React, projetinho rodando com sucesso. Então, vamos começar do basicão do começo, né? Então, olha só. app.js, vai começar. Deletar tudo dele e vamos começar do básico. Import React, né? Criamos o projeto, instalamos as bibliotecas e vamos começar agora fazendo a primeira coisa, a primeira configuração da verdade que a gente pode começar a fazer, que é separar, instalar e configurar, né, o nosso React Navigation. Para quê? Para que a gente consiga passar de uma tela a outra. Basicamente isso, tá? Então, vamos lá. Import caixa em que todas as telas vão ficar dentro dessa caixa, e aí tudo que está dentro da caixa consegue pulir de uma tela para outra, tudo bem? Então é obrigatório para você fazer isso se você for o React. Então, você pode criar aqui logo o nosso principal return. Lembrando, todos os detalhes, o que é resposta, depois, essa adaptação, não sei o que, tudo isso eu explico em aulas específicas para a gente aprender no projeto. Cada um dos detalhes. Já podemos criar a nossa stack, nosso stack navigation, tá? Então, ó, eu vou vir aqui, vou criar uma pastinha no nosso projeto chamada SSC. Dentro dessa pastinha é que a gente vai criar, na verdade, todo o nosso projeto, tá? Então, primeira coisa que a gente vai criar nessa pastinha aqui é outra pastinha chamada stacks. E aí, tudo a gente vai separar cada coisa do seu quadrado para ficar um projeto organizado que facilite a manutenção, tudo bem? Então, essa pastinha de text eu vou chamar esse arquivo de main.js. Em outras palavras, esse aqui é o principal do nosso projeto, tá? É o que começa a executar, tá? Então, criei já a gente foca nele. Eu vou importar ele aqui agora. Entrar na página CRC main stack. Beleza? E aí eu jogo aqui dentro do meu navigation container e vou jogar o main stack, a minha stack principal. Certo? Beleza. Importei aqui o stack principal. Vou salvar aqui por enquanto. Vou salvar aqui. Erro. No nosso main stack, que é onde a gente começa a organizar os nossos sistemas. Então, vamos lá. Ó. Import. React. Import. Importar um carinha chamado Create Stack Navigation. Stack.navigation. E aí aqui dentro a gente vai botar as telas que a gente precisa, tá? Então, como eu falei, voltando aqui para o nosso layout. Agora a gente vai ficar sempre voltando para o layout, tá? E aí eu peço desculpas, porque o Adobe XD ele é branco e o layout ele é um pouquinho claro, né? Então, às vezes, se fizer isso aqui, ó, tudo preto, né? Aí eu vou abrir tudo branco. Então, se você estiver numa sala escura, ou se você estiver, sei lá, epilepsia, vamos lá. Telinhas que a gente precisa para a gente começar. Login e cadastro. Então vamos começar do básico. Vamos abrir aqui a tela preload, então. Stack.screen name preload, vou chamar ela de component, e aqui eu vou botar o componente. Eu preciso criar esse carro. Vou copiar e colar duas vezes, e aqui a gente vai fazer o do login, que eu vou chamar de sign in, e o nome da tela, sign in. E aqui, sign up, seria o cadastro, tá bem? Então, 3 telinhas aqui, e agora vamos criar essas telinhas. Aqui, vai continuar dando erro aqui, tá? Até a gente completar isso aqui na pastinha SNC cria uma nova pasta e nessa pasta aqui eu vou salvar todas as técnicas do meu sistema. Então eu vou chamar aqui Screens. Lembrando, isso daqui não é um padrão universal que todo mundo na nossa internet utiliza. Isso daqui simplesmente é uma forma de organizar. Muitas pessoas usam esse padrão que eu estou utilizando aqui, tá? Mas não é todo mundo, obviamente. Então, aqui nas Screens, vamos criar essas três telinhas que a gente precisa para a gente começar. Então, e, na verdade, não vou nem criar uma e estrutural da tela. Vou criar uma pasta chamada Preload. E aí, dentro dessa pastinha, eu vou criar dois arquivos. Um arquivo index.js, que é o arquivo principal da tela, basicamente. E um outro arquivo chamado styles.js, que é a estruturização dessa tela Preload, da pasta Preload. Tudo bem? Então, React, import. Eu já vou importar também a minha styles, Vou importar agora aqui ponto barra styles e eu importo aqui porque eu preciso as coisas, os componentes que eu precisar, tudo bem? Então, olha só, aqui vamos criar um principal chamado que é basicamente o que envolve toda a tela, o início e toda a tela, beleza? Beleza? Salvei aqui. Agora eu preciso criar esse container aqui dentro. Styled components barra, como é para aplicativo, native. O Styled components também funciona para front-end, você criar sites também. Aqui é muito fácil. Export, container, styled, está criando e a gente vai importando ele para cá e usando ele na tela Preload. Tudo bem? E aqui no meio eu vou fazer o seguinte, eu vou botar o texto básico aqui, text do React Native, aqui, text, e eu vou botar aqui o nome da tela, então, Preload, por exemplo, tá? Telinha pronta para ser exibida do jeito que está aqui. Eu vou fazer o seguinte, vou copiar a pasta Preload. Duplicar fazer a mesma coisa. E de novo eu vou entrar aqui no index do site, eu vou chamar então tenho aqui as três telas já criadas, um textinho dentro dela só para a gente ter a tela, tá? Então vamos vir para cá agora e voltando no Skype. Vamos importar essas três telas para a gente poder usar elas aqui. Que eu vou chamar de pronto, tenho aqui as minhas três telas. Agora sim, não vai, provavelmente, né? Não vai dar nenhum tipo de erro. Se eu atualizar aqui agora,
你的山就不肯往前的预感，我赞同你的选择。
Reactivate.
你是看着眼泪飘飘泪点点跌撞成的走着。
Já vai ter pelo menos as 3 primeiras telas e aí a gente já começa a trabalhar na primeira tela, que é o que basicamente vai decidir se o cara tá logado ou não, tá bom? Pronto, e as outras telas estão escondidas, mas prontas para a gente conseguir brincar com elas, tá? Então vamos lá. Primeira coisa que eu vou fazer nessa tela, ó, perceba, nenhuma dessas telas aqui tem cabeçalho, né? Ela simplesmente é focada no conteúdo da tela em si. Então o que nós vamos fazer? Vou vir aqui nesse stack. E aí, o que eu vou fazer? Eu vou botar aqui e uma das opções que eu vou botar é a Header Show, tá? E aí eu vou botar aqui false. Ou seja, eu salvar aqui, o cabeçalho subiu. Fica só a própria tela, só o conteúdo da tela mesmo, tá? Nenhuma das telas desse stack vão ter esse cabeçalho aparecendo. Legal? E a outra que normalmente eu faço por segurança é a Initial Route Name, ou seja, eu estou estabelecendo qual é a primeira tela que vai ser carregada. Então, telinha chamada Preload, sempre. Veio para esse stack, primeira telinha, Preload, tá aqui. Então, estou na minha tela Preload, agora sim vamos começar a brincadeira com ela. Então, por enquanto eu vou deixar esse stack aqui, eu vou abrir styles da minha telinha Preload, legal? A gente focar na telinha. Vamos lá, ó. O que essa tela vai fazer? Eu expliquei ela logo no começo, mas vou explicar aqui mais tecnicamente, tá? Essa tela basicamente ela vai ter esse SVG aqui, já a gente vai botar ele na tela, tá? Ela vai ter esse SVG, aqui embaixo eu não botei no layout, mas ele vai ter um loadzinho, vou botar o loadzinho também, vou botar e aí, enquanto essa tela está aparecendo, o que está acontecendo? E aí, basicamente, todo aplicativo que tem login usa esse tipo de coisa. Ele vai, primeiro, verificar se existe algum token de login salvo já no seu aplicativo. Se existir, ele vai validar esse cara para saber se esse cara realmente existe. Tá? E aí, se ele existe, está tudo certo, beleza, se ou ele não tem nenhum token salvo, ou tem algum token, sei lá, botar de forma oficial, enfim, deu alguma coisa, não validou o token, ele vai para o login. Ou não tem ou tem algum token errado, ele vai para o login. Basicamente essa é a função dessa telinha, beleza? Vou começar a brincadeira mesmo. Primeira coisa, deixa eu pegar aqui a cor do fundo. Essa cor do fundo a gente vai usar em muitos locais, né? Então, ó, é que selecionarzinho aqui, eu vou começar brincando aqui com o meu container. Ele vai ter background color e flex 1 para pegar todo o espaço da tela e vai botar o no meio da tela. Justify center, align itens center, beleza? Então, todo o conteúdo dessa tela vai ficar justificado horizontalmente no meio e verticalmente também no meio. Vai ficar no meio da tela, dependendo do tamanho da tela. Então, salvando aqui a brincadeira, olha lá, o aplicativo já ficou azulzinho e com um textinho no meio, tudo bem? Vamos continuando agora. Eu vou tirar o texto. Eu tenho que botar duas coisas aqui. Primeiro, aquele SVGzinho, basicão. Logo abaixo, loadzinho, né? Então, olha só. assets, eu vou, na verdade, copiar todos os SVG que a gente vai utilizar nessa aplicativa. Eu tenho uma pastinha com todos eles aqui. Eu vou copiar todo mundo e eu vou jogar aqui, tá? Incluindo esse próprio desenho aqui, tá? E vocês vão ter esse material disponível tá? 18 SVGs. Pra cá. Pronto. Ó, tá todo e o que a gente vai ser interessante agora é esse parent.svg. Se eu abrir ele, vamos primeiro carregar esse cara como? Já que a gente usou aquela biblioteca, a React Native SVG Transformer, tudo que a gente precisa fazer para usar o SVG é import logo from assets e aí eu ponho o nome do arquivo, né? No caso vai ser pronto, ele se transforma, em outras palavras, né? Em um componente e aí eu venho para cá eu ponho e aí eu ponho alguns propriedades como tamanho ou então tamanho vou botar e a altura 160, tá? Basicamente isso. Certinho. E tcharam! Tá aqui a minha logo do meu banner. Legal? Então, logo devidamente posicionada. Vamos fazer agora o carregar outra carinha chamada loading. Loading icon style e o nome do componente que a gente vai usar é o activity eu vou botar aqui no 50 pixels só para ele escolar. Tá? Então, eu criei o componente e eu vou usar ele para o outro baixo. Então, loading icon. Os tipos, né? Então, size, que é tudo maiorzinho, né? Color. Legal? E ver como é que vai ficar a nossa tela. Olha lá. Olha que legal. Íconezinho bacana. Loadzinho bacana. Nossa tela de preload, pelo menos eu faço aqui visualmente. Tá pronta. Não é mesmo? Ó, essa é a telinha. Aqui ela funcionando certinho. Legal? O que a gente vai fazer agora? Vamos fazer ela funcionar. Né? Não importa se só assim funcionar. Então, vamos fazer ela funcionar de verdade. Para isso, o que a gente vai precisar? Vamos importar o meu Asset Storage para utilizar esse cara. Assim. Vamos importar ele para conversar aí eu mas vamos lá. Vou importar aqui também o Use Effect para que assim que essa tela abra cadê o link das imagens? Vai estar disponível, tá? Vai ter todos os SVGs que você então vamos lá. A gente vai botar esse cara toda vez que a tela abrir, ele vai executar o código que eu botei aqui dentro no meio. E que código vai ser esse? Vamos lá. O código de verificar o token, que é uma função chamada check token. Só assim. E vamos executar tá? E o que é que essa função vai fazer? Basicamente ela vai fazer o seguinte: ela vai tentar pegar o token salvo no aplicativo. Ela vai ver se tem, na verdade. Vou chamar ele de token. Beleza? Então, esse cara aqui, ele pega o token e salva o aplicativo. Então, eu posso fechar o aplicativo, eu posso abrir ele novamente, e ele vai estar lá salvo bonitinho, tá? Pegou, primeira coisa que eu vou verificar, se tem alguma coisa. Por exemplo, aqui não vai ter, né? A gente nem fez login na hora nenhuma, vai ter. Então, se token for diferente em outras palavras, se tiver conteúdo, a gente parte para o próximo passo, que é validar o token. Então, o que a gente faz aqui? Manda o cara pro login, tá? Logo de cara, manda o cara pro login, tá? Beleza. Para a gente mandar o cara pro login, vamos usar o Navigation. Vou trabalhar com muito nesse projeto. Então, assim, daria certo fazer apenas assim, também funciona. E aí, olha só. Navigation, tá? E aí o que a gente vai fazer aqui agora? Se o cara não tem token nenhum, eu vou simplesmente mandar o cara para o termo do link, tá? Então, navigate, e a gente manda o cara para sign in, que é a tela do link, tudo bem? Se ele tiver algum token salvo, aí a gente vai para o próximo passo, que é o passo de validar esse token. Então a gente tem esse basicamente vai salvar, o que vai acontecer? Ele vai vir para cá e nosso preloader está funcionando pela metade. Pelo menos como não tem, ele já está mandando a gente para a tela certinha. O que vai fazer aqui agora? Vamos fazer o login funcionar, o login de cadastro funcionar, e aí sim a gente volta e a gente faz a validação, tendo como fazer essa validação, tudo bem? Ok, então vamos lá, olha só. Antes de a gente fazer a tela de login, a tela de cadastro, eu preciso fazer a configuração da Context API, tá? Que é o que? Basicamente, é uma forma de a gente ter conteúdos salvos, ou seja, poder usar esse conteúdo em qualquer tela, independente da situação. Por que eu quero isso? Por exemplo, eu quero saber qual usuário que está logado. Então, eu quero saber essa informação, por exemplo, em qualquer lugar de qualquer tela do aplicativo que eu esteja, certo? E também modificar essas funcionalidades, etc. Eu quero ter acesso a essas coisas independente da tela que eu esteja, tá? Então, eu tenho duas opções. Uma, na verdade eu tenho várias opções, mas as duas principais, né? É usar o Context API do próprio React, né? Ou então, eu posso usar Redux, né? Uma biblioteca chamada Redux, muito famosa, que era a única mais utilizada antigamente, né? Hoje em dia a gente tem a gente consegue fazer fácil também, tá? Na verdade não tão fácil, é um conteúdo que se você for muito iniciante, você vai ver que não tem como é que esse negócio está funcionando. Mas você vai entender quando ele estiver como é, tudo bem? Então vamos lá. Agora é uma parte bem técnica, tá? Eu vou tentar explicar, claro, mas se você é muito iniciante, já saiba que essa parte agora da configuração do Context é ligeiramente um pouquinho mais técnica, tudo bem? Em que simplesmente criar as telas, etc. Fechar só uma app, realmente vai precisar desse cara. Então, ó, na página SRC, cria uma nova TSMC também, outra pastinha chamada Reducers, que são basicamente ações específicas de local de armazenamento para os nossos dados do usuário. Então, novo arquivo dessa pastinha que vocês Então, esses dois carinhos é o que eu preciso para começar, tudo bem? Então, vamos lá. Aqui, as coisas que vai precisar do nosso React para fazer. Uma delas é e a outra Use Reducer. Esse aqui vai criar já. Então, vamos lá. Primeira coisa que a gente precisa agora: export criar esse contexto de informações do usuário. Agora vou criar um componente específico desse contexto, tá? E aqui ele vai vir usar ele provider, eu vou criar um provider aqui, e ele vai ter um shieldr, então eu vou pegar aqui o shieldr, que é o conteúdo que tem dentro dele. Porque já a gente vai usar esse cara e vai jogar ele aqui englobando tudo isso. Então esses caras vão vir pra cá com o shieldr, tá? Então ó, return. Provider. O shieldr. Os dois carinhos que a gente precisa para usar o nosso reducer. Então vamos importar aqui primeiro. Importe duas informações. Initial state, que é os dados iniciais que a gente vai preencher nesse bloquinho de informações sobre o usuário, tá? E o user reducer que a gente vai criar. Reducers, e eu chamo aqui o meu user reducer, tá? Então agora para esse cara aqui é o conteúdo dele. O conteúdo dele é um pouco mais técnico e um pouco mais visual. Como é que está funcionando o processo aqui, tá? Initial state. E aqui a gente põe as informações iniciais. Que informações são essas? De acordo com o nosso aplicativo, né? Então, olha só, voltando para o layout aqui, onde a gente vai precisar do nosso aplicativo de informações do usuário que está logado. Do layout não tem, mas aqui, ó, esse íconezinho aqui, quando o cara está logado e tem um avatar, ou seja, tem imagenzinha de usuário, não vai aparecer esse ícone, vai aparecer o íconezinho tipo no Instagram. Ele aparece o ícone do usuário aqui, né? O avatarzinho do usuário. Tá? Então, para isso eu preciso saber qual é o outro local aqui, ó, na telinha de favoritos, né? Eu tenho que saber os favoritos daquele usuário específico, então eu posso armazenar essa informação para quando eu for para essa tela eu já ter essa informação. E também os atendimentos, né? São coisas particulares do usuário, beleza? Comecinho, explicado isso, vamos agora salvar essa informação. Então, avatar, começa assim nada, claro, né? E vamos chamar aqui de favoritos, que é uma renda também, tá? Então, são serviços que o cara e a lista de favoritos, a imagenzinha do avatar, tudo bem? Beleza. Feito isso, tem as informações iniciais do usuário que eu vou ficar salvo e eu vou ter essas informações em qualquer tela que eu estiver acessando, tudo bem? Depois agora, lembra que a gente importou dois carinhos aqui? Vamos criar esses dois carinhos aqui, beleza? Então vamos criar esses caras aqui. Então aqui eu vou ter grade de ações que eu vou poder fazer dentro dessa caixinha com informações do usuário. Então, state e action. basicamente vai ser uma das ações, setar o avatar. Então, set avatar. Essa é uma das ações que nós vamos fazer. E o que essa ação vai fazer? Eu vou dar um eu vou copiar o conteúdo inicial, ou o conteúdo que eu quero, que não é mais inicial, mas é o EP, e eu vou alterar avatar. E eu vou mandar beleza? E vou criar aqui um default. Criei o redução. Então, eu nem vou fazer ações para o favoritos e para o apoio por enquanto, para não complicar, beleza? Vamos fazer primeiro só mudar o avatar. Então, eu vou armazenar o avatar. Eu tenho uma ação que possibilita trocar esse valor que está aqui dentro. Basicamente isso. Então, salvei. Aqui, importei os dois carinhos aqui, né? E vamos utilizar ele aqui agora. Então, state e criar ele vai criar esse cara e esse cara. E eu passo aqui para o meu provider. Falei informações mais técnicas, né? Mas que fazem a criação do meu contexto. Tudo bem? Então, criei o meu contexto aqui. Agora o que eu vou fazer? Agora eu vou usar esse cara aqui no app. Vamos importar esse cara aqui. Importa e vou chamar de user context o que eu vou fazer aqui agora? Eu vou pegar esse cara e eu vou englobar beleza? Então, aqui eu tenho a caixinha com informações do usuário que está englobando todo o meu aplicativo. O que isso quer dizer na prática? Quer dizer que o meu aplicativo já tem acesso em qualquer lugar às informações do usuário. Basicamente é isso que eu acabei de fazer aqui. Tudo bem? Então, show de bola. Fizemos a parte da criação do contexto. Agora, sim, a gente pode vir para cá e a minha tela de login. Então, vamos lá. Agora, o que é que nós vamos fazer? Vamos começar do básico, do início, e vamos montando, né, toda a minha tela. Tudo bem? Então, ó, container. Mesma coisa do que fez no meu vou pegar aqui a função novamente. Aqui no fundo dessa tela. Flex. Center, então também o conteúdo dela é no meio, tudo bem? Telinha aqui, beleza. Depois, vamos importar também aquele ícone, né? O mesmo ícone na verdade. Importe, barra, legal? E aí eu vou tirar esse text daqui e vamos botar aqui no meu barber só informação 100% aqui. Atualizar, veio pro upload, depois veio para telinha normal, beleza? Telinha normal, agora o que nós vamos fazer? Esses dois campos, né? O campo do e-mail e o campo da senha. Então, uma dica de ouro todo para você. Agora, quando você vai usar tipo, o mesmo conjunto de coisas em vários locais diferentes, não cria ele aqui para depois duplicar ele aqui. Cria um componente que aí você consegue utilizar em qualquer tela que você quiser. Você faz um código só, e se você quiser tirar você vai aplicar esse automaticamente do mesmo jeito, tudo bem? Então é importante a gente ter essa noção. Vou reutilizar esse código? Sim. Então transforma ele em um componente, tudo bem? Então vamos fazer um componente agora para fazer esse campo aqui. Logo abaixo aqui de Barber Logo, eu vou criar aqui. Chamada de input área, que vai ser a área dentro desse input área. Eu vou ter um componente que eu vou criar, vamos chamar de sign. Eu vou ter o e-mail, eu vou ter a senha, né? E logo abaixo eu vou fazer aqui um botão, vou chamar aqui de custom button. Dentro aqui um textinho que vai ser um texto assim desse cara. Então custom button text login. Então eu tenho a logo, depois eu tenho a área dos meus campos, dois, eu tenho um botão com o e no segundo meu layout eu tenho nada mais é do que eu vou fazer com que todo esse cara seja um botão também, tá? Um botão com dois textinhos, né? Para que se o cara clicar em qualquer lugar aqui, ele possa ir para a tela de cadastro, tá? Isso é fora da minha área de input. Logo aqui embaixo, chamado de sign message button, tá? E aqui dentro eu vou ter dois textos. Sign message button text. E aí depois eu tenho um negrito, né? Sign message button legal? Então criei tudo que eu preciso em termos de componente. E aí, agora eu vou criar cada um desses caras. Tudo bem? Então, input área, já encontrei aqui. Custom button, text e a legal? Vamos para o styles, criar cada um desses caras agora. Export const, é um view, export const, custom button, style, opacity, legal? Depois, é o textinho do botão, agora a mensagenzinha lá embaixo, né? Legal? Então criamos todo mundo, então ele já vai se salvar aqui, ele vai aparecer ele, tudo vai aparecer tudo esquisito, você não consegue ter nada, noção de nada, né? Agora vamos começar a brincar, vamos começar a fazer esses caras funcionarem visualmente, certo? Tudo bem? Input área. Esse cara aqui, o botão é o seguinte, a altura 60, você já tem essa informação, tá? Mas se você vir para cá, clica aqui, no botãozinho, você vai ver a altura dele, 60, tá? Vou só pegar 60. Então a altura 60, ficar arredondado. O texto é cor branca. Salvando. Vai já botar os inputs. Ele ele vai automaticamente esticar e ficar do tamanho dos
就不肯完全的预
Beleza, vamos para a mensagem do botão.
我赞赏你的选择，你是看着眼泪飘飘来的天空中的
Just vai center ele ficar no meio da tela.
快乐。
50 para ele separar o conteúdo, tá? E fecha o botão 20 só para ele. 74, alguma coisa aqui. E vou ficar essa mensagem colada lá embaixo no fim da tela, tá? Então, nesse vídeo, basicamente. E os textos. Size 16 pixels, color. Pegar aqui só aqui.
就不肯完全的预言。我赞赏你的选择，你是看着眼泪飘飘来的天空中的
mesma cor, só que com font weight
快乐。
legal? A frasezinha já está prontinha. O botão também está pronto, mas ele vai ficar bonitinho quando a gente botar o campo, né? Aí ele vai aumentar o diário. E agora vamos para os dois campos. Olha só, agora a gente vai fazer um componente específico para o campo. É um componente chamado Insight Input, né? A parte essencial, uma nova parte chamada Components. E aí todos os componentes extras, né, que a gente for criar aqui no etc., a gente cria e organiza eles aqui dentro. Tudo bem? Então, novo arquivo e mais cara de site.js. Então vamos criar aqui. Eu vou botar a estilização junto do próprio componente, tá? Para ele separar demais também e ficar vamos criar ele aqui. Então vamos criar primeiro uma área para o nosso campo, né? A área visível do nosso campo. Tá? Então, input altura 100%. A altura é 60, né? A altura do campinho, a mesma altura do botão, tá? A altura 60 e agora vamos para as cores. Row, que vai ter campo, né? Obviamente. Tá? Certo? E a padding para ficar tudo colado um do outro. A line e mesh para descolar no próximo campo que mostra aí embaixo. Só o fato de eu botar esse outro que agora não vai tratar mais assim. Vamos conferir o que foi que aconteceu. Tá aqui também pegando lá. Cara, tá aqui. O bumper logo, ok, tá aqui também. Vamos entrar de área, começa background color. Então vermelhão. E, olha só, agora sim nosso campo ó, começa a tomar forma, né? Você consegue ver ele melhor, tudo bem? Voltando aqui para o nosso componente, ele só fez a área do campo, né? Ele não está clicado, ele o que vai fazer aqui agora? Vamos fazer duas coisas, na verdade. Vamos botar um ícone, que vai aparecer aqui, e vamos botar o campo, tá? Então, botar primeiro o ícone. Essa informação do ícone que a gente está utilizando, tá? Vou botar aqui uma prop chamada SVG. A gente passa já o SVG do ícone que a gente quer botar na tela, tudo bem? Então aqui, e-mail, assets, o primeiro aqui vai ser um cadeadozinho, né? Primeiro e-mail tá aqui, o outro assets, acabei de passar basicamente. Eu recebo esse cara aqui, icon SVG, e aqui eu posso jogar ele aqui icon SVG. Vou só botar o tamanhozinho dele. E eu vou ter que usar um aqui, ó, ícones aparecendo. Legal? Tanto do e-mail quanto do log. Tá aqui os dois. Só fica faltando agora o nosso campo efetivamente. Nosso input as várias funções que a gente vai ter que fazer aqui agora para ele, né? Tem o valor, mandar o valor, placeholder, etc. Então, vamos lá. Voltando aqui, vou botar só as considerações sobre o pega o restante da área disponível. Font size 16, o color é o mesmo do ícone. Margin left 10 pixels para não ficar colado tá aqui. Aparentemente não mudou nada, né? Mas se eu clicar aqui, já aparece o meu cursor, abre o teclado e consegue legal? Beleza, vamos botar só um placeholder aqui, tá? Então, aqui, tudo e todas as informações que eu quero colocar vão ter que vir de fora. Aqui é o componente. Então, aqui, a gente vai botar mais informações aqui, né? Então, primeira informação, placeholder, que é o textinho que vai aparecer, né? O nosso layout, o textinho é digite seu e-mail. Placeholder, aqui então, mandei a própria placeholder, eu vou jogar ela, puxar aqui, eu vou jogar ela no placeholder. toda a letra. É essa cor aqui. Place
就不可能完全的预言。我赞成你的选择。
isso aí mesmo. Já vai tomando forma. É fácil, tá pronto aqui. Mas vamos fazer agora funcionando, tudo bem? Então fazer eu digitar, ele salvar em algum lugar essa informação, etc. Tá? Então, vamos lá. Vindo pra cá. Sign input. Quem vai precisar passar o valor, os valores. Então vamos criar state específico para salvar esse valor. Então, ó, use state. Certo? Vamos pra cá. E vamos criar dois states. Primeiro vai ser field set. Use state. E depois os dois states aqui. Eu vou passar aqui como email field e value password field. Então isso quer dizer que eu passei a prop value, eu vou repassar ela para o meu input. Então, vindo pra cá, direto na state. Quando eu salvo, ele já vai abrir o aplicativo com o e-mail digitado. E também, ó, se eu digitar outras coisas aqui, ó, ele me deixa. Agora eu tenho que fazer a possibilidade de mudar o texto, né? Então eu vou vir pra cá. Vou usar o mesmo nome que passa para o outro. Então, on, change text. E aí eu vou vir pra cá. Set, email field. Mesma coisa. Beleza, mandei a prop, vou vir pra cá, receber o on change text e eu vou jogar aqui on change text. A partir de agora, eu posso gravar e eu posso agora sim alterar. Agora eu posso controlar o meu plano certinho. Beleza? E aí essa informação está salva simples assim. Legal? Agora eu preciso fazer só o seguinte. Eu preciso transformar aqui, ó. Então eu preciso agora fazer o seguinte, principalmente aqui na senha. Eu vou botar mais uma prova chamada password true. Quando o password true quer dizer que vai ser uma senha. E aí eu vou vir pra cá, eu vou fazer com que esse campo vire senha. Como assim? Security password. Simples assim. Esse campo aqui continua normal, mas de senha, do digito, ó, ele fica tá? Então, agora sim, o meu sim estão 100% certinhos do jeito que tem que ser. Legal? Então, componente criado com sucesso, utilizado com sucesso aqui nos dois, já tem aqui tudo certinho, beleza? Então, tela de login, state. Tela de login feita com sucesso. O que a gente vai fazer aqui agora? Quando eu clicar aqui embaixo, ele clica a tela de cadastro, certo? Então, ó, o Custom Button, ele vai fazer uma ação para quando eu clicar no login. O login também, né? Mas criar essa funçãozinha aqui, certo? Legal? Quando o cara clicar nesse botão, o que é que nós vamos fazer? Nós vamos basicamente jogar ele para a tela de cadastro. Tá? Nós vamos jogar ele para a tela de cadastro sem possibilitar ele de voltar. Se ele voltar, ele vai ter o botãozinho lá da tela de cadastro. E ele clica, ele vai tá vendo? Então, vamos deixar aqui para a gente fazer já esse botãozinho aqui. E vamos botar a ação. O botãozinho de login, tá? Botãozinho quando o cara clicar no login, tá? Então, clicou no login, já tem o botãozinho aqui agora. Reload, login. Cliquei, já está sendo clicado nesse botão. Também está sendo clicado. Legal? Agora o que é que nós vamos fazer? Clicou no botão da mensagem, ele vai navigation. Legal? E aí, quando o botãozinho da mensagem, o que a gente vai fazer? Notification ponto. E aí, como eu falei, né? Eu vou mandar ele para a tela e voltar, tá? Então eu vou dar um reset. Antigamente era um codezinho que a gente fazia para possibilitar isso. Hoje em dia é uma só se faz. Então, vou mandar um objeto. Esse objeto eu mando aqui as props, eu mando aqui dentro objeto.name e no caso é a sign up. Certo? Então, ó, deixa eu salvar aqui. Tá aqui, certo? Beleza, pra cá, login. Clicou no login, agora ele vai poder fazer o login. Tá? Antes da gente fazer o login, vamos fazer a tela de cadastro, que na verdade é idêntica a essa, então a gente vai dar um Ctrl+C, Ctrl+V e só ativar um campo a mais, né? Que é o campo do nome aqui em cima. Tudo bem? E vou dar o textinho aqui. Então, ó, copiei. Legal? Pronto, temos já duas telas aqui agora. Vou só mudar as frases, né? Já possui a conta. Faça login. E o botão, o nome é cadastrar. Legal? E a gente vai precisar botar só mais um campo aqui. Então, copiar seu nome, o ícone. A gente vai precisar botar aqui agora esse ícone aqui, ó. Person. Vou botar esse cara aqui também. E aí vamos criar um state, dar o nome, name field, set name field, use state, e jogar ele embaixo. Então, e usar trocar set field. Beleza? Sem clicar aqui embaixo, não vai para cadastro, vai para o sign. Salvei, tudo salvo, viro pra cá. Olha só, login aqui, maravilhoso. Cliquei aqui, cadastro, maravilhoso. Já fiz aqui 2 telas, uma para cada só, né? Cliquei, botou o login. Cliquei, cadastro, cliquei, login. Beleza? Então, tenho aqui as minhas 2 telas certinho aqui, prontinhas para eu começar a implementar. Então, vamos agora começar a fazer precisa fazer lições para saber vamos começar a brincar com requisições, tá? Olha só, sempre que eu trabalho com requisições, aí deixa eu só, eu gosto de criar um local específico que vai ficar responsável por essas requisições, tá? E aí a gente faz um local só que depois, sei lá, eu quero mudar o aplicativo para em vez de usar o Backend, eu usar o Firebase da vida. Um local só, tudo certo, tudo continua funcionando, maravilha. Beleza? O que vamos fazer aqui agora? Vamos criar um local só, que ela vai fazer as nossas requisições, tá? Então, ó, essa vai ser e vamos chamar de API.js com uma maiúscula, beleza? E aqui, o que a gente vai fazer? Se a gente fazer a base da nossa API, tá? Eu vou exportar aqui um objeto que vai ter as ações que nós vamos precisar fazer. Dentre elas, a primeira, check token, lá a próxima, sign in. A próxima, sign up, né? Tá aqui, tá? E aí a gente vai fazer depois, tá? Check token, sign in e sign up seria o cadastro, tudo bem? Então, olha só, o que a gente vai fazer aqui agora? No check token, a gente vai fazer uma sign in, outra requisição. Então, as 3 funções elas são muito similares. Eu vou fazer as outras, para você entender ela explica bonitinho a requisição e já só tem que colocar as outras, tá? Então vamos lá. Vou botar aqui https api.dev/API. Essa é a base da minha API, tá vendo? E a requisição basicamente é isso, barra, o que eu vou fazer, tá? O login vai ser o seguinte, ó. Para fazer o login, requisição, await. Eu vou dar um fetch. Botar uns headers ele vai mandar em inglês, no formato ou seja, o conteúdo que eu vou estar mandando no e-mail e no senha, certo? Essa função. E eu mando 2 caras para cá, tá? Então, é o mesmo nome da variável, então eu vou botar e-mail peço também, as 2 variáveis. Vai fazer a requisição, vai receber a resposta, eu vou transformar essa resposta em um JSON. Então, const JSON await.json, e eu retorno a requisição. O Pedro falou ali, eu vi aqui, fica mais fácil usar Axis. Tem gente que gosta do Axis, mas o processo, eu não queria botar uma outra mas uma vez que você aprendeu a fazer o fetch, que é a forma nativa, né, de fazer a aquisição, você pode usar o Axis sim, ele vai facilitar a sua vida sim, tá? Você só configura muitas dessas coisas, você simplesmente se foca no endpoint e nas informações que você está dando. É muito interessante, tá? Então, fiz aqui a requisição de login, a requisição de copiei, colei, e o que vai mudar é o endpoint. Tá, o Vinícius falou, caracas, eu aqui, mas repete a sua o endpoint do cadastro é user, post também, e no caso aqui eu vou receber mais uma informação, o e-mail e o password, as três informações, e é o mano, e o password, legal? Para fazer o cadastro do usuário. Então, fiz a requisição do login, fiz a requisição de cadastro, vamos fazer também a de check token, tá? É a mesma coisa. O endpoint que é tudo bem? Eu mando receber o token, dá esse token. Ele vai dar um refresh nesse token, tá? Ele vai dar um novo token se ele fizer essa verificação. Aí eu já salvo esse novo token, vou fazer isso na prática. Tá? Salvei, tenho aqui agora 3 requisições que eu vou fazer: login, cadastro e check token. Vamos usar essa galera na prática? Vamos lá, todo de login aqui. O que eu vou fazer aqui agora? Eu vou importar esse meu arquivo API, certo? API. Importei minha API. Agora é só utilizar esse carinha. Quando o cara clicar no botão de login, o que eu vou fazer? Eu vou vir pra cá e eu vou basicamente primeiro verificar se o cara digitou o e-mail e senha. Se o e-mail field tá diferente do vazio e password field de vazio, quer dizer que os dois estão digitados, mas pelo menos digitados, né? Caso contrário, os campos. Tá? Caso que eu queira usar essa API para fazer login, legal? Let essa resposta você pode chamar de JSON também. Você vai receber o mesmo de forma, né? Await API e para você fazer login, sai dele. E o que é que eu tenho que mandar para essa função? Email field e password field, basicamente. Legal? Então eu vou receber a resposta aqui. E aí o que eu faço com essa resposta? Eu fico. Sei que tem que ser um erro, alguma coisa. Então, JSON.token. Se eu tiver recebido um token, agora eu vou para o próximo passo. Salvar esse token, etc. Caso tenha dado problema, vou botar aqui e ou senha legal? Então, se deu certo, deu certo. A gente trabalha nisso já já. Se deu certo, deu certo. Não é assim que é a função? Ah, tá. Então, vamos transformar essa função
那就不可能完全的预言。我赞成你的选择，
vem pra cá.
你是爱着眼泪飘飘来。
Eu tenho um usuário que eu já pré-criei. A gente vai fazer um cadastro do novo usuário, mas não tem problema não, tá? Um usuário que eu pré-criei é o suporte@pcr.br e a senha dele é 1234. Legal? Cliquei em muito lindo. Vamos só verificar se ele está mandando tudo certo, se está tendo alguma resposta. Console.log e vou dar um console log ver o que está acontecendo com a resposta que está recebendo, etc. Salvei. E errado, beleza. Mas vamos ver aqui agora o que ele recebeu. Erro não autorizado. Vamos ver se ele está mandando as informações certinhas, tá? Então, sai aqui. Password field, beleza. Vamos ver só se e-mail field e password field estão preenchidos. Para ver se a gente está mandando as informações. Vamos ver isso aqui dentro. Sign in, e-mail, password, legal? Então vamos ver se a gente está recebendo as informações certinhas. Salvei. Pra cá e olha lá. E-mail suporte e senha 234. Ok. Ele até aqui recebeu a informação certinha. Agora vamos ver aonde que é esse certinho, né? Como é que ele está, sei lá, alguma letra, ele então realmente eu acho que é assim, eu esqueci a senha. Como é que eu vou então realmente a senha está errada. Está mandando as informações, mas a senha está errada. Então a gente resolve no cadastro. Sem problema. Então aqui todo mundo está recebendo a resposta, o que é bom, né? Então, deu certo, tá? O que a gente vai fazer agora? Vamos pegar esse cara e vamos jogar no cadastro. Vai só com o index dos dois, tudo bem? Então, ó, aqui no cadastro, o que é que nós vamos fazer? Vou pegar a gente cria uma conta e a gente tenta fazer o cadastro com ela, tudo bem? O login também faz com ela. Então, e aqui é só utilizar. Aqui eu vou fazer a verificação, na verdade, em 3 campos, né? Então, name field. Está preenchido? O que a gente vai fazer? Continuar. Caso contrário, preencha os campos. Legal? Beleza. Se está tudo preenchido, vamos para o próximo passo, que é fazer a condição. Então, do mesmo jeito que a gente fez o login, a gente faz o cadastro. Então, let as await agora é essa cadastro. Especificamente, date field, age field, 3 campos. Beleza? Feita a requisição com os 3 campos, a gente faz a verificação. Tem token, ele faz o cadastro e ele loga automaticamente também, tá? Então, tem token. Não tem token, tem algum problema, então a gente pode exibir o erro. Isso deu certo. Deu certo. De toda forma, eu vou vir pra cá e vou dar tudo bem? Salvei. Vamos vir, opa. Assim que também aqui. Assim que. De clique. Vem pra cá. E vamos fazer um cadastro, tá? Eu vou botar aqui um nome. Vou botar aqui, Boniek, testador, o e-mail e a senha, vamos botar 1, 2, 3, 4, tá? Cadastrado. Dados incorretos. Agora e password. São as 3 informações que eu preciso dar. Vou fazer o seguinte, vou desconfiar de alguma coisa aqui. Eu vou testar essa API diretamente no browser. Criar um usuário por aqui, tá? Se eu não mandar nada, dados incorretos. Ok. Então, se eu mandar e testar então, a API está funcionando. Realmente é alguma coisa no aplicativo. Tem alguma coisa que eu não tenho certinho Eu vou remover o header para ele mudar, para ver se não é esse cara. Acho que eu estou digitando alguma coisa. Vamos sign in. Sign up. Agora que a gente criou, né? Criamos um usuário aqui. Vamos criar de novo. Arquitect@hotmail.com e assim 1, 2, 3, 4. Então vamos testar ele. Fazer login com ele, tá? Não dei certo. Stringify. Vamos testar aqui agora. Sem método, tá? Post e o body. Agora vamos tentar fazer login. Então vamos tentar fazer login. O erro mesmo foi não autorizar. Então quer dizer que ele não está recebendo dados. Vamos ver se eu estou mudando. O URL. Jason Shopify completo também.
你的山就不肯往前的预感，我赞赏你的选择，你是看着眼泪飘飘泪在天天双双的走着，快乐，你的笑就是一场的保护伞，你决定不爱了，你决定不爱了。
Teste, é teste normal.
让它紧跟，是在等我的。
Teste @rotina.com, certo?
你的山就不肯往前的预感，我赞赏你的选择。
Agora vamos conferir aqui.
你是看着眼泪飘飘泪在天天双双的走着。
Ok. E o body? E-mail, o password, tá aqui também. Tem sentido, tá? Eu vou copiar do aplicativo funcional, a colinha do aplicativo funcional. Copiar esse mesmo código desse trecho do login. Vamos ver se algum
你的山就不肯往前的预感，我赞赏你的选择。
essa base.
你是看着眼泪飘飘泪在天天双双的走着，
Agora vamos testar.
快乐。
Se não funcionar,
你的笑就是一场的保护伞，你决定不爱了，你决定不爱了。让它紧跟，是在等我的。
e agora vamos fazer o login. Connect teste arroba
你的山就不肯往前的预感，
cliquei,
我赞赏
deu certo.
你的选择。你是看着眼泪飘飘泪在天天双双的走着。
Header, por causa de um S, eu botei header e era headers, plural. Por causa de um S. Beleza, show de bola, show de bola. Agora o que é que a gente vai fazer? Eu vou copiar aqui esse cara, eu vou colar ele aqui no cadastro e vou mudar aqui só o endpoint. User,
你的山就不肯往前的预感，
Caraca, só um S.
你的选
Show de
择。
bola, beleza. Sem problema.
你是看着眼泪飘飘泪在天天双双的走着。
Beleza. Olha só. Então, agora pelo menos sabemos, né? Você aprendeu, essa foi uma aula que foi de propósito, né? Uma aula sobre derrubar o código. Se tocou aí, legal, né? Sobre isso. Vamos lá. Deu certo, pelo menos, né? Então, a partir do deu certo, agora a gente já fez login, já temos o token certinho. Próximo passo, deixa eu tirar esse console aqui. O próximo passo, tanto no login quanto no certo, é a gente salvar esse token, recém-criado, certo? Obviamente. Então, o que nós vamos fazer? Olha só.
你是看着眼泪飘飘泪在天天双双的走着。
Vamos tirar o deu certo. E a gente vai fazer o seguinte. Uma vez que a gente tem o token, agora chegou a hora de a gente fazer 3 coisas na verdade. A primeira, a gente precisa salvar no Async Storage o nosso token, para que se a gente fechar o aplicativo, a gente abrir de novo, ele esteja lá basicamente, tá bom? Então, o que a gente vai fazer? Já importei o Async Storage? Não, então deixa eu importar o aplicativo.
就不肯往前的预感，我赞赏你的选择。
Ele aqui. Agora vamos.
你是看着眼泪飘飘
Então, await assim ponto set item, e aí o nome do item é token, né? Lembra que eu peguei lá a gente seta ele agora, token, e eu mando o quê? JSON.token. Então, salvo o meu Async Story nesse token. Próximo passo. Além do token, eu também tenho outras informações. Aqui, ó. Eu tenho, ó, o token, tá? E eu tenho também o data, que tem, ó, o ID, e eu tenho o e-mail do cara. Tudo bem? Eu só preciso do avatar, por enquanto. Por quê? Porque eu vou salvar quando eu jogar ele lá no contexto. Lembra? Então, pegar aqui o primeiro passo, salva assim. Segundo passo, salva no contexto. Então, agora a gente precisa usar o contexto. Só cortar tá? E aí eu vou importar tá? Agora, vamos vir pra cá e vamos criar o display para poder mandar informações para o meu contexto, tá? Contexto. E aqui eu vou pegar o dispatch. Eu vou renomeá-lo, tá? Para user dispatch. Agora, salvamos no assim. Agora vamos usar o nosso user dispatch. O nome da minha ação, deixa eu abrir aqui o reducer para te mostrar a ação que criou, set avatar. Legal? Set avatar. Depois reload para a gente mandar aqui o próprio avatar para ele salvar. Então, avatar data.avatar. Legal? Salvei, então ele vai salvar. Passo 2, salvar no meu contexto, eu já tenho essa informação, e depois ele vai mandar o cara para home, né? No caso para os tabs, né? Que vai ter o tab, etc. Então, aqui o que eu vou fazer? Eu já tenho o navigation. Eu vou deixar o cara voltar, né? Vou deixar o cara voltar pro menu, ver se ele sai do menu. Então, reset. Route. E aí, aqui, a minha main stack, eu vou precisar criar mais uma tela que seria, na verdade, o meu tab, né? Eu vou chamar de main tab. Legal? Esse passo salva no contexto, né? E o terceiro passo manda o cara para o monitor. Tudo bem? Então, o login feito com sucesso. Vamos fazer a mesma coisa agora, só para quando o cara fez o cadastro. A mesma coisa, na verdade. Então, vem para cá. Deu certo, eu tenho aqui o token, tá? E eu vou fazer exatamente a mesma coisa. Eu vou até os importes que eu dei aqui em cima. O importe do vou copiar criação do dispatch. Criação do dispatch. O conteúdo aqui é exatamente o mesmo. Assim, o dispatch e o reset mandando o cara para a tela. Salvei. Só que o cara Quando eu faço login aqui, quando eu cadastro, o resultado é e quando eu adapto com as informações daquele usuário. Beleza? Salvei. A partir de agora, uma vez que eu fizer o login, eu vou estar logado. Tá? Então, ó, eu vou vir pra cá, eu vou fazer o login naquele primeiro usuário lá que eu tenho tentado criar, tentado fazer. Suporte, senha, 1, 2, 3, 4. Deu erro aqui por quê? Porque não existe a porta que a gente não criou ela ainda. Tá? Então, fechei aqui, mas ele fez as outras etapas, salvar assim, storage, etc. Isso quer dizer o quê? Quer dizer que se eu ele vai entrar no upload, ele vai sair daqui. Por quê? Ele vai vir agora dentro do token, que ele achou o token, certo? O próximo passo agora do meu download é o quê? É eu validar esse token, certo? Então, vamos no processo de chamar a API para validar o token. A gente já tem, inclusive, né? A API criada, prontinho para requisição do token de validar, certo? Então, o que a gente vai fazer? Vou vir aqui, vou importar a API. Legal? E vamos usar ela aqui bonitinho. Vai ser await API.checkToken, né? E aí eu mando esse token. Legal? Mandando o meu token, o que eu vou fazer depois? Vou verificar se ele me retornou um novo token. Ele só vai me retornar um novo token caso funcione efetivamente. Tá bom? Token funcionou. Tá? Caso não tenha funcionado, quer dizer o quê? Quer dizer que o cara tinha um token, mas esse token tirou ou fez alguma coisa do tipo. Tudo bem? Aí tá, pessoal. Então, se ele não deu algum problema com o token, o que ele faz? Não preload? Qualquer coisa que aconteça que não deu certo, manda pro login. Tudo bem? E se deu certo, obviamente, o que ele vai fazer? Aquelas mesmas três coisas. A gente vai salvar o login do assento atualizado. A gente vai usar o dispatch para salvar o avatar, e a gente vai jogar o caso no interno. Tudo bem? Mesma coisa. Vou até copiar o código aqui. Salvei. Salvei. Só tenho que importar. Set avatar aqui. E depois eu o cara pro interno. Tudo bem? Só importar aqui. Essa história já está importada. Beleza? Só não tenho o dispatch. Preciso importar aqui só. Esse aqui. E eu preciso importar o meu user context. Então, preloadzinho aqui agora, ó. Ele vai ter que dar outro tipo de erro, não esse. Mas esse aqui, que é um erro que basicamente ele não mostra o erro certo, mas ele não tem que encontrar o meu primeiro. O check token está com o conteúdo errado. Só o token. Ele verificou, e aí sim, agora sim, coisa do reset. Por quê? Porque nós não temos. Então, basicamente agora, o que nós fizemos a tela triple load com todas as verificações dela, fizemos a tela de login e de cadastro com todas as verificações dela e fizemos aqui, vamos fazer na verdade, a tela home, tudo bem? Então, aqui na tela home, o que eu vou fazer agora? Vamos primeiro criar o meu tab bar, né? Para a gente focar, criar as telinhas. Depois a gente vai fazer o meu tab bar aqui, esse tab bar personalizado. Legal? Então, ó, vou fechar essas telas aqui para a gente começar a focar novas telinhas aqui agora. Então, stack. tab.js. Legal? Legal? E agora eu vou criar o meu tab bar. Né? Então, import bottom tabs, que na verdade é create bottom. Vamos criar um tab mesmo, né, com todas as tags que a gente vai precisar. Então, é exatamente igual a gente fez no stack, só que aqui é tag. Então, aqui a gente vai botar as nossas telas. Então, ó, tab.screen telinha search, que é a telinha de buscar a pessoa, né? Telinha appointments, que é a telinha dos seus agendamentos, telinha dos favoritos e a telinha do perfil. Essas 5 telinhas aqui. Vou criar aqui já o atalho para todas elas. 5 aqui. E vamos criar todas as 5 telinhas para a gente focar, já ter todas as telinhas prontas. Então vamos lá. Home, search, depois appointments, favoritos, profile. Legal? Então, 5 telinhas aqui. Agora eu preciso criar essas 5 telinhas. Então vamos criar uma tela básica, como a gente fez, né, com o stack, para a gente poder importar todo mundo aqui. Importar todo mundo para o tab funcionar e a gente focar no tab. Tá bom? Então vamos lá. E aí eu vou criar aqui o APS e o arquivo componente. Next, import. Componente basicão, na verdade. Import text, do React Native. Vamos botar um textinho dizendo qual é a tela. Saltei. Vamos só criar o container. Export const container. E aqui eu Save Area. Legal? Ó, criei os meus dois carinhas aqui no caso tela home, né? E vamos criar as outras telas. Vou fechar aqui. Vamos criar a da Search. Copiar lá. Renomear para Search. Certo?
就不可能完全的预感。我站在你的选择，你是看着眼泪飘飘泪在天地狂奔的走着，快乐。你的笑就是一场的保护伞，你决定不爱了，你决定不爱了。
Então criei as 5 telinhas, né, que a gente precisa. Agora vamos só importar essa screens salvei. Ele veio aqui para o meu preload, né? Nada nem fiz nada com esse main test. Então vamos agora para o meu main stack e vamos criar as panelas. Vou puxar o main tab. Vou criar main tab e manda para componente tab. Legal? Salvei. Então a partir de agora eu copiei por aqui e regerar o aplicativo. Espera só ele voltar aqui. O meu deve estar funcionando 100% com as minhas 5 telas. E aí sim, agora ele vai voltar a criar o nosso tab-bar, ó. Maravilhoso. Legal? Reload e mais para home. Legal? Então, home, search, appointments, favoritos e profile. Legal? Então, ó, tenho aqui agora todas as minhas 5 telas aqui. Eu consigo modificar clicando aqui embaixo em cada uma delas. Legal? Beleza. Tab-bar pronta e funcionando. Vamos agora vamos fazer esse nosso, entre aspas, custom tab-bar, né? Então, vamos fazer um componente novo arquivo e vamos chamar de custom tab-bar. Esse cara vai ser o meu tab-bar. Então o que eu vou fazer com esse cara? Deixa eu já criar aqui tab área, styled.view, certo? E aí, o que é que eu vou fazer aqui? 60 pixels, que é a altura do tab-bar. Deixa eu só pegar aqui desse fundo,
就不可能完全的预感。我站在你的选择，
fica ao lado do outro.
你是看着眼泪飘飘泪眼狂奔的
Salvei, estou com um componente certinho aqui, o meu derivar customizado certinho aqui. O que eu vou fazer agora? Eu vou colocar esse cara aqui dentro do meu main tab, invoco custom derivar components custom derivar. Veja o que eu vou fazer agora. Eu vou vir no meu dev.navigator e eu vou dizer para ele, ó, não usa o derivar que você usa o agora. Eu vou passar para você agora. Então, derivar. Eu vou mandar esses próprios para o meu componente. Custom derivar. Eu vou mandar as próprias para ele, o meu próprio componente. Quando eu fizer isso aqui, que eu salvar, olha só o que vai acontecer. Vou para cá e olha só. Legal? Já apareceu aqui o meu próprio derivar. Então agora eu tenho basicamente um componente que eu posso criar esse meu componente do jeito que eu quiser. Legal? E aí por isso que eu vou criar do jeito que eu quiser. Tá? Vamos lá. Aqui. Então, ó, eu vou ter aqui vários itens. Eu vou ter aqui. E vai ser o governo dele no botão, né? Um touchable, posso botar aqui um touchable opacity dentro dele. Então, vamos primeiro criar todos e aí a gente põe eles aqui. Então, eu vou colocar esses caras todos aqui.
就不可能完全的预感。我站在你的选择，
tá?
你是看着眼泪飘飘泪眼狂奔的走着。
Search icon, o arquivo é o search. Eu vou copiar aqui. Today, ele é um calendáriozinho. SVG. Depois eu tenho favorito icon, que é o coraçãozinho. Que é o símbolozinho do perfilzinho. Tá?
就不可能完全的预
Peguei aqueles 5 ícones que eu preciso. Agora e vamos botar vou botar 24 por 24, tá? E branco. Legal? Então vamos criar só esse tab item para ele funcionar. Então esse tab item nem viu. Touchable. Opacity. Certo? E nesse touchable opacity eu vou botar aqui o flex 1 e vou centralizar o controle center.
我站在你的选择，你是看着眼泪飘飘泪眼狂奔的走着。
Apareceu o meu primeiro íconezinho aqui. Vou só copiar e colar. 5 vezes. Tá? Então, esse aqui é o search. Esse aqui é o today. E esse aqui é o account.
就不可能完全的预感。我站在你的选择，你是看着眼泪飘
Daqui no meu tab bar, eu posso clicar nos itens, eu posso clicar na verdade, ele só não tem nenhuma ação que ele vou fazer a ação em cada deles. On press, ou seja, quando você apertar o tab bar, ele vai você. Vou criar aqui uma função já com o próprio navigate, um atalho, meio que um atalho, né? Então go to e aqui eu digito o screen name, né? O nome da tela. Basicamente o que ele vai fazer? Ele vai fazer o duas coisas, state e navigation, tá? Ele vai receber o meu navigation, eu vou usar ele. Navigation, e aí quando eu clicar aqui, o que eu faço? Eu vou ter uma função que faz go to. Vou colar aqui todos esses caras. Aqui vai para appointments, aqui vai para favorito. E aqui vai para loading, carregou, cliquei, search, cliquei, appointments, cliquei, favoritos, cliquei, profile, cliquei aqui, funcionando 100%. Legal? O que eu tenho que fazer aqui agora? O layout não é assim, né? Meu layout tem um carinha aqui no meio, meu layout fala qual é o então, vamos fazer esses detalhes extras para que ele apareça. Aqui eu posso fazer um efeito especial, que é o seguinte: Style, Opacity, eu posso meter aqui 0.5, por exemplo, de opacidade. E aí, ó, se eu jogar 0.5 em todo mundo, ó, vou jogar só no mundo aqui, por exemplo. Ó, ele fica meio escurinho, né? Meio escurinho. E aí o que eu faço? Eu vou botar esse cara escurinho, eu tenho qual é o item que está ativo. E como é que eu sei qual é o item que está ativo? Eu tenho aqui State Index. Ele fala para mim a ordem que eu quero usar. Então eu posso usar essa informação assim. State Index. Se for igual a 0, eu quero que a 0. Então eu classifico, caso contrário, ele fica 0.5. Ou seja, vai ficar quando a minha tela for a tela nativa. No caso, a tela home, que é a primeira tela aqui. Aqui. Dois, três, 4. Quando eu faço isso, olha só uma fica branca e as outras ficam escurinhas. Se eu passar por 6, as outras ficam escurinhas. Passar pra cá, esse fica branquinho e as outras escurinhas. Esse aqui, do mesmo jeito. E o outro, todos funcionando do mesmo jeito. Legal? Beleza. Passo 2, feito. Agora vamos fazer esse maiorzinho tab do meio aqui. Ele no caso não vai ser um tab item. Vou criar um outro item similar a ele, mas específico para o do meio, que vai ser maiorzinho. Const tab item, chamado tab item. E aqui o que nós vamos fazer? O 70. O conteúdo do meio, justify content. Center. Do mesmo jeito. Background color. Por ser uma bola, border radius. O tamanho da 35. Ah, no layout tem uma borda também.
的山就不肯往前的预感，我赞赏你的选择。
3 pixels
你是
só.
看着眼泪飘飘泪
O que eu vou fazer aqui agora? Eu vou pegar esse tab item center e eu vou jogar, eu vou substituir na verdade, né? Por esse aqui, do Atari Classic. Os outros vão ser tab item, mas esse vai ser tab item center. Salvei. Vamos ver. Reload. Border. Salve rápido.
的山就不肯往前的预感。
A bolinha. Só que essa bolinha tá um pouquinho mais rápida, né? Vai ter que subir um pouquinho mais. Como é que eu faço para subir menos 20 pixels. E aí o ícone tá branco. Eu tenho que fazer a troca. O ícone tem que ficar. Eu acho que o tamanho é diferente. 32 por 32, legal. 32.
的山就不肯往前的预感，我赞赏你的选择。
E, olha lá.
你是看着眼泪飘飘
Só que, claro, o do meio não tem esse troço da macete, então eu posso remover o do meio aqui. Vamos ver agora. Olha lá, legal. Funciona 100%. Então, ó, casinha, a lupa, o outro é um pouquinho maior, tá vendo? O coração, o botão do usuário. Então, ó, mandei pra cá, search. Cliquei aqui, favoritos, e funciona, tá? Cliquei aqui, favoritos, cliquei aqui, profile, e eu tenho um tab bar personalizado. Mas para ficar 100% personalizado, vou fazer o último item, que é o que eu falei para você. Eu falei que esse funcionário, se ele tivesse um avatar, a gente queria botar o avatar dele aqui, e não esse ícone. Se ele não tivesse um ícone, por algum motivo não aparecesse, não ia aparecer, mas para entender qual o usuário que tá. Então vamos lá. Para isso, precisamos pegar a informação do texto, certo? Então, em cima, vou puxar contexto, beleza? E aí vou puxar também logo aqui.
的山就不肯往前的预感，我赞赏你的选择。你是看着眼泪飘飘泪
o state que eu vou só transformar o nome dele para o nome dele e aí o que é que eu faço agora? E posse dessa informação eu posso vir para cá e ao invés de eu botar o account icon, né, eu vou fazer uma verificação, ou seja, se eu tiver esse cara, se ele tiver preenchido as palavras, o que eu faço? Eu boto um componente. Sócio. Com quem? E caso não tenha esse cara, aí sim eu ponho esse ícone aqui, jogar ele aqui. Show? Então, vamos só criar esse avatar icon aqui. Style, image normal. que é o tamanho do ícone normal, né? E eu vou só botar um border radius de 12, que é a metade do ícone, para ele ficar redondinho, certinho. Então, olha só, o ícone do usuário aparecendo aqui. E aí, claro, se ele não tiver ícone, por algum motivo, etc., aí vai aparecer o backup receber o account icon. Mas ó, e clicando nele, ó, vai para a tela profile do mesmo jeito. Legal? Todos os itens aqui perfeitamente certinho. Maravilha? Beleza, olha só. O que nós vamos fazer aqui agora? Então, criamos o nosso televisor perfeito, maravilhoso, funcional, 100% funcional. O que nós vamos fazer aqui agora? Vamos colocar a nossa boa e velha telinha tá? Abre o nosso e agora, ó, o que nós vamos fazer? A nossa tela home, ela basicamente é o seguinte: ela vai ter esse texto, esse conteúdo aqui, ela vai ter um pouquinho para pegar a música, e ela vai ter uma listagem dos meus itens, tá? Então, o que eu preciso fazer aqui agora? Vamos primeiro desenhar essa tela toda, e depois a gente insere as informações dentro dela. Então, olha só. Eu vou ter o meu container. Depois, a tela inteira, toda a minha tela, ela vai ser rolável. Então eu vou colocar um scroll aqui. Então eu vou chamar de scroller. E dentro desse cara a gente desenha a nossa tela, tá bem? E inclusive essa tela eu vou fazer aquele processo que você arrasta para baixo e ele atualiza a lista. Não sei se vocês são familiares com esse conceito. Esse conceito é o conceito de refresh control. A tela está aqui, você arrasta para baixo, ele vai meio que atualizar. Você usa muito no Instagram, isso, né? Você arrasta para baixo, você coloca o chave para baixo e ele atualiza o conteúdo. É isso que a gente vai fazer nessa tela também, tá? Um recursozinho. Então, ó, scroller. Dentro aqui do scroller vamos começar a área, assim, vai ficar só o botão da música. Isso vai ser um text mesmo, então seu barreiro como é um texto que eu quero que ele vou botar aqui um number of lines e logo ao lado o botão. Então e dentro o ícone é o íconezinho 26. O search icon não vai ser um componente, então eu posso até search icon é um ícone mesmo, criado de próprios componentes, tá bom? Logo depois, nós vamos ver a transação, que é um conceito similar ao que a gente fez do componente lá do sign up, do botãozinho, lembra? Então, só que ele aqui. Então, o que nós vamos fazer? O location, legenda do campo, e do lado do campo, do lado direito do campo, a gente tem o ícone, né? Então, location, input, e logo depois, ao lado, vamos ter o ícone, que na verdade não é só um ícone, é um botão chamado location, o ícone é my tá? Beleza. Campinho, área principal, tá acima, ok. Área de localização, ok também. Logo depois nós vamos ter a lista geral, né? Então vamos focar primeiro nesses caras aqui, tá? Scroller, depois header área, title, search agora vamos para location área, location input, location finder, que é o botão, e dentro nós temos o ícone observe. Beleza. Esses caras são os caras que nós precisamos criar por fora. Export. Scroller. Tá? Quem é esse cara? Área. Styled. Title. Styled text. E o search button. Search button. Styled. Depois, location, view, location input, styled text input, nesse caso aqui, depois spot location finder, que é um botão. Touchable opacity. Exportei todo mundo. Importei todo mundo. Usei todo mundo. Então vai aparecer a tela, só que não apareceu, só que não dá pra ver nada, né? Dá pra ver um íconezinho aqui. Dá pra ver depois. A tela em si. O background dela. Consegue visualizar um pouco. Show de bola. Agora o que nós vamos fazer? Vamos fazer agora essa área daqui, essa primeira área, né? O header seria a área funcionar certinho. E o scroller. Flex 1 para pegar a tela toda, né? E um padding para tirar tudo que está ao lado. Dá um padding, né? Em todo o conteúdo que está ao lado. Header área. Row, para que fique o texto, e ao lado do texto fique o ícone, justify space between, para ficar um item lá na esquerda e outro item lá na direita. Space between, espaço no meio, né, entre os dois. Depois, center, para ficar verticalmente alinhado certinho. O texto.
沙就不肯完全的预感。我赞成你的选择，你是看着眼泪飘飘泪在天天转转的走着，快乐。
o head tie.
你的笑就是一串的保护伞。
Tomando uma forminha. Vamos só diminuir na gravura desse head tie para que ele quebre o texto não fique colado aqui no meu caminho. Vamos fazer o seguinte: a largura de 250 vai ser o suficiente. Show de bola. Agora, search button, um botão especificamente eu já posso fazer ele a clicada, né, dele funcionar. Então, search button. Basicamente, quando a gente apertar esse botão, ele vai mandar a gente para a tela do search, né? Então a gente pode, se quiser, pode fazer até aqui mesmo, direto. Então vou ter só que pegar o Use Navigation aqui. Tá? E aí a gente pode fazer o seguinte, ó, clicou na lupa, navigation, ponto. Salvou. Cliquei, ó, veio pra search. Cliquei por baixo, eu posso clicar aqui na lupa por cima, também vai para a mesma tela. Então, tá aqui a área de cima criada. Vamos agora focar é basicamente a parte cinza, né? Então, background color, vou só pegar a cor. Beleza. 60 Corner Radius bem arredondado, Flex Direction Row para ficar no campo do lado esquerdo e alinhados, o campo padding left 20, deixa ficar colado do lado, padding right para o lado, margin top vai tomando forma aos pouquinhos. Legal? Show de bola. Vamos agora para o input, que é onde o cara digita alguma coisa, né? Então ele vai pegar todo esse espaço font size 16 branco. Automaticamente eu fiz o campo pegar essa área aqui e aí o ícone assume o seu lugar. Vai para o seu cantinho aqui. Legal? Então, no caso do ícone, que é o Location Finder, só a área disponível dele. Então, 24, área do ícone. Tá? Então, ó, tá aqui. Cliquei, ele vai abrir, ó, um campinho. Tá? Simples assim. Eu vou botar um placeholder nesse cara para que ele apareça placeholder next color, nosso campo, né? Ou seja, alguma coisa, a gente saber o que ele digitou, etc. Então, state desse localização, desse location. Set. Value, location, text. E on change text, quando eu quero mudar o texto, vou pegar ele, set, location, text. Onde você está? Vem pra cá. Isso vai acontecer no state que eu digitei. Se eu não tiver nada, ele aparece depois. Show de bola. Vamos fazer o seguinte agora. Vamos fazer o processo de pegar a localização. Ou seja, cliquei aqui nesse botão aqui, ele vai pegar a minha localização. Tá? Na verdade, ele vai pedir primeiro permissão, se tiver permissão, etc. Vamos fazer esse processo de pegar a localização, tudo bem? Que é esse ícone aqui, Location Finder. Press. Location Tá aqui a funçãozinha, tá? E aí o que vai acontecer? Quando o cara clicar no botãozinho do áudio, quando o cara clicar no áudio, nós vamos precisar fazer o processo de pegar as coordenadas. Só que esse processo ele envolve pedir permissão para o celular pedir permissão para o usuário dizer, ó, pode pegar minha localização. Então, na primeira vez, é isso que vai acontecer, tá? As próximas vezes, ele vai pedir, mas como já deu, então ele meio que pula esse bastante, tá? Então, o que é que nós vamos fazer? Vim pra cá, ele vai armazenar as coordenadas, as suas coordenadas do usuário. E aqui a gente já salva o conteúdo dessas coordenadas, tá? Vou salvar quando o cara clicar, a primeira coisa, zera qualquer tipo de coordenada, e depois ele vai fazer o processo de pegar a localização, tá bom? Então, o processo de pegar a localização, basicamente, como eu falei, consiste em pedir permissão e depois pegar a mesma localização. Para isso, a gente vai precisar usar aquela biblioteca que a gente puxou lá no começo. Vou pedir permissão, né? Request view permissions from React Native permissions. Esse aqui é o que faz pedir permissão, basicamente, tá? Pegar também, né? Geolocation da nossa biblioteca React. Esses dois carinhos que a gente vai precisar para pegar a localização, tá? Então vamos lá. Quando o cara clicar Location Finder, depois a gente vai fazer o processo de o resultado do processo de pedir permissão, tá? Await, botar assim aqui. Request, que é a função lá em cima, né? E aqui eu vou dizer qual é o tipo de permissão que eu quero pegar. Só que no iOS é um tipo de permissão e no Android é outro tipo de permissão. Então eu tenho que ver onde o aplicativo está rodando. beleza? Para isso,
不肯完全的预感，我赞赏你的选择。
que aí com ele eu sei. Aqui eu vou fazer platform.os. Se for iOS, o nome da permissão vai se chamar permissions.iOS.location use. Caso contrário, vai ser access find location. Tá parecido com o que a gente pedir a permissão, dependendo do sistema operacional que estiver rodando o aplicativo, ele vai e aí aguardamos o resultado e o que a gente faz? Result, ou seja, o resultado. Se ele for granted, significa que o cara deu acesso ao negócio aqui. Se ele não deu acesso, então vai pegar a localização, basicamente. Tudo bem? Então, se ele deu acesso, o que é que nós vamos fazer? Nós vamos basicamente agora pegar mesmo a posição do usuário. Já que a gente já tem acesso, podemos pegar. Então, geolocation. Quando ele pegar a posição do usuário, ele vai jogar em info e aqui vão vir várias informações. Eu vou até mostrar para vocês essas informações. Então, como só eu vou te mostrar na prática essas informações quais são, tá? Então, salvei e vai rodar na prática para a gente ver e agora. Pra cá. Deixa eu abrir aqui. Então, ó, vou apertar. Apertei. E aí a primeira vez que eu apertei, ele vai me pedir permissão. Como esse é padrão em inglês, a frase em inglês, mas se fosse em português, o Android tivesse em português, ele mostraria em português, tá? Permitir. Na mesma hora ele pegou, ó. E aí vem, ó, chords, que vem a taxa de accuracy, a altitude, a latitude, a longitude, a velocidade, no caso do parado, zero. Enfim, vem várias informações. O que é que me interessa? Latitude e longitude, somente. Basicamente isso. Tá? Então, o que eu vou fazer aqui agora? Peguei a localização. Vamos ver se eu peguei a localização certa. Chords, que são as coordenadas, né, que vem de legal? Então, peguei, salvei essas informações. Quando eu salvei, o que eu faço agora? Eu vou rodar uma funçãozinha chamada get backwards, que basicamente significa o quê? Pegar os barbeiros, né, da lista de barbeiros. É uma funçãozinha que a gente vai criar. Eu vou deixar ela pronta aqui, inclusive. Que é, pegou a localização, agora pega a galera, né, pega o barbeiro naquela localização, em outras palavras. Então, basicamente, é isso que a gente faz. E aí, o que eu vou fazer é você pegar a localização, vou ativar o loading, e aí, basicamente, pelo loading, vou mostrar um ícone de loading. Então, antes de pedir a missão, a gente já roda o loading. Então, set loading true, certo? A gente vai zerar o texto que tiver no campo aqui, que ele vai pegar uma nova localização. Então, zerar também, tá? E eu vou criar já um state aqui para a minha lista. Set list, use state. array vazio, tá? Então aqui agora, o que nós vamos fazer? Antes de pegar, né, certo? Pega a localização e pega a nova lista de barbeiros, em outras palavras. Tudo bem? Ó, salvei. Agora vocês fazem o loading funcionar para que ele apareça no íconezinho aqui. E a gente saiba que ele está carregando, tá? Aqui chamado Spot const loading styled font espaçar um pouquinho. Importei ele. Agora vamos vou só botar aqui o tamanho dele na verdade. Size. Então, ó. Ó lá. Já aparece aqui o meu arquivinho, meu só vou aparecer, eu vou mostrar ele se tiver carregando alguma coisa mesmo. Ele provavelmente não vai mais aparecer. Ó, não vai. Cliquei aqui. Aí, ó, ele faz o load, pegou a localização, ele já fez o procedimento e rodou a minha função principal dessa tela, que é a função getBarbers, que basicamente é a função que vai pegar a minha lista dos barbeiros, em outras palavras. Né? Então, o que a gente vai fazer agora com essa getBarbers? Vamos lá. Vou botar uma assim nela. Essa função é que vai pegar a minha lista para eu exibir aqui basicamente, tá? Então, precisa criar agora a API dela, e pegar os barbeiros, em outras palavras. Então, get barbers, e aqui nós vamos fazer o seguinte, essa função ela vai executar uma função, um get, então é mais simples do que esse aqui, né? Então, const barbers pegar um tokenzinho aqui, tá? Aqui certinho pra gente poder pegar o token. Todas as funções a partir de agora, uma vez que está colocado, eu tenho que mandar o token junto. Ou via parâmetro da carry string, ou no body, ou então no cabeçalho, tanto faz, ele vai aceitar os dois, tá? Tranquilamente. Então, ó, aqui, só um portal assim, storage, aqui. Para eu poder pegar o token, certo? Então, const peguei ele, joguei a minha requisição, fiz a minha requisição. Agora eu vou pegar o resultado. JSON, JSON e o retorno esse resultado. Tudo bem? Esse cara, ele vai basicamente pegar a minha lista dos barbeiros. Só que aqui não está baseado em localização, está baseado em nada. Porque eu não mandei parâmetros nem nada ainda, né? Então, vamos primeiro só pegar a lista. Get backwards aqui. Eu vou fazer Forte API from esse cara aqui, que na verdade a gente faz essa função também. Quando abrir a tela, né, tem que aparecer alguma coisa aqui. Então, basicamente, o que é que nós vamos fazer? Set load true, ou seja, inicia o carregamento, set list, vaza a lista completa dos barbers do pegar o resultado barbers, e a gente verifica se vai pegar o resultado se tem algum erro, né, por algum motivo, sei lá, erro. Se não tem nenhum erro, tudo bem, quer dizer que deu tudo certo. Se deu algum erro, e aí quando termina o processo, tá? Se deu tudo certo, o que é que nós vamos fazer? Nós vamos primeiro set list para pegar essa data que tem a nossa lista, efetivamente, tá? Pega a nossa lista e ele vai vir mais uma informação. Eu vou até fazer o seguinte, ó. Vou dar um console.login as para eu mostrar para você tudo que vem, tá? Eu vou aproveitar e já mandar os Get Barbers quando a gente abrir a tela. Effect. Já vou jogar um Use Effect aqui. Quando abrir a telinha, o que é que você vai fazer? Você vai basicamente rodar Get. Você vai pegar a lista dos barbeiros. A lista dos barbeiros. Pegou o preload e provavelmente aqui, ó, já pegou aqui a minha lista. O que é que tem nessa lista? Vamos lá, vamos ver o que é que tem. Primeiro, eu tenho data, ok. Eu tenho o erro, né? Eu tenho um lock que vem em São Paulo por padrão. Por quê? Eu não especifiquei nenhuma localização. Então ele tem barbeiros cadastrados, os barbeiros que eu cadastrei no sistema, eles estão cadastrados em São Paulo, beleza? Então, dependendo da localização que você mandar, ele vai filtrar em São Paulo para que apareça. Depois eu posso liberar no web service essa mas aqui no você vai mudar a localização e ele vai funcionar normalzinho. Só que como só tem barbeiros em São Paulo cadastrados, então ele vai para São Paulo. Tudo bem? Então, ó, data. E aí aqui em data eu tenho cada um dos avatares, e cada um deles vai ter o avatar, a imagenzinha dele, o ID, o nome e a quantidade de estrelas. Que é justamente, ó, as informações que eu preciso para exibir aqui. Tá? O avatar, o nome e a quantidade de estrelas. E o ID, claro, para eu poder saber quem é o cara. Show. Então, tenho as informações, botei na minha lista. O que eu tenho que fazer aqui agora? Eu vou atualizar, já que ele o lock, o que eu faço? Set location text lock. E aí quando ele atualizar a tela, ele automaticamente pegou a lista, ele não está exibindo porque eu não botei para exibir ainda, né? mas ele já pegou a lista, já salvou para exibir a lista aqui em São Paulo. Legal? Então, ó, botou a lista, agora vamos fazer o processo de exibição dessa lista. Logo abaixo vamos fazer um list área, ou seja, a lista. Em outras palavras, e list com map aqui para exibir. Aqui eu pego o item, então cá seria aqui, tá? E aí, observação importantíssima. Segundo o meu layout, essa tela, a exibição dos itens, eu tenho aqui também, ó, na busca, a exibição do mesmo item, eu tenho aqui novamente a exibição do mesmo item, em outras palavras, esse cara vai ser componente, né? Então, vamos criar um componente, vamos chamar aqui de Barber Item. E aí eu passo aqui o key, e o data, os meus dados, basicamente. Tudo bem? Então, deixa eu só criar aqui uma list área e nós vamos agora para criar o componente. Então, list área para cá. Salvar que ela vai ter um top para se afastar do campo do lado de cima e o método para se afastar de baixo. Basicamente isso. Vem para cá, ele provavelmente vai dar erro porque eu não criei um Barber Item. Vamos criar esse componente. Barber Item. Vamos importar ele para cima para poder utilizar, né? Voltei mais ele vai jogar aqui na minha lista. Agora eu preciso criar, né, o componente Barber Item para ele ter alguma coisa para exibir efetivamente, né? Então, e aí só para dar erro quando criar esse componente no começo. Style components componente, né? E aí eu já vou receber data, eu passei data, recebe ele aqui mesmo, e aqui a gente começa a brincadeira. Então, ó, que é um botão, basicamente, para clicar em toda a área disponível do item, eu posso clicar. Depois, ele vai ter, segundo o meu layout aqui, uma avatar, depois uma área para essas três informações aqui. Então, aqui eu vou ter avatar, posso botar já uma imagem também, então, vai data.avatar, certinho aqui. Depois, info área, das informações, aqui eu vou ter um componente de sistema eu uso aqui no depoimento, enfim, eu uso essa estrelinha em vários locais. Então eu vou criar um componente para ela também, tá? Então não vou botar por aqui. E o botãozinho que é o ver perfil, legal? E vamos criar essa galerinha aqui agora. Então, tipo, o capacete. Pronto. Avatar, que é a imagem. username e é o text. Depois eu tenho, não é nem um botão, na verdade, é um view normal. É um view normal, porque o botão já é a área inteira, então não precisa se preocupar. Que é o certo? Então, vamos lá. Salvar aqui, todo sem ser formatado. Ó, já está aparecendo, tá vendo? Dados. Vamos lá aqui. Nada formatado, né? Vamos lá. Vamos começar em área, que é a área total, né? Back, ground, bottom para empurrar o de baixo. Border radius para ficar arredondado. Padding 15 pixels. Row, um item ao lado do outro, né? Row no avatar. Normal, então se eu vou botar aqui, deixa eu ver aqui qual o tamanho. 88 por 88. E vou deixar show de bola. Info área. Da foto 20 pixels e Shields Mobile Space. Vou botar no Space aqui. Que aí ele vai fazer o seguinte, ó. Esse texto que vai aqui em cima, o botão vai lá para baixo e ele vai se espalhar, né, na vertical. Com a área username. Aqui é só o tamanho. Size. Sem profile. Aqui é o botãozinho, né? Esse botãozinho aqui que é só uma borda, basicamente, né? Vou botar aqui 85 ou 26. Border 1 pixel solid aqui, foi mal. Border radius 10. Isso aqui just fine. Line itens 100. E aí fica o conteúdo no meio. Legal? O texto, um textinho basicão. Então, font size 13. A galera já aparecendo aqui, ó. Os barbeiros aqui já aparecendo. Legal? Então, maravilha. Ó, estão aparecendo só as estrelas, né? Eu falei pra vocês que ia fazer o componente, né? Então, já que esse cara já está certinho, pronto, já está pronto, vamos fazer agora o componente das estrelas. Tudo bem? Ó, eu vou chamar ele aqui de Star. Ou Star. Legal. Então, vamos chamar ele de Star. Duas informações, que é a nota já tenho, beleza, passo ela, vou passar também porque, ó, segundo o layout, aqui, ó, eu mostro a notinha, 4.7, mas aqui, por exemplo, ó, no depoimento, eu não mostro, eu simplesmente mostro as estrelinhas, então eu vou fazer com que eu possa tirar ou não a notinha, tá bem? Então ele mostra ou não a nota, dependendo daí de como é que a gente vai querer exibir, tá? Stars, né? Que é a notinha que eu tenho, tá? E legal? Show number 2. E aí eu preciso agora criar esse criar aqui stars.js e agora eu vou focar em criar esse componente específico aqui. Style também. Feito isso, vamos fazer o seguinte aqui agora. Sporting return. E aí eu vou fazer está na área das estrelas. E aí eu ponho as estrelas aqui, que vai fazer um mapzinho aqui, etc. Vai ficar bem legal. E depois eu vão ser dois itens dentro desse está área. Então, vou criar logo ele. Está área. E aqui vamos receber as minhas duas props, stars e show. Legal? Então, o que a gente vai fazer aqui agora? Olha só. Para exibir essas notas, basicamente, essas estrelas, né, basicamente, o que eu vou precisar? Primeiro, eu vou precisar de uma estrela, um ícone de estrela vazia, um ícone de estrela cheia e um ícone de estrela aumentada. Então, vou pegar essas três estrelas que eu tenho. Então, assets barra star.svg star assets barra star.svg e star empty assets barra então são os três basicamente, tá? As três precisar. Agora, olha só que legal, para a gente exibir essas estrelas, eu vou fazer o seguinte, eu vou criar um array. Nesse array vamos ter as 5 estrelas. E aí eu vou fazer o seguinte: 0 é o valor para a estrela vazia, 1 é o valor para meia e 2 é o valor para cheia. 2, 3, 4, 5. Então, se eu botar assim todo mundo com 0, o que é que vai acontecer? Basicamente, eu vou ter aqui nota 0. Aqui nota 1, nota 1 não. Nota 2, 3,5, 2,5. Legal? O que é que nós vamos fazer aqui agora? Baseado nessa informação, tá? A gente vai vir pra cá. E deixa eu pegar aqui na área. A gente explicar cada uma das coisas. Criar um view e dentro desse view eu vou ter que botar a estrelinha, na verdade. Start view. Quando i for 0, eu vou rodar e preencher, tá? Agora eu vou botar mais quando a estrelinha para fora do loop, né? Vai ser start. E 2 vai ser start full. Tudo bem? Então, show de bola. O que é que eu vou fazer agora? Deixa eu só criar também, tá? Não vai ter nada. Salvei. Vamos ver se agora ele já está aparecendo. Já vai aparecer certinho. Todo mundo nota 0. Legal? Então, todo mundo está com nota 0 porque eu vou botei a nota ainda, né? Então, todo mundo está aparecendo somente Start End todas as vezes, né? Todas as 5 vezes a Start End. Tudo bem? Então, o que é que eu vou fazer agora? Nós vamos basicamente pegar. Deixa eu só botar também. E aí eu ponho status, que é a Ah, tá. Eu fiz dentro do esse aqui é 2.8, 2.7.4.7, isso aqui, show de bola. Então, ó, já está mostrando a nota. Agora o que é que nós temos que fazer? Temos que fazer a lógica para ele transformar esse estado que é uma nota e botar aqui dentro desse arquivo, dos carinhas os respectivos, né? Certinho. Então, olha só o que a gente vai fazer. Primeiro, vamos pegar o inteiro, né? Por exemplo, 4.7, eu quero agora só o 4. Tá? Então, o que eu vou fazer? vou pegar o floor. Being stars. Vai ter que retornar somente os inteiros, certo? E aí o que eu faço agora? Eu vou dar um loop for. Eu vou usar var, é utilizar depois for, tá? Zero.
它就不可能完全的预感。
O floor deu 3. O que eu vou fazer agora? Eu vou rolar 3 itens aqui e você vai virar o quê? 2. Então, isso aqui vai resolver o problema inteiro. Eu salvei. Olha só. Por exemplo, se eu levo for 0, quer dizer que eu soltou alguma coisa. Ou seja, a nota não foi inteira, foi meio quebrada. E aí o que eu faço? É assim. E eu vou aproveitar o i daqui, ou seja, o próximo item logo depois dos inteiros, tá? Vai ser simples, fácil e rápido. Vamos lá, 3 inteiras e uma na metade. 4, 7, 4 inteiras e uma na metade. 4.8, lembra? 2.8, 2, uma na metade. Legal? Então, agora sim, ó, as notas estão aparecendo certinho. Dessa galera aqui estão aparecendo certinho. Vocês devem ter percebido também que eles estão aparecendo de forma aleatória. Né? Então, a ordenação deles eu botei de forma aleatória. Então, cada vez que você atualizar, ele vai aparecer valores diferentes. Tudo bem? Agora, vamos fazer o seguinte. Vamos fazer o nosso refresh control. Ou seja, vamos fazer a possibilidade de eu vir para cá, puxar para baixo e ele recarregar os meus itens. Tá? Vamos lá. Olha só. Para fazer eu vou fazer o seguinte. E o index aqui. Olha só. Como é que você faz para você fazer o refresh control? Você vai botar no scroll view, ou seja, no scroll. Então, eu vou precisar, eu vou lá em cima, eu vou precisar de importar o refresh control do próprio React, tá? Então, ó, feito isso, eu vou voltar para cá, meu scroller, tá? E aí eu vou fazer esse botar um próprio chamado refresh control, que na verdade eu uso o componente, eu boto o componente refresh control e ele recebe, ele tem na verdade duas props. A primeira, refreshing, que é true e false. Então eu vou botar aqui o state, eu posso dizer se está ou não aparecendo o loadingzinho. Eu vou mostrar na prática para você entender, tá? Chamado refreshing. E depois refresh. Em outras palavras, quando você quer o refresh, você está puxando. Tá puxando, aí o refresh fica true. Quando você termina de puxar e solta, aí ele roda o on refresh. Tudo bem? Vou criar aqui um on refresh. Vou criar essas duas carinhas aqui. O primeiro em cima, refresh e o set. State false. Legal? E agora vamos vir para aqui criar o on refresh. Com o on refresh. Que aí vai fazer o seguinte. Olha só. Não vai botar nada aqui no on refresh. Salvei. Vamos vir para cá. Tá aqui, beleza. Só o ato de eu ter botado esse refresh control vai fazer com que isso aqui aconteça. Ó, vou puxar. Comecei a puxar. Olha só o que está aparecendo ali em cima. Ó. Puxei. Aqui ele chegou na área que se eu puxar ele vai, entre aspas, ativar. Tá? Então, ó, soltei e ele some. Ó, puxei, soltei e ele some. Puxei, soltei e ele some. Legal? E aí eu posso vir pra cá e eu posso fazer o que eu quiser nesse cara aqui. Tudo bem? Por exemplo, se eu der um set refresh true aqui dentro, olha só o que vai acontecer. Vai aparecer aqui, beleza. Aí ó, puxei, soltei. Se manteve. Por que se manteve? Porque ele pegou o refresh e eu disse, bota o outro vai aparecer aí. E aí ele mandou aparecer. Tá? No caso, eu não quero que esse cara faça. E aí o que eu faço? Get barbers. Ou seja, eu rodo o código e pego o puxa novamente. Então, ó, salvei. Pra cá. Tá aparecendo? Aparecendo. Vamos agora. Puxei, soltei. Soltei de novo. Apareceu. Puxei, soltei. Carregando. Apareceu. Legal? Então, ó, só puxar, recarrega a lista e aparece. Beleza? Ui, velho, então, olha só. Acabamos de fazer agora a telinha do home. Beleza? O que é que nós vamos fazer aqui agora? Vamos fazer essa tela está pronta. Ah, não, está pronta não. Falta a gente mudar a então, ó. Pegou e aí dá o get barbers. Esse get barbers é o seguinte, ó. No get barbers nós vamos fazer uma pequena verificação, que é o seguinte. Vou criar aqui um lat nu. Tá? Esses caras nós vamos passar com o parâmetro do API. Tá? Então, lat longitude. A gente passa aqui no get barbers. Para isso eu vou pra cá e criar o parâmetro e tornar ele opcional, né? Então, tá? E também não precisa passar ele na definição. Passo o lat, LNG, passo o LNG. Tudo bem? São parâmetros reais que você pode passar para essa posição. Tudo bem? Salvei, deixo o parâmetro opcional e aqui eu estou passando ele. Só que eu estou passando ele nulo, claro. Agora o que é que nós vamos fazer? Vamos verificar se existe performance. Ou seja, se o cara passou algum dado. Legal? Então, se eu quero algum dado salvo em box, o que vai fazer? Latitude e longitude. O que é que isso vai fazer? O que acontece? Salvar e eu vou te mostrar na prática o que vai acontecer. Olha só. Vou vir aqui na API, vou fazer o seguinte. Salvar. Lat, LNG, tá? Para ele exibir aqui as informações, tá? Salvei. É possível a classificação baseada na classificação do usuário. É exatamente como está. Uma nota. Essa nota aqui é uma média que está vindo do próprio WebService baseado nas notas que esse cara recebeu, uma média. Beleza? Então, quando você fizer a sua votação desse cara, você faz em outra ferramenta, ele vai influenciar essa média. Ele vai mudar a média. Tá? Não sei se foi essa pergunta, mas é basicamente isso. É a informação real. Aqui no banco mesmo, é a média calculada do cara. Então, continuando aqui. Sempre que a gente chamar o get barbers, quer seja algum que a gente enviou. E aqui, sempre que a gente tiver essa informação. Em outras palavras, console de resposta. Console de resposta. Então, ó, vamos ver. Vou atualizar aqui agora. Ó, carregou aqui e carregou com lat null e com null, certo? Olha só o que é que eu vou fazer agora. Eu vou atualizar. Vou clicar aqui para ele atualizar minha localização, certo? Então, ó, clicou, ele carregou. E se eu puxar novamente, ele vai recarregar, mas ele vai mandar, ó, o lat e o nome está salvo. Beleza? Então, uma vez que eu peguei a localização, ele fica com ela salva e ele manda ela junto com todas as requisições. Por isso que eu botei isso aqui. Qualquer hora que ele chamar o Get Barbers, se tiver localização, ele preenche. Se não, ele se não mandar, funciona. Se mandar, ele funciona também do mesmo jeito. Legal? Beleza. Vamos fazer só a última coisa aqui para que essa tela fique funcional, fique 100% funcional, que é fazer eu digitar alguma cidade aqui e mandar essa informação também para o alicerce. O que é que eu vou fazer aqui agora? Vou no cara aqui, ó, location input, tá? Nesse cara, o que eu vou fazer? Eu vou botar aqui mais um carinha, que é um editor. Que é quando o cara dá um enter, basicamente, ele dá um enter. Então, handle location search. Basicamente, quando a gente digitar alguma coisa no campinho lá, ele vai zerar as coordenadas, então set coords. E depois o que ele vai fazer? Get Barbers. E aí, dentro do Get Barbers, vamos fazer com que ele também pegue a cidade que eu estou digitando aqui. Salvei. E aqui no Get Barbers, vamos botar um terceiro parâmetro aqui. Essa eu já tenho, né? Location. Next. Sempre vai pegar o que está digitado e vai mandar também para o alicerce. Então, ó, salvei, location text, vamos só criar esse parâmetro aqui agora. Então, city, address, Aí você deve estar pensando, tá, tudo bem. Vou botar no console aqui. Aí você deve estar pensando, tá, beleza. Pode ocorrer dele mandar, por exemplo, deixa eu atualizar aqui. Deixa eu atualizar o aplicativo, que eu vou simular uma situação com você. Carregou, beleza. Olha só. Lat, longe, nu e address. Sem nada, basicamente. Ok, tudo bem. Eu vou vir aqui e eu vou digitar. Google aqui o meu. Já aconteceu uma vez comigo. Mas tudo bem. O fato é, usar essa funçãozinha aqui. Certo? Essa funçãozinha ela vai zerar as coordenadas e ela vai rodar uma nova pesquisa. Essa nova pesquisa vai mandar o que eu digitei também, nosso location search. Então, o website ele faz o seguinte: quando você manda coordenadas, ele prioriza as coordenadas. Quando você não manda coordenadas e você digita alguma coisa que você digitou de localização, né? E vai usar o Google para pegar as coordenadas baseadas no nome do seu digitou, tipo Rio de Janeiro. Aí ele pega as coordenadas do Rio de Janeiro que você digitou. Se você não mandou coordenadas, claro. Tá bem? Então, basicamente, é assim que funciona e ele está pegando a localização tranquilinho. Beleza? Então, ó, terminamos essa tela aqui. Se o teclado não está funcionando o teclado aqui. Olha só, terminamos essa aqui e eu queria fazer o seguinte: nós ainda temos essa tela, que é a tela do próprio barbeiro, né? A tela, o modal da finalização aqui do agendamento, etc. Tá? Só que eu não quero que essa live fique gigantesca demais. Já dá com live aqui. Então, vamos fazer o seguinte: vamos marcar uma outra live para essa semana ainda. A gente pode marcar essa semana ainda, tá? Para a gente continuar de onde a gente está parando aqui agora. Ou seja, paramos, né, concluímos, né, toda a tela inicial e vamos agora fazer na próxima live essa tela aqui, tá? A tela do barbeiro e a do modal, enfim, o restante. Tudo bem? Vocês podem? Tudo bem com vocês? Porque a gente quase 4 horas. Então, beleza. A gente faz, vocês continuam com 350 pessoas. E a gente continua a partir dessa tela aqui. Tudo bem? E aí, amanhã, quando a gente parar aqui essa transmissão, amanhã eu vou pegar os arquivos que a gente tem agora e eu vou disponibilizar para vocês. Tudo bem? Pode agora, etc. Eu disponibilizo para vocês. E aí na próxima live a gente continua. Tudo bem? Show! Beleza, então. Então, uma ótima noite para 6 horas da noite até 10 horas da noite, quase basicamente, né? Tomar água bonita. Eu vou tomar água. Então, muito obrigado por vocês que ficaram e nós queremos fazer uma maravilha. Demorou mais porque eu fui explicando, né, detalhes, etc. Então, espero que tenha sido didático para vocês. Legal? Maravilha, pessoal. Uma ótima noite para vocês. A gente se vê essa semana ainda. Eu explico, eu falo para vocês, tá? Fala na sua plataforma do post. Sim, se você quiser. Se você quiser. Centenas de aulas. Você pode acessar b7web.com.br/fullstack ou então você digita quero ser fullstack. Você vai dar na mesma página, beleza? Aqui você pode conhecer, aqui eu explico tudo como é que funciona o nosso curso, você pode se inscrever, todas as tecnologias que você vai aprender, não só de mobile, mas também de back-end também, tudo que você vai aprender, tá? Tem aqui, mas aqui embaixo, ó, tem mostrando a nossa plataforma por dentro, como é que funciona as aulas, eu vou mostrando cada um dos cursos que tem, tá? Então, é uma página bem completona que vai te mostrar, vai explicar tudo certinho como é que funciona o nosso curso e você pode se inscrever nele, tudo bem? Então, maravilha, hoje é segunda-feira, vamos fazer o seguinte, já vamos deixar certinho para todo mundo que está aqui no live. Na quinta-feira, legal? Quinta-feira nós vamos fazer o projeto de continuação, a live, né, de continuação dessa live aqui, tudo bem? E a gente continua a partir da outra dessa tela do barbeiro, tá? Vou deixar o projetinho jeito que tá aqui agora, pra gente continuar no próximo live. Quinta-feira, tá? Mesmo horário, 6 horas, mesmo horário, tudo certinho, tá? Maravilha, então, galera. Uma ótima noite pra vocês.
山中不肯往前的余额，我赞同你的选择，你是看着眼泪飘飘泪两天也双双的走着，快乐，你的笑就是一床的保护色。决定不爱了，你决定不爱了，让那几个是真的我的，你的山中不肯往前的余额，我赞同你的选择。你是看着眼泪飘飘泪两天也双双的走着，快乐，你的笑就是一床的保护色，你决定不爱了，你决定不爱了，让那几个是真的我的，你的山中不肯往前的余额，我赞同你的选择，你是看着眼泪飘飘泪两天也双双的走着，快乐。你的笑就是一床的保护色，你决定不爱了，你决定不爱了，让那几个是真的我的，你的山中不肯往前的余额。我赞同你的选择，你是看着眼泪飘飘泪两天也双双的走着，快乐，你的笑就是一床的保护色，你决定不爱了，你决定不爱了。让那几个是真的我的，你的山中不肯往前的余额，我赞同你的选择，你是看着眼泪飘飘泪两天也双双的走着，快乐。你的笑就是一床的保护色，你决定不爱了，你决定不爱了，让那几个是真的我的，你的山中不肯往前的余额。我赞同你的选择，你是看着眼泪飘飘泪两天也双双的走着， 就不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一场的保护伞，你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤就不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一场的保护伞，你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤就不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一场的保护伞，你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤就不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一场的保护伞，你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤就不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一场的保护伞，你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤就不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一场的保护伞，你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤就不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着， 从不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护色，你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤从不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护色，你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤从不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护色，你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤从不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护色，你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤从不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的走着，快乐，你的笑就是一床的保护色，你决定不爱了，你决定不爱了，让那几个是真的我的，你的伤从不肯往前的余额，我赞赏你的选择，你是看着眼泪飘飘泪的跌跌撞撞的
There's something really fascinating about how sport transcends all cultures, languages, history. Over the years, I've been down every sport in my life. I think as sport leaders, ourselves have to be inspired by how we feel across all sports.
I've represented the British diving team since 2015, competing at European and World Rugby. This is really where fine margins make all the difference, which is why I started using Push.
Push is an advanced strength part of our mission is to optimize athletic training. Ensure that when athletes walk into the gym, they're actually
Push gives me rep by rep feedback in real time, so my
we will constantly get requests. And one of our challenges is that we are small. We knew that trying to support people with Flutter, we are able to save roughly a day a week just syncing up 2 different code bases. It's really enabled us to push out a lot more features. We believe that Bluetooth connection is going to be robust and reliable. And the data transfer that we do, just how performant Flutter was. We really wanted to make sure that our technology can scale at various levels. And that's something that I'm really proud of.
Push gives me motivation to see how far I can go and what I can achieve. That ultimately means the Olympics.
We're so glad to have you join us virtually wherever you are. It's been a tough year, so we're thrilled to share some good news as we share some announce some new things from Our theme for this year's event is to highlight the flexibility and portability of Flutter as a complete UI toolkit for building beautiful apps for any platform. And today is a key milestone for Flutter with the launch of Flutter 2, a major upgrade to Flutter that builds on the momentum and foundation of previous releases and opens up a broad range of new target platforms. Over the next hour, you're going to hear us talk about Flutter on Android and iOS, as well as desktop. You're going to hear from companies like Microsoft, Canonical, and Toyota. You're going to learn more about how our work on Dart provides a unique productive, robust combination of capabilities for building apps. Flutter is the first UI component designed for an ambient computing world. And this vision is unique to Flutter, a portable toolkit for building beautiful, native, fast experiences wherever you might want to build apps. Our goal is to shift you from having to start with the platform and focus instead on what you want to create. Some UI toolkits impose tight constraints that really creative expression to what fits within the toolkit. But Flutter allows you to handcraft beautiful experiences where you can design Flutter is fast, it compiles your source to machine code, but thanks to features like stateful hot reload, you still get the productivity of interpreted environments. You can make changes while your app is running and see the results immediately. And of course, Flutter is open, with thousands of contributors adding to the full framework and extending it with an ecosystem of packages. So the big news in Flutter 2 is that we broadened Flutter from a mobile framework up to a portable framework, unleashing your apps to run on a wide variety of different platforms with little change. As of right now, there are already over 150 Flutter apps out. Now that number is doubled just since the start of this year. These apps come from big teams and big companies, as well as entrepreneurs and startups who simply want to share their idea with the world. We thought we'd show you some of our favourites.
Send them down. 山中不肯往前的鱼儿，我赞赏你的选择，你是看着眼泪飘飘泪两天也装成的愁色，快乐，你的笑就是一双的保护色。
So let's talk about what's in Flutter 2. You could think of Flutter 2 as we've shipped about 10 updates to Flutter since our original launch, but in this release we add support for something worthy of a major version upgrade, a major increase in the number of users. If you've built a Flutter app so far, you've probably been thinking primarily about iOS app. But with Flutter 2, your app can target 4 additional platforms: Windows, macOS, Linux, and the web. And when you add iOS and Android to that list, you can see how uniquely flexible Flutter is. Native support for 6 different platforms, and the ability to tailor the experience to each platform without compromising performance. Flutter is perfect to both integration and high-quality results. So, to demonstrate Flutter's versatility in action, we asked our friends at G-Skinner to create a demo that spans all these patterns. Let's show you.
Hi everyone. Here at G-Skinner, we've created a variety of patterns, how to embed multiple patterns. For this project, we wanted to go beyond that. Build something that purposefully considers norms, user expectations, input devices, and idioms on each platform. Create an app that truly felt personal. We also wanted to leverage the unique strengths of each platform. After some brainstorming, we decided to release Let's take a closer look at how the app works. All devices follow us everywhere. Given that, we focus the small screen and let's say you want to go to the tin and grab the car. You could use the mobile-friendly UI to quickly navigate the existing scrapbook and reminisce about shared experiences. Or navigate to the preference page and snap a few pictures of Carl to add in later. Of course, larger screens provide a lot more space and improved precision, which makes them ideal for creative, like editing scrapbooks. When you get back from your walk, you're super excited to add in new photos of Carl. You fire up the app, maximize it, and create a picture of the Use your scroll wheel or arrow keys to navigate to a scrapbook. While editing, you can use desktop-specific images, native menus, keyboard shortcuts, context menus, and scroll wheel zoom. But of course, not all large screens are the same. If you're working on a touch device, the UI adapts in a variety of ways, such as providing larger hit areas and exposing functionality through textual buttons and some other menus. Last but not least, we wanted to target the web. These days, browsers are capable of almost everything, so the full app runs there as well. But the web is unique. We leverage that screen to let you share For example, sharing an amazing new page with Tim and Carl. This URL is actually live right now if you want to check out Carl. to invite you to visit flutter.skinner.org, where you'll find more info, source code, and links to the app. We also learned a ton of great things, and we're excited to share that knowledge via Twitter. Ultimately, we're able to build now arms-break live OSs and the web while reusing over 95% of our code. We built Flutterfolio with best practices. You can check out the source code and start making your apps. Source code is available at flutter.gskinner.org. And for more on great design practices with Flutter, check out the several tools check that we're posting live today. Of course, there are hundreds of other new features in Flutter too. We continue to make progress on foundational areas that you and your customers care about, improving performance and stability, supporting the latest UI trends and widgets, and increasing accessibility. We've completed our work on new state restoration, which supports running on Apple Silicon. We've added multi-line text editing and keyboard shortcuts. We've added interactive safe water app framework, and we've closed nearly 6,000 issues. The full list of pull requests is merged into a 200-page document to give you a sense of the size of the Flutter isn't just being used outside Google. Over 1,000 engineers inside the company are using Dart and Flutter to develop apps today, representing over 30 different teams. And the apps you see on this list here are already shipping using Flutter. One of the largest apps for Google using Flutter is Google Maps. And Timothy Jordan recently sat down with Neil Schroeder, who's the Vice President of Engineering at Google, to ask him about their experiences with Flutter. Let's hear what they had to say.
Have you used
You might have heard of Google Pay, but let me first tell you the scale of the problem. You're trying to launch in 30 countries on the platforms and 20 islands, and so now, as a result, right, iOS and Android might. We also had feature disparity, the feature being implemented also tech that was building up, and we needed more and more engineers to keep up on development. So we started looking at options, and after weighing the rewrite migration, we decided the good thing was we ended up with 1.1 million lines compared to 1.7 million. And at the same time, our tech debt went down by 90% on a per engineer basis. Now, once the rewrite was done, we also had to we were also able to merge all the duplicate responses, experimentation, the launch process, everything, because now everything was done. Plus, the best part was with every engineer working in the same code base, we were able to take the iOS because it was all now, if I had to go back, I would absolutely Thanks for joining us today.
So one of the most interesting things about mobile development is that phones come in so many different shapes and sizes. And one of the latest trends is fold cameras. One great example of this form factor is the Surface Duo from Microsoft, which combines the best of Android with the Surface team's average abilities. And we're happy to announce that Microsoft has been contributing code to Flutter over the recent months. It's Silas Milner, his guide, who leads Surface development experience.
device form factors you when you're on the device, that's for you. When you're creating content, playing a game, watching a video, just reading a browser. For us, the mobile developers, it means new scenarios, user experience to explore in our apps. First, you have to know how to speed and not just one. You have more to do in real estate, content,
Thinking about two-screen mode, you can also utilize various dual-screen design patterns, such as the use of foldable soft factor also provides you to share content with another entity. For example, by adding joint to your want developers to take advantage of foldable and dual-screen devices regardless of the platform or app that they're building on. Today, we're happy to announce that the collaboration will bring foldable support to Flutter. When contributing code to let Flutter apps to take advantage of the devices like the Surface Duo, but also enable it on other devices like fully manufactured by Samsung. Let's see a demo. The best way to demo anything Flutter is by using the Flutter Gallery app that we are offering. This is the Flutter Duo, which you can download today. Let's run the Flutter Gallery app. The app is started on a single screen. As you can see, the app we are aiming at and positions the assets across both screens. This is typically the first step that you will take. Start thinking today of a new layout that you may want to show now that you have to screen. Flutter is all about widgets, so let's see those in action. We've added foldable support for the existing Flutter widgets. For example, when you use a dialog, you can update Ninjaware and you will display a pop-up to your page on the right or left of the page. Also modify other modal routes, pop-up menus, and other widgets. Let's move on. We've added a new widget to position assets to two screens. We call it a two-pane widget. You can use to place assets on the right or on the left. Also, you can two-pane widgets makes it easy to support all these new form factors. But enough with demos. Let's get into some code. We've added display features to make it clear. You can use it to query the type of displays you have and the position of the image. Using the two-pane widget, add your own widget to the content to either the left or right. Let's summarize what's there. Foldable and dual-screen devices are ready for you to try them. You can use a dual-screen device or a dual-screen foldable device. We want to make developers with their hands. We're super excited to share this news with you. All samples and lectures are open source and support. We're excited to see what you bring with them in your app. Thank you.
So let's talk about portability. Last year, we gave you an early preview of WebSpot. So today, we're delighted to announce that Flutter's support for the web platform is in a stable milestone. This is a huge leap forward for Flutter, building on the portability of Java's powerful web platform and the flexibility of the Flutter framework to deliver the same experiences on the web as on mobile. And it's exactly the same Flutter framework. All of different editions. The web is just another device target for your app. So, that Flutter is particularly suited for app-centric experiences. Things like progressive web apps that integrate with the user's environment, including installation, offline support, and tailored user experiences, single-page apps that deliver a client-driven experience, and existing Flutter mobile apps that provide fast path to the browser. So I thought it'd be fun to chat with Dean Ahmed, who is responsible for the web capabilities at Flutter, including, of course, the Chrome browser, and get his take on how Flutter fits into the web platform. Thank you for joining me today.
Thanks so much for inviting me to share my excitement. We think the web is incredibly important. It was born as a content platform and enables richer capabilities for publishers with M. But we've seen this open platform evolve into a great deal of use cases such as forums, apps, and even tenants allow them to their web frameworks and approaches to delivery for the developer of choice. And there's plenty of room for Flutter to grow. The web has many strengths, including ubiquity and reach. So if you're building a Flutter app, you now get to reach users outside the power of URLs users across operating systems and device clients directly to any part of your app. This is
engagement because many users will simply not pause to do so. And now I'm going to go straight to that action PWAs like these are now possible due to the web pushing on two areas. First, platform users. These enable fast performant rendering, and we know this is really important for the community. Second, soft trusted manner. And with the other, the web platform will be incorporated by the Flutter engine. So you get improvements for free. But we've seen this at work. As Flutter's web support has transitioned from tech preview to now production. The Flutter team were able to try different rendering approaches, starting with the and then canvas taking a bunch of new APIs to help with ergonomics and speed up performance. This is where WebAssembly and WebGL open the door for massive optimization. We're collaborating in many accessibility. So hopefully you and the Flutter team collectively keep pushing us forward to enable the next generation of experiences. Because we're really big on with the Flutter and Chrome team working all together, we can iterate on web platform features that Flutter can abstract and make easy for you to use. So you can just focus on that. And also users are clamoring. So Flutter gives you a great way to ship them. And I can't wait to see because I've seen how the Flutter community always delivers on high quality.
Dion, thank you so much. It's great to have you join us. So since we announced beta support for the web, we've been focusing on some major architecture improvements that extend and optimize the web Flutter framework for the web. Perhaps the biggest thing we've been working on since the preview, as Dion mentioned, is performance, and we've been making a ton of progress. We recently switched our default web desktop browser over to a new CanvasKit renderer that combines Skia and Wasm to couple with advanced web graphics engine with the productivity and ease of use of Flutter. And we're seeing huge performance gains as a result. So I'll show you an example of this with a demo from Felix Bascher, who's a developer in Germany who's been experimenting with I can take the same demo and run multiple times simultaneously on the same machine thanks to So performance is important, but it's not the only thing that we need. A Flutter app that's running in the browser should feel like a web app. So we've been adding features to Flutter that help you use the best of it. For example, hyperlink widgets, text auto, control over address bar URLs and routing, and PWA manifests. And thirdly, we want to make Flutter web experiences feel right, whether you're a different content feeds to desktop apps. And we've added screen readers, accessibility, Windows, Mac, and Windows. I want to show you one example of the kind of app that shines really well on the web. iRobot is the company behind the popular Roomba robot, but they also have coding robots that empower the next generation of innovators. Let's take a look at their root robots.
We're trying to allow it to become the next great digital business. You just have to allow it to take on. Coding shouldn't be something just like the scientists do. It should be something everyone can do.
就不可能完全的预感。我赞成你的选择，于是看着眼泪飘飘泪
iRobot built their app with Flutter, and today they're launching the web version of their experience. So here you can see the app building in the browser using the same code as their tablet. On the left side you can see their visual code editor, which lets you drag and drop commands and flow structures that will run on the robot. And on the right hand side of the screen you can see a simulator that shows the virtual robots and actually test out the robot before it loads on the real thing. They have a whole library filled with different project elements, 3 different projects aimed at different age groups. And of course, everything you see is built with Flutter, including the simulator, the same code It's really cool to see iRobot using Flutter for education purposes. I hope you'll check it out yourself at code.irobot.com. Of course, we're using Flutter's web support ourselves. One example of the convenience most of all is our web-based Scratch web supported by Flutter and Dart code. We also use it throughout our documentation, so you can see how to work with a widget in line in your browser without first having to copy it into your app. There's so much more to say about Flutter, so we have a breakout session dedicated to this topic, where Mariam Hasnani and John Ryan walk through building and deploying a web app with Flutter. So we've already seen how important Flutter is, and the ability to go from mobile to web. And the great thing about building on open source foundations like Skia is that we can take this work further still, including 3 platforms that together reach a well in excess of 1 billion users, Windows, Mac, and Linux. Today, we're delighted to announce that we're also opening up desktop to the stable channel of Flutter, enabled with an early release firmware. This release lets you produce standalone executables for each platform like OS, Linux, and Windows. And you can even use the developer tooling provided by each platform to get apps into the store. We're excited that everyone can now run Flutter natively on their development workstation. This isn't just our work, it's been a community project. Microsoft has contributed a number of pull requests to the Flutter engine to use the latest Windows Runtime APIs when running on Windows 10. On Linux, Canonical has been a fantastic partner, and I'd like to have them tell you about some of their contributions to it.
Hello, I'm Ken Bailey, Engineering Manager for Virgin Desktop. When desktop applications were required for Mac, we saw an exciting change in Linux distribution, an attractive target platform for Flutter app developers. Flutter's native we want to get the beta. We worked with Flutter desktop to Flutter. By making Linux official as a web platform, we are inviting application developers to publish their apps to millions of Linux users and broaden their high-quality applications available to them. We not only enable Flutter for Windows, we also work with Flutter to publish Flutter SDK and Snap in the Snap Suite, the app store for Linux. By publishing Flutter SDK and Snap, it's very easy to install and set up your development environment to build mobile, web, and desktop apps for Flutter. Even with just these basics in place, we're very excited. Linux support for desktop applications is today. We continue to support Flutter for Windows, keeping in sync with other desktop platforms. That's just the start. We also want to give developers To do so, full across all the desktop platforms that Flutter supports. We are start the engineering work very soon. Of course, your plugins we are Bluetooth, network Furthermore, while enabling app developers to bring their apps to Linux desktop, we thought it would be nice to bring along the Ubuntu style as well. Ubuntu has a very distinct style, which we call the style, which is a community-led effort. We effectively illustrates material as the base and applies the Ubuntu style, covers, and fonts. This enables app developers Ubuntu style with ease. Now that we've enabled as we already announced, we are developing soon every user will be doing so with our new installer built in Flutter using the Ubuntu style. Along with the out-of-the-box experience for the license for Windows also be powered by Flutter. Choosing the installer as the first enactment is a bold move, to say the least. It's the first thing users see, and as everyone knows, first impression is critical. It not only has to be beautiful, it has to be robust and reliable. It has to run the latest hardware. User experience is very complex. With no Flutter is up for the task, and choosing it for an installer is telling the world that using Flutter for Linux apps is a great choice. The desktop tool not only builds the first class Flutter is the default choice for desktop and we look forward to working with you. Thanks.
Thanks so much, Ken. It's a really big deal for us to be able to for the very first experience users have with Ubuntu, and we're looking forward to continuing to work with them. So we've talked about how the key thing of Flutter 2 releases portability, upgrading your code to be able to run on 6 different platforms, iOS, Windows, macOS, and Linux. There are even more screens out there beyond the kind of operating system that you might have on your phone or your PC. So I'm delighted to introduce another customer who is using Flutter to bring beautiful user interfaces to light in a critical part of their own product. Toyota is the world's biggest selling automaker with over 9.5 million vehicles sold in 2020. And the cars, beautiful, tailored user experiences matter. Toyota are building Flutter right into the heart of their products. And so I want to hand over to Daniel to share more about their plans with Flutter. Hello.
Basically what that means is I'm responsible for leading the design and development for our next generation in-vehicle. Today we're excited to announce that Toyota is partnering with Flutter to bring the best in modern digital experience to vehicles by building infotainment systems powered by Flutter. Using Flutter marks a large departure from in-vehicle software. While we're not ready to share our final product just yet, we'll take a little bit of time to talk about why we chose it and how we're using it. So, why did we pick it? At Toyota, we continually evaluate Flutter immediately caught our eye. Foremost, Toyota customers expect a consistent, high-performance in-vehicle user experience to match the overall Flutter's rendering engine provides good performance in a constrained environment, and features like AOT computation give us the consistency we're looking for in an in-vehicle technology. Flutter also allows us to provide provides a fast development. The variety of tablets are useful for all sorts of physical and digital uses. We can even leverage web support as an integration to improve our feedback cycle. Of course, this developer-friendly workflow isn't just for our own benefit. Ultimate goal of using Flutter is to streamline software development, resulting in better user experience. A technology that enables high productivity and relatively low barrier to entry allows us to create a tighter overall feedback loop in design and engineering processes. These faster iteration cycles allow us to integrate feedback from our customers earlier and more often, which helps us create the best experience. We talked a little bit about why we choose Flutter. What do we do? We're starting with technology powered by the Flutter Engine's architecture makes it relatively easy to support embedding in our target environment. It's just a matter of cross-compiling the engine, grabbing it, the Embedded API is fairly easy to use and allows us to Flutter apps in systems. Additionally, we've created several in-house tools that enhance Flutter's developer experience by extending the design process, all under the same umbrella. Our overall goal is to support workflows and design flows generated so that validation of running software isn't needed. Both Dart's design and the Flutter SDK software is used. For example, Flutter's approach to develop UI and code as configuration allows us to very easily perform code generation based on designs without any complicated or confusing implementation. Most importantly, while developing these specific tools, Flutter's open source principles of high-grade development. Without the support of the large and open ecosystem, we couldn't have started Flutter. At Toyota, we see working with open source software as a positive investment towards our can't wait to share more details
by bringing together beautiful, fast user experiences with a productive development environment that lends itself to exploration and iteration, all delivered as free open source with less than nothing overnight. Let's now go one level deeper and talk about Dart's client optimization for advanced apps on any platform. What does Dart matter? Well, Dart provides a unique set of capabilities for building apps. For starters, as you've seen already, Dart is portable, built pilots that generate highly performant Intel as well as highly optimized JavaScript. The same Flutter framework source code compiles to all of these targets. Secondly, Dart enables iterative development with stateful on desktop and mobile, as well as language constructs designed for asynchronous concurrent parenting. And thirdly, Dart offers Google class performance across all of these platforms, with sound internal safety guaranteeing non-experience at runtime as well as development. There really is no other language that combines all three of these components together, and this is the reason why we often talk about Dart as the secret sauce behind it. Now, we've not been standing still with Dart, so we've gone out to the links to some of the work we've been doing in Dart to upgrade your Dart.
Thanks, Tim. I'm very happy to tell you that we have shipped so now the type system helps you. This is the biggest change to Dart since we added With null safety, we didn't just add type system, we also added a string of functions, flow analysis, late variables, and parameters. So your Dart code isn't just safe, but easy to write. The changes are so big, the only reason we aren't calling this release Dart 3 is because we managed to ship null safety. Instead, we allow null safety to coexist with unsafe. Plus, we migrate the null safety and we provide automated
program is fully migrated, the type system guarantees, like a mathematical proof, that no non-nullable expression will ever be lost. This guarantee is great for complex code, but it's even more valuable. Chips are so complex that it's compiler optimization is often about detecting some operators and eliminating it. That optimization is only safe in the form if the compiler can prove that the operations are needed. Sound null safe is the getAge function simply returns the value of the Here's the assembly code of the Here's what you get today with the Since the field's type is not no need to check the null. The generated code simply acts our attendance function. That's a small change, but real programs can be thousands of pages. Eliminating less code downloaded and of course, working on Dart is just about efficiency determines the value of what is possible. Rewrote their flagship app. So much that they started hitting the wall inside the application. So we worked to unblock them so that they could use Flutter's file size, which got their app 14% smaller than it was. Dart's internal string representation. We found out that UTF-8 could be modeled Nesca on the VM team, rewrote our decoder, and operating parts of times faster. When you want to access features, you need some kind of Flutter long tags synchronous way to call it. Null safety out the door, we get to turn towards the next batch. One area we're exploring to give you a feel for how we would do it. Whenever I talk to you about all three reports they have are non-nullable types and we have the first two rules. With the data class, you define a type with a set of fields, and then the language gives you a constructor following it's essentially baked in. The problem is that they all years from now, users decide that persistent data structures we can end up with dead weight language features. How do we enable the Dart user to listen to add data classes to themselves? What I'm talking about here is metaprogramming. Code that produces output. Metaprogramming is already common in Dart already run Dart code to generate another Dart. The code generators can feel heavy weight bolted on. So we're exploring adding static metaprogramming features directly. The goal is to enable frameworks that eliminate some of the verbose code we optimize today. I love the metaprogramming feature expressing it. Now we don't know what's happening. Fast language is no use. So next, Kenzie's going to talk about.
Thanks, Bob. Hi everyone, I'm Kenzie from the Flutter team, and today I'll share 4 new tooling highlights from the Flutter team. The first new feature we'll look at is what we call Flutter Fits. As part of Flutter 2, we've done a lot of work on consistency and tidying up the framework to make our APIs more approachable and to make real code clear. Now I know what you're thinking. Framework improvements are great and bring all sorts of new and improved functionality to you, but usually they also come with some breaking changes to your code. But fear not, because what we've also done as part of Flutter 2 is create a tool called Flutter Fix that does all the heavy lifting for you. For example, I have a budget tracker project we open in IntelliJ, and this is a sample app that hasn't been updated in a couple of years yet. So now that I updated to Flutter 2, there are some analysis errors to address. You can see that it's using a couple deprecated APIs. So let's click on one of these warnings and see how we can solve the problem. I can see the deprecated member here as well as the quick fix icon. And the quick fix option allows me to automatically migrate my code to the new API. So now I can see my code has been updated and the warnings we've added quick fix tools just like this one all throughout Flutter. And as we move forward with new breaking changes and feature versions, we'll add new quick fixes to help you manage. Quick fix helps us keep the API fresh without breaking your code, so give it a try. And now that we've moved our budget tracker to Flutter 2, let's move on to the second feature I'll be showing off today, null safety. To do this, we'll fire up the null safety migration tool with the Dart migrate command. Right now, my code is in a state where null safety is not enabled, but the migration tool will enable Dart null safety and help me migrate my code so that it's compatible with the null safe runtime. So I'll open the tool. And this tool analyzes our code to determine what can be non-null and what should be null. And from this, the analysis tool displays suggested changes with the explanation for those changes. So in our case, all looks good to me, and I'm just going to go ahead and accept the changes and apply this migration. So if I come back into my code, I can see that my code has been updated to null safety. And now that we've migrated our code to null safety, we can still use nullable types, but by default, our object references will not be nullable, eliminating a whole class of bugs from our app, making our app smaller, faster, and more messy. And that's just the tip of the iceberg on null safety on Dart and on the migration tool. So check out the null safety deep dive to learn more. For the third tool we highlighted today, I'm going to show you some new Flutter debugging tools. So let's do a little bit of work on the budget tracker app. I'll get it running here next to IntelliJ. But I want to make sure that everything looks good also in landscape mode. Oh, and it does look. So it looks like we have an exception here in the run console. And I can see that a render flex overflowed by 282 pixels on the bottom. Now, looking at this error output, I can actually directly navigate to the error-causing widget in my code. But that's not as helpful as we'd like, because what I'd really like to be able to do is go directly from an error message to inspecting that widget in Flutter DevTools. But luckily, we have created a new feature that allows me to do exactly this. So when an overflow error occurs, your IDE will show you a message in the bottom right window of your screen. This message expresses the error code, as well as giving you the option to inspect the error-causing widget in the Flutter DevTools inspector. So let's do that. This opens up the Flutter inspector directly selected to the error-causing widget, and moreover, we can see this directly in our IDE. Using the inspector in the past would have required you to open DevTools in your browser, but now we've actually embedded DevTools directly in your IDE. So whether you're using Xcode, IntelliJ, or Android Studio, you'll always have access to this powerful tool that gives you insights into your running Flutter app. So let's get back to the prompt and use the layout explorer to solve this issue. I can see that I have some unconstrained heights here. So let's fiddle with the flex values in the layout explorer to see how and now I know that the single child scroll wheel was just missing a flex value of 1. And that means it needs to be wrapped in a flexible widget. So what I will do is come over here and wrap this single child scroll wheel using a flexible widget. So now I have a flex value of 1. And if I come into the run console here and do a hot reload, I can see that there are no more exceptions and the issue is resolved. Over time, we'll be adding similar functionality for other common errors to make it easier for you to solve problem solution using Flutter DevTools, all without leaving your IDE. And last but not least in our tool highlights, I'm going to show you some new features in Flutter DevTools. I've already shown you the inspector command embedded in the IDE, but you can also open DevTools in the browser, where you'll not only have access to the inspector, but also more sophisticated debugging tools for things like performance, memory, and more. Some of this new functionality is available in the Layout Explorer itself. On popular demand, we have added the ability to show a visual representation of fixed layout details in the Layout Explorer, in addition to the flex layouts we already support. So now we can meet our layout issues for all kinds of layouts. We've also added an app size debugging tool. So let's see this in action with the Budget Tracker app. I have already We can use this tree map in the tree table below to explore our app size and visualize the space occupied by different classes and libraries. Looking at the overview of my app, the assets are a little concerning. I only use one image in this application called Headshot, and it's rendered as a really small avatar. But I can see here it's taking up 1.6 megabytes of space, which seems like way too much for such a small image. So now I can revisit my assets and optimize the image or use a smaller version, and then I can verify the improvements using the app size. But unfortunately, that is all the time we have, so be sure to check out the Flutter Team Alpha post to see all the highlights of this upgrade with the latest Flutter 2. Thanks for tuning in. Back to you, Tim.
Thanks, Kenzie. Our developer tools are another example of the unique flexibility of Flutter, built with Flutter, for Flutter, and integrated into whatever tool you're running. For those of you who want to hear more about how Null safety works and how to migrate your apps to Null safety, check out the breakout session. Okay, so we've seen how Flutter 2 expands Flutter from mobile to web, desktop, and embedded devices. We talked about the secret that provides Flutter portable, productive language with features such as sound null safety. The Flutter ecosystem is much broader than just what we provide. In fact, there are over 15,000 packages now for Flutter and Dart from big companies like Amazon, Microsoft, Adobe, Huawei, Apple, eBay, and Square, to packages like Kotlin, SQLite, and SVG, as well as individual developers like you and me, who are packaging up useful functionality for us to use. One great example of a useful package is from Sentry, who are publishing a major update to their Flutter SDK for their popular crash management and release tool. This package provides tools to help developers ensure their app is healthy on all their target platforms, offering deep insights into exceptions and crashes, whether they occur in We're also today announcing a major update to our Flutter plugins and several more Firebase services. Authentication, Firestore, Cloud Functions, Cloud Messaging, Cloud Storage, and Crashing Tests. We've updated all these packages to support SAML and null safety, and we've overhauled the Cloud Messaging package in particular. But there's another major package we're releasing today, and I want to hand over to Zoe Fan to tell you about it.
Thanks, Tim. Hello, everyone. My name is Zoe. I am a product manager on the Flutter team. There are many ways that mobile developers can please when their work. Monetizing ads by ads is probably one of the most popular problems for many mobile developers. Today, we talk about ads such as overlay banner, interstitial, and rewarding video ads. However, many developers have been asking us, where is inline banner? Where is native ad? It is important to create a beautiful, seamless user experience. Developers want to display ads as part of their content in an existing Flutter view and customize it to match the look and feel of the ad. Therefore, today, we're excited to announce an open beta for the Google Mobile Ads SDK for Flutter. This is a brand new plugin that provides inline banner and native ads in addition to existing Google formats. Also, in this plugin, we're unifying the support for ad ads. So regardless of what size publisher you are, this plugin is able to tailor to your scenarios. We've been piloting this plugin with some of our early customers in a private beta program, and many of them have successfully launched their apps for these new formats. Swan Musica is one of them. Today, it is our great pleasure to have Alan, the CTO of Swan Musica, to share his experience with us all. Let's welcome Alan.
As Zoe told you, I'm the CTO of Swan Musica.